first chapter, which is physics, and in the class 11 physics first chapter, you will be faced the unit and measurement. So what is measurement? So you can see there the international system of units. Earlier, different system of units were used in different countries. CGS, FPS, MKS. CGS means centimeter, grams, and second. FPS means foot, pound, second, and MKS meter, kilogram, and second. So that kinds of thing you can just imagine like that. If any physical quantity, you can be get their unit with the help of three main parameters according to their length, according to their mass, and according to time. So all kinds of physical quantity like force, stress, pressure, volume, these total quantities, their units are totally combination of three major parameters of the units, which are centimeter, which is showing according to length, mass, which is whose unit is gram, or you can say kg, and third one is second. So as an international purpose, for a different countries, every physical quantity having some different parameter of length, mass, and time. So according to CGS method, length could be measured in the centimeter, mass is measured by the gram, and time is measured as a second. But if I look about the FPS process, so length could be measured as a foot, or mass could be measured as a pound, and time can be measured as a second. And for MKS, you can say phenomena of measurement of the units, length could be measured as a meter, and mass is measuring as a kilogram, and second is measuring in the second. So main thing is that this CGS and FPS method we are not using in the generalized way. These are using in the different countries. Main our complete class 11 physics, we are using our MKS process to writing the any you can say units of any physical quantity, which is along meter, kilogram, and second. If I give you a particular example regarding to this measurement, so I can say that you have already know about the force. So force can be written as M into A. What's the unit of force? So most of the students will reply Newton. But if I ask you what is the unit of force in terms of centimeter, gram, and second, so you will be reply as a MKS process. We are deriving the unit of force is meter, kg, and what is the unit of acceleration? Meter per second square. So with the combination of this unit, we can say that the force unit in the MKS process will be meter square, kg, and second inverse square. So that is the unit of force in terms of mass, length, and you can say time. So that is the famous unit, MKS unit we are using generally in the physics. With the you can say length could be measured as a meter, kilogram, mass is the measure as a kilogram, and time is the measure as a second. So these kinds of things we are using in the MKS process. Now next thing which you can see, the second point is that to bring uniformly the SI system was adopted internationally. SI system means system international D units, which means it is the normal international unit, so that we can measure every kinds of unit according to SI system. Because main thing is that in different countries, the measurement scale are over different. For example, if I talk about the temperature, so temperature in our country is measured as a majorly Celsius per Celsius, okay? But if I talk about different countries like France and you can say other Spain, their temperature measuring scale are Fahrenheit. So that was a different. And third unit, you can say temperature we can be measured as a Kelvin. Whenever you are solving in the class 11 chapter like gaseous state and thermodynamics problem, then you can see that temperature we are using as a delta T as a Kelvin form. That was a different unit of you can say temperature. So SI unit, or you can say SI system mainly refers to you say that was the common unit. You can say that was the common system to measuring the physical quantity units, so that every country can understood. So that SI system is called Systems International of D units. Got it? So fourth point is saying SI is the present globally accepted system for scientific, technical, industrial, and commercial measurement. So that is the, again, I was saying same kinds of thing. This SI system present globally accepted, which means every country can be accepted this SI systems unit measurement in terms of scientific, technical industries, and always industrial and commercial measurement also. If I talk about the length we are measuring as a meter. in our country we are measuring as a meter, but sometimes can also measure their height, which is according to their length. They are using foot. So foot is not commonly used in everywhere. So such units which are we can use in every country with a globally, that kinds of system by which we can use our common unit in every country, that system is called SI system. So this system is mainly used to give a common understanding about the units so that every country can be accepted. Again, third point is saying about the unit system is that the SI uses the decimal system, so conversion or simple and convenient. SI system is very simple for the conversion as well as you can say for understanding. If I talk about the fit, if I ask you what is 1/5, so in 1/5 you can assume that 2.54 centimeter containing. So for conversion in feet to centimeter, centimeter to feet, that could be very complex for the calculation. But according to SI system, we are using meter, kilogram, and second. So with the help of these three units, we can easily convert length into the another thing. Kilogram or also convert to the other system also. For example, if I talk about in 1 meter, how much centimeter are containing? So you can say 100 centimeter are in the 1 meter length. For what if I ask you in 1 centimeter, how much meter is present? Then you will be divided by 1 upon 100, and then you will get 1 centimeter equals to 0.01 meter. So that was the easy concept to understand how can you convert unit first to other. So SI units mainly used to classify very easily to conversion of one unit to the other unit. So that is the three types of units which we can measure in different country: CGS, FPS, and MKS. MKS is the very famous unit which we can be acceptable in every countries. And this SI system, whenever we are using this kinds of three unit, will be acceptable to the globally. Okay, in terms of every field like technical, scientific research, industrial, commercial use, every kinds of thing we can be measured with the help of MKS, yeah, SI uses system. Okay, so that was the first thing. So main thing is that SI base units. What kinds of SI base units we are using? So mainly the system 7 base quantities and 7 bases units. So we have 7 base, or you can say perfectly units, or you can say physical quantity on which their SI units are, you can say, converted. Every kinds of physical quantity, you can say, like force, pressure, temperature, current, or you can say flux, every kinds of thing, every units are totally made up from these 7 types of units, which are mainly said. The SI system has 7 base quantity and 7 base units. First one is length, second one is mass, third one is time. That was the 3 for major component, but another component which are including of this in the 7 base quantity, which is electric current, thermodynamic temperature Kelvin, amount of substance any mole, and luminous intensity like candela. Candela, it's not most commonly used in your syllabus. Mainly we have seen in your totally class 11 physics, or you can say 12 physics: length, mass, and time, electric current, thermodynamic, and amount of substance. So every units inside your, you can say, physical quantity are totally based upon these 7 parameters, or you can say these 7 quantities. These are fundamental 7 quantities on which every physical quantity units are made up. So if I talk about pressure, so pressure, you can assume that P equals to force of perpendicular upon area. So if I ask you what is the unit of this pressure, then firstly you will be reply as a normal unit is Pascal. But what if I ask you what is the unit of pressure in terms of SI units? In terms of SI unit, what is the unit of pressure? So you will be right, firstly unit of the pressure, unit of the force. So you will be right kg, meter square, and second inverse upon, you will be right area of unit is the meter square. So meter square will be cancelled, then you will be right the pressure unit in the SI form will be kg second, so second power -2. So you can be derived with the help of, you can say, these 7 SI units. As a, you can say, you can find any kinds of physical quantity. If I ask you what is the unit of electric charge? Electric charge in SI form. So firstly, whenever you are finding some physical quantity in this, firstly you have to understand their formulas. Okay, every relatable formula which you are getting inside your mind, that will be helpful to finding the you can say units of any physical quantity. For example, uh, any physical quantity on which charge q can be present, so you can assume that force between two electrical charge, which is electrostatic force, then you can see that the force between charge will be k q1 q2 upon r square. So the finding the unit of this charge q, you can also use this formula. Otherwise you can also use I equals to charge upon time. It is the definition of electric current, which is very, you can say, easy to find unit of charge in terms of SI units. SI unit means which can be contain these 7 parameters. Maybe this 7 parameters: electric current, thermodynamics, amount of substance like mole, length, mass, and time, and last one is candela. So if I use this formula, you can see that the unit of you can say electric current, that is ampere, and the time is the unit is second. So the charge unit will becomes in the SI form will be ampere multiplied by second. So that is the again unit of SI, unit of charge. So with the help of these seven SI base units, or you can say 7 quantities, you can easily find any units of any physical quantity. You just understand their formula. You just understand their this 7, you can say, units. Yeah, you can say 7 quantities about their units. Length unit we are using meter. Mass unit we are using kilogram. Time unit we can use as second. Electric current unit we are using ampere. Thermodynamic temperature units we are using Kelvin, and amount of substance units is the mole. So every physical quantity units is the combination of these 7 quantities. Got it? Anyone who have any doubt? Okay, anyone who have any doubt? Let's understand this phenomena with the help of this question. Now the question is says the length, width, and height of a block are measured as 5.2 centimeter, 3.10 centimeter, and 2.0 centimeter respectively. Calculate the volume of the block with the current significant number. Okay, you have to find volume of the block with the correct significant number. How can you find? So firstly, you have already given that length and width and height. So if these 3 parameters are totally different, then we can assume that it is the cuboid. Got it? And what if I ask you, we have to find, you can say, volume of cuboid. How will you find? How will you find volume of cuboid? So firstly, the length is given as 5.2 centimeter. That is the length is 5.2 centimeter. And again, width is already given 3.10 centimeter. And the height is given as 2 centimeter. Okay. So you have to find volume with the correct significant figures. Correct significant figure I will explain you in the earlier. Firstly, we have to find volume. Then I will explain about significant figure. Okay. So what will be the volume? So everyone knows about that. The volume of cuboid will be, volume of cuboid is what? Kindly reply. The volume of cuboid is length multiplied by width multiplied by height. Okay, so length you will be already given 5.2 multiplied by 3.10 and multiplied by 2.0. You can assume that one length having 2 decimal points, one length having 2 decimal digits. So to find the correct significant figure answer, you have to consider following two quantities in the, you can say, which having two decimal digit according to width. Okay, you can also assume that you can also convert you can say that if 2 digit having 1 decimal digit, then you can say that this width can also be in the 1 digit, 1 decimal digit. So firstly we can assume that we are converting this to length and height into, you can say, 2 decimal digit. So what will you write? You can assume that if length is given 5.2 centimeter, then you can assume as a 0. at the behind it. Okay, so that is becomes as 2 digit of decimal. Similarly, width is also already given as a 3.10 centimeter, and height is also given as 2.0. So to assuming as a 2 digit as a decimal, then you can also assume as a 0 behind it. Now multiply this, you can say, now multiply this all kinds of parameter, length, width, and height will give you the volume. So volume you will be right. You can see that every multiplication is totally same. 32.24, 32.2, 32 centimeter cube, and 32.240. So main thing is that multiplication we are not needed. So what we have needed? We have to need about their decimal points. Decimal points. So if I am writing, you can say, volume of this, if I'm doing calculation of this volume and every significant digit are present after 2 decimal, then volume answer will be get with the help of 2 decimal units. Okay, so in which option which is saying 2 decimal units of the volume, because multiplication is same, 32.24, 32.2, and again it can be written as 0, and again fix 32 centimeter cube will be correctly right whenever no decimal digit are not present. Okay, so if 2 decimal units are present of every parameter, then volume will be you will be get after 2 volume will be you will get containing 2 decimal units. So which option which has having 2 decimal units volume, which is option A. So correct answer is option A. So according to this question, what we have understood, main thing which we have understood is that whenever we are finding some physical quantity with correct significant figure, then firstly let's understood that the parameter which is already given, with the help of we can finding the third quantity. Okay, so the parameter should have equal decimal digit. Equal decimal digit means every every parameter does contain same decimal digit, like 1, 2, 3, every parameter. So in this question, 5.2 having 1 decimal digit, 3.10 having 2 decimal digit, 2.0 having 1 decimal digit. So we need to understand that firstly we have to assume 2 decimal digit of every parameter. That could be 5.2 can be written as 5.20, 3.10 can be written as 3.10, and 2.0 can be written as 2.00. And after multiplication of this, your answer will be come back into the, you can say, this fixed 2 decimal unit answer. So question, the answer is option A will be the correct answer. Got it? Now let's understand third thing. How can you find dimension of any physical quantity? If I ask you, whenever you are finding the dimension is what? Dimension is the every unit, every physical quantities units can be written as a mass, length, and timing. Time period, every physical unit can be written as a value of m matlab mass, L matlab length, and T means time period. So we can be written as a form of every physical quantity unit. Let's say physical quantity is Q. Its unit we can be measure as m to power A, length to power B, and T to power C. It depends upon physical quantity what will be the value of A, B, and C. And how can we write this type of dimension formula? That is the dimension formula, so that we can be write any physical quantities dimension with the help of M, L, and T. How can you write? So we have a question. Force into velocity upon time, that is the quantity C. Quantity Q, which has a formula, is force multiplied by velocity upon time. So I am writing formula of this quantity is force divided by velocity. Sorry, not division. It is force multiplied by velocity divided upon time. So we have to write dimension formula about it. So firstly, can you know about their basic, you can say, formula? Force can be written as, you can say, M into A. Can I write like this? Okay. Or can I write velocity as a distance, D upon time? Okay, we can also write. And time is also multiplication. So here is the acceleration. Acceleration is what? Acceleration is the change in velocity. Acceleration is the change in velocity per time. So can I write m multiplied by change in velocity? You can write delta v divided by distance upon time multiplied by time. Here is the normal formula, so that you can easily find out the dimension formula regarding to this quantity. So delta v, it is also called as a velocity. So velocity I can also again write m multiply by velocity's formula again distance upon time, and these two quantity are time into time, which is already same, and d multiplied by d. Now this total physical quantity has converted into mass, length and time form. Now convert into the m, l and t form. So m means mass, l means you can say length, t means time, and abc are the powers according to the formula. So quantities, physical quantities formula you will be get m multiplied by distance square and d square upon time cube. So you will be right, mass is the capital M and mass power having power 1. So capital M1, and distance is what? L, and L distance having power 2, which means you will be right L power 2. And again time having in the denominator, so their power will be negative. And if their power is negative, the time power you will be right T minus 3. Now look at this dimension formula, which one option having the correct answer regarding to this. So you can see that option A is showing M L2 T minus 3. M L2 T minus 3, that is my correct dimension formula of quantity Q. Everyone understood? What is the problem statement? Everyone who have any doubt, he and she kindly ask me. I can also repeat if anyone have any doubt regarding to this. Vinayak Mohanvi is saying option 2. Option 2 for what? Option 2 for what? Okay, kindly reply. What option you are showing? Second question. Okay, second question's answer will be option 2. It must be right. Okay, let's look like this. M L2 T minus 4. M L2 T minus 4. How is it possible? Okay. Sorry. Distance upon time. dv by dt. Meter per second square. Sorry. Acceleration unit is meter per second square. Okay. Second square means L upon T square. So I will be write again two values of T. Got it? So you will be written as again new value of T. Again, it is also written as T. So, okay. You will be get T power minus 4. Okay. Because I have written acceleration as a distance upon time. That was wrong. Because acceleration is showing to you rate of change of velocity with respect to time. So you will be right dv upon dt. So time is already present in the denominator form of the dv. Okay. And velocity I can also write distance upon time. And time is also present in front of this t2 also. So this 2t comes with the help of this acceleration. So no. Option B will be the correct answer. Sorry, it was a silly mistake. Is it understand? Okay. If you are giving the correct answer, that means you are active in the class. Okay. Now again, we have the third question. The time period T of a simple pendulum depends on the length L and acceleration due to gravity G. During dimension analysis, the relation is the time period. Okay. We have to find the time period. Which one formula is correct? T is directly proportional to under L upon G. T is directly proportional to under G by L. T is directly proportional to L upon G, and T is directly proportional to G by L. So main thing, if you can answer this question with the help of direct formula. If you know the direct formula time period of the simple pendulum, then you can find the direct answer regarding to this. If you does not know about the formula, then you can assume about there with the help of option. If I am writing L upon G, L is what? L is the length, and G is what? G is the gravitational acceleration. So acceleration unit is also meter per second square. Can I write? So time period I am getting as the ratio of L upon G. That means the total answer of their units after doing some calculation. If this unit answer I am getting the value, I am getting the unit as a equivalent to the time unit, that is the second, then I can say that this expression will be right. So time period formula can be written as a, you can say L upon G, G by L. It could be any power, it could be any kinds of power. Okay. So you need to understand what is the actual expression regarding to time period. How will you write? So let's check. option by option. Firstly, you have to write L upon G ratio. What is the L upon G ratio? At L is the length, that is meter, and G is the gravitational acceleration. Acceleration unit is meter per second square. Can I write meter per second square? So meter per second square I can also write. So second square will become to the, you can say, numerator. Okay. So meter multiplied by second square divided upon meter. So meter to meter will be cancel out. L upon G ratio you are getting second square. But you have to find in time period value. So to getting the time period units, it should have a square root value. It should have square root value. So if this expression having square root value, then time period unit you will be get L upon G ratio will give you the second unit, which is the time period. So L upon G should be have square root value, that will be under root L upon G. So which one option is giving the correct answer? Option B is saying under root G by L. No, that is the wrong answer. L upon G gives second square unit. That was also wrong answer. G by L, GL. GL will give you some different unit, not give the second unit. So that is also wrong. So the correct answer is option A. Time period will directly proportional to under root L upon G. So is it understand? Everyone understood what is the how answer has come? Okay. Okay. Now next question I will give you to yours. Firstly, answer to your by yourself. If most of the students are giving correct answer, then we can continue with our next question. If someone are failing to give the correct answer, we will solve it together. Okay. Okay. So let's discuss about next thing regarding to this. So we have a fourth question which we have given. Measurement is given as 2.50 plus minus 0.05 centimeter. The percentage error in the measurement is given as. So what is the percentage error? How can you find the answer? Everyone, kindly solve by yourself and give me the response in the chat board. I can give you only 1 minute. Let's solve it together. After that, we will solve it together. The measurement is given as length having measurement 2.50 plus minus 0.05 centimeter. Okay, the percentage error in the measurement. So main thing is that the question mainly saying is that look at here. I have a pen, and the pen I am measuring their length with the help of scale that will give you the correct measurement. But what if I tell you have to measure your, you can say, pen with the help of your brain, just assumption. You have to give me your assumption length. So you are giving that the length could be 2.55 or you can say 2.57, but exact length is 2.50. So extra length which are you giving by your brain, that was your error, that was your incorrectness. So according to question, the measurement is given as 2.50 plus minus 0.05. That could be, you can answer large as a 0.05 centimeter, or you can say you can reduce 0.05 length. That was your error by your brain. So you have to find what is your percentage error in the measurement. Okay. How can you answer this question? Anyone who have solved this problem, kindly give reply. Okay. Some students are replying. B. Okay. Someone, one student is asking, Vinayak Manvi. Once again, sir, previous question. Okay. Let's move with the previous question. So mainly previous question, you're already given this time period of the simple pendulum depends on length and acceleration due to gravity. Question already showing to you that the time period of the, you can say, pendulum is depending upon your pendulum wire length and gravitational acceleration. Time period pendulum is what? That is the time period pendulum. If I tied you can say bob with this particular string of, or you can say particular thread, then if I oscillate this while according to like this the, you can say, phenomena, then that is the called time period of the simple pendulum, or you can say that is the simple pendulum. Okay, so time period of the simple pendulum according to our calculation, according to the question, is depending upon length and G. And according to question, all of this option mainly showing the L upon G ratio. So you have to know about the time period mainly depends upon L upon G. You just assume. Okay, so the length, it is the length, and it is the gravitational acceleration. Acceleration means its unit could be meter per second square. Okay, and what is the unit of length? Length is the meter. So you just write L upon G with their units. L unit is meter, gravitational acceleration unit is meter per second square. Now let's solve this calculation. So time period unit, you will be get meter upon meter. This second square comes to the numerator. Got it? So m to m will be cancelled out. If this calculation give you the exact value of time periods unit, which means your L upon G assumption is right. And if it is giving some different answer, then you have to use your brain and identify what should I do. That's why time period unit can become as a same answer. Okay. So according to this calculation, time period units you are getting second square. That was the wrong, because time period unit is the second. Then how will you convert into the second unit? If this expression having square root value, then time period comes to the second. Okay. And how second square I have got? With the ratio of L upon G. Okay. So to find in the time period accurate unit, I have to understand that this unit could be a square root value, which is under L upon G. So overall, I can say the time period will directly proportional to square root value of L upon G. And which option giving the right answer, which is option A, time period directly proportional to L upon G. Understood? Understood? Vinayak Manvi, did you understood what is? Okay. Okay, so next question, most of the students are replying option B, option B, option B. Okay, no problem. Let's solve it together. So the percentage error, whenever you are finding the percentage error, how can you find? So firstly, you have to understood about the error phenomena. Error phenomena, mainly you are saying that if you have a particular wire, let's say whose length is, you can say, I don't know what is the length. I'm just assuming that is the 5 centimeter. I just write that is the length is 5 centimeter. Is it really 5 centimeter length? No, because I did not measure this wire length with the help of scale. So it could be, let's say actual length of this, you can say diagram length will be, you can say 3 centimeter. So the 5 centimeter which I writing in front of you, that could be wrong. Yeah, but it could be slightly correct because it is nearest to the 3 centimeter. So what is the extra error? The measurement of a given measurement of the length we have given 2.50 plus minus 0.05 centimeter. The percentage error in the measurement. You have to finding percentage error whenever any physical quantity measurement you have already given. So according to this question, length is already given. You have to find percentage error. Okay, this is the measurement of length. So to finding the percentage error, you just use your direct formula, which is change in physical quantity. Physical quantity upon actual measurement multiplied by 100. So that is your percentage error. Okay. So firstly, change in physical quantity is what? Change in physical quantity means your error which you are doing. According to my previous example, actual temperature is 100 degrees Celsius, but I am giving you 50 degrees Celsius. That was my wrong statement. How much I am doing wrong? Because you just give me, sir, 50 degree less. 50 degree less is what? Change in physical quantity. Change in physical quantity means change in temperature, which I am giving you. Okay. So the percentage error of this phenomena will be change in temperature, that will be 50 degrees Celsius divided by actual temperature, which is 100 multiplied by so. So with the help of this thing, you can find percentage error in this question. Okay. Now the question is saying we have given percentage length measurement, which is 2.50 plus minus 0.05. So delta L you have given 0.05 divided by actual length, that will be 2.50 and multiply by 100. So the percentage error you will be get 5 upon 250. 10 to 10 cancelled. 5 ones are 5. 5 5s are 5 5s are what? 5 5s are 25. 5 ones are 5. 5 2s are, you can say 10. So overall percentage error you will be get 2%. Got it? Which one option is correct? Option B is correct. Everyone understood what is the problem is saying and how solution I have written? Everyone who have any doubt regarding to the solution, he and she can ask me. Any doubt regarding to this question? Kindly reply on the chat so that I can be identified. Okay. Okay, nobody has any doubt. Okay. Okay, let's solve with the next thing. Rounding of digit. If the digit to be dropped is more than 5, increase the previous digit by 1. Okay. If the digit is dropped is less than 5, leave the previous digit unchanged. Okay. Okay. If the digit to be dropped is exactly 5, if previous digit is even, leave it unchanged. If previous digit is odd, increase by it by 1. In long calculation, keep one extra digit in intermediate steps and round off only at the end. So mainly round off is what? Round off is the approximation value whenever you are doing your calculation. For an example, what if I give you, if you having g acceleration value is 9.8, got it? 9.8 meter per second square. So sometimes we can assume that 9.8 is close to the 10. 9.8 is the close to the 10. That means sometimes we are assuming 10 meter per second square. So overall, we can say whenever you are using the approximate value, nearest digit, round of digit, whenever you are using round of digit, our calculation becomes easy. If our calculation becomes easy, then your final answer is slightly different than our actual correct answer. That could be, you can say, possible in your physical calculation. It is allowable, it is allowed in your answer also. Okay, so the round of digit writing, we have some particular rules so that we can find round off of any kinds of number. Okay, during the calculation also. So first rule is saying if the digit to be dropped is more than 5, it's more than 5, increase the previous digit by 1, which is telling to you that, let's say, according to this example, gravitational acceleration is written as 9.8 meter per second square. Look at this particular digit. At the decimal form, decimal has increases more than 5. Decimal is more than 5. It is also more than 5. If I have 9.5 and 9.8, then that is the more than, decimal has increased by 0.3 from 0.5. So according to first rule, you can see that you have to add +1 in this term, and that last term will become 0. That means it is nearest to the 10, like this, 10.0 meter per second square. So overall, the first rule mainly saying is that if you are having some particular digit which have decimal unit having, you can say 0.5 more, then you can see that you just close to the nearest next digit. You can just move to the nearest to the next digit. So 9.8 close to the 10 meter per second square. So I have write 10 meter per second square. That is first law is saying. Okay. Second rule is saying if the digit to be dropped is less than 5, so leave the previous digit unchanged. Leave the previous digit unchanged. That means it's saying if I write the gravitational acceleration to be written as 9.45 meter per second square. Okay. And gravitational acceleration I can also written as 9.8 meter per second square. So according to my previous rule, it is more than 0.5 digit. So it is more than 0.5. So you will be write 10 meter per second square. So, and if I write g equals to, look at this along again, second digit, you can say value, you can see that the digit having two value and it is less than 0.50. If it is having less than 0.50, then according to second rule, it is directly saying to you that you can't go to the round off value. You can't go to the next digit because it is less than 0.5. So if it is less than 0.5, then you will be right similar like this, 9.45 meter per second square. That will be unchanged. Got it? So that is the second rule is saying. If the digit to be dropped is exactly 5, then we have two more possibility. If previous digit even, then let unchanged. And if the previous digit is odd, increase it by 1. So mainly it's saying if I have written, let's say length, I have written 1.5. Okay. If now question is saying, if you have digit to be dropped is exactly 5, if you have a perfectly 0.5 decimal unit, if you have a 0.5 decimal digit, then we have two cases. If your next previous digit is even, then leave it unchanged. If previous digit is odd, then increased by 1. So previous digit is odd, then you will be increased by 1. That will be 2.5. Not 2.5, that will be becomes 2. And if it is even, so you can say if I am writing 2.5 and 2 is the even number and 0.5 is the exactly decimal value, then L will be unchanged. You will be write 2.5 exact value in your questions. Okay, so in long calculation, keep one extra digit in intermediate steps and round off only at the end. So in your long calculation, you just assume that if you can say just like this calculation, question is already given as you have long calculation regarding to this. You can see you are writing mg cos theta minus g sin theta. That kinds of calculation you are writing. Okay, that is the long calculation which you are doing. So whenever you are using 9.8, it will be very very difficult to giving your correct answer. But if you write g equals to 10 meter per second square, then your calculation becomes easy. But main thing is that you are increasing 0.2 digit. You are increasing slightly. Then after calculation, your final answer you will be considered as a lesser value because you are increased 0.2, then your answer also increased by some value. So to getting the current answer, you can assume that my final answer could be lesser from my assumption. Got it? Because you have already increased this value. So long calculation, fourth point is mainly saying to you, keep it of your mind what kinds of thing you are assuming. If you are assuming extra digit, then answer you are getting into some extra value. And if you're assuming you can say some lesser value, let's say 9.8, I am assuming that 9. So my final answer will also reduce by some value. So you can your correctness, you will be say my final answer could be more than from my assumption. So that concept you have to remember whenever you are doing calculation of round off. Okay. So these kinds of 4 rules so that you can understand how can you find round off digit of any number. Got it? Okay, let's solve some question. Okay, so the question is saying the result of calculation comes out to be 5.67849. If the answer is to be reported up to 4 significant figure, what should be the final value? Okay, so answer we have get 5.67849. You have to identify round off value. Okay, so significant figure it is showing 4 significant. So 4 significant figure is showing, which means 1, 2, 3, 4. These are 4 significant figure. So you have to consider this round off value regarding to this. Okay, how will you write? How will you write? Anyone who have an idea? Firstly, solve by yourself. After that, I will answer. Kindly solve this problem. Sir, please, off camera is getting space, my phone screen small. Okay, should I off my camera? Sorry to say, but I can't off my camera. Okay, okay, most of the students are replying option A. What about others? It's okay, sir. Yeah, because according to class, I can't off my camera. Sorry. Okay. So most of the students are replying option A is the correct answer. Option A, option A, option A. Okay, I think everyone have solved this problem. So should I solve this problem in front of you if everyone are getting correct answer? Should I solve this problem? Okay, so most of the students are replying, okay, sir, let's solve this problem. Yes, sir. Yes, for confirmation. Should I solve this problem? Okay, okay. I think I should solve this problem. No problem. Okay, so the mainly significant figure, I have to write the correct answer accordingly. So I have already told you that 5.67849. Okay, so can I say if I want 4 significant digit, which could be 1, 2, 3, 4, it could be lie in between 4. So I have to write my answer in the 4 significant digit. Okay, so 1, 2, 3, 4, that is my 4 significant digit. So it could be written as 5.678, and also it could be written as 5.679. It can also be written at 5.679. Which one option is correct? So to getting the correct answer, you have to identify how can you write your round off value. So let's move to your rules. So rule mainly is saying mainly 8 is changing to 9. It could be changed or it could be unchanged or changed. How it could be changed? How could be it's changed into the next digit? So according to my previous slide, I already told you that digit could be changed whenever the previous digit could be changed when next digit having greater than 0.5 value, greater than 5 value. Okay, previous digit could be added by 1 when next digit value having 5 more 5 value. Okay, so look at this answer, look at this question. So which digit I should change? We are thinking about 8 and 9. 8 comes to be 9, or it could be unchanged. So I am changing, I am asking about this 8 and 9. Okay, so I will consider this two, you can say, digits. So these two digit are lesser than these two digit are you can say less than 50. Okay, if two digit are less than 0.5, you can say 5, then this digit, it will be unchanged according to my first rule. Look at this example. According to second, if the digit to be dropped is less than 5, then leave the previous digit unchanged. Got it? So according to the second rule, I will be write the correct answer. It will be unchanged. I will not write like this. I will be write like directly 5.678. 5.678. So that is my correct answer. So I will be marked as the correct answer is option A. Second answer is showing 5.679. That will be correct whenever we are applying the first rule. But the first rule is saying when digits are having more than 5, then you will consider as the you will be add +1 in the previous digit. So second answer is wrong. Third answer is giving you significant figure more than 4. 1, 2, 3, 4, 5. So that will be again wrong. Okay, and fourth option is saying 5, 1, 2, 3, 4. Okay, this one is also having 4. We are finding round of digit with the help of last one, depends upon a significant figure. If someone is asking about me, find your answer in the 3 significant figure, then I will consider like this answer, I will consider this 3 digit. Okay, so writing this 3 significant figures. So I will write 5.67, and I can also write 5.68. Okay, now 849 is the more than you can say 500. 849 is more than 500. So I can be write +1 from the last digit. So I will be write 5.68 add by 1 in the previous one. So that will be your correct answer according to your 3 significant answer. So question is asking about 4 significant answers. So I will be marked as a option A is the correct answer. Everyone understood what I have explained? Most of the students are replying Harish Karan, B is correct. No. B is not correct. Option A is the correct, I think. Okay. Option A is the correct. Option B will be correct when I applying. Option A is the correct whenever I am applying first rule. Okay. 0.49 is less than 0.50. 0.49 is less than 450. So previous digit will not change. So first answer will be correct. Got it? Harish Karan, if you have still problem, kindly see the second rule. You will get your answer. Okay. Okay. Let's understand about fourth thing, which I'm dimensions of physical quantity. So again, I have already answered about regarding to this question. Is that dimension question we have already found out. How can you find the dimension of a particular, you can say, physical quantity? So mainly, what is dimension saying? Dimension describe the nature of the physical quantity. Base dimension are represented as length, mass, time, electric current A, temperature K, and luminous intensity, that is CD, and amount of substance, that is mole. So every physical quantity, we can write the dimension formula in the following, you can say, terms. Dimension formula you can get in terms of M, in terms of L, in terms of T, in terms of ampere, in terms of Kelvin, in terms of mole. Okay. Dimension formula you will get in terms of this thing. Okay. And sometimes you can be used as a cadmium. Okay. So mostly you will be get your dimension formula in between this figure. mass, length, time, ampere, temperature, and more. This majorly play key roles in your any physical quantities writing the dimension. Okay, every dimension formula having the terms mostly are these: mass, length, temperature, ampere, Kelvin, and mole. Okay, now the question is saying derived quantities are written in terms of power of base quantities. Example, okay, that is the same thing. Derived quantity, derived your dimension quantity are written in the terms of power of base quantity. Base quantity is what? These are base quantity. So every physical quantities dimension formula can be written as MA, LB, TC, AD, KE, that kinds of thing. Okay, and power you will be written according to your calculation. We will solve some more regards. We will solve some question in you can say next slide, so that you will get better understanding how can you write dimension formula of any physical quantity. So mainly example like volume dimension formula will be L cube. How I have written volume quantity as L cube? Because volume you have written will be area multiplied by height. If you have a cylinder of a particular height, okay, and area, L height is you can say H, and H you are measuring as a length, that could be L, and area is the you can say meter square unit, and meter square is what? It is the unit of length. So L length is multiplied by 2, so L by L. So area you will be written, volume you will be written as base area multiplied by height. So volume unit you will be write, dimension of area will be L square, and dimension of height you will be write as L. So volume dimension you will be write L cube. Got it? So that is the derivation of L cube regarding to the volume. Okay. So that is the dimension of L, dimension of volume. So look at this dimension formula. It is containing base fundamental quantities, that is L. It is the combination of base fundamental quantity, that is the L. It could be written as M0 and T0 like this. Okay. Similarly, velocity dimension formula you will get LT minus L, because velocity you can be written as meter per second, and meter is mode. Meter is length. Length means L, and second means time, that is T, and T to the power minus T to the power 1, and T is the denominator, the power comes to the negative form. So L T minus 1, that is the unit of velocity. Again, force unit you will be written as meter, kg, meter per second square. You can be written like this. So you will be write M L1 T minus 2, because second square having power times unit as a 2. So you will be write T minus 2. So that is the force unit. So dimension do not tell magnitude. They only show the physical nature of the quantities. Main thing, dimension formula does not give you the magnitude about the force. If I have written M1 L1 T minus 2, and if I ask you what is the dimension of the, you can say what is the magnitude of force, can you write exact value of force with the help of this M1 L1 T minus 2? Nothing. You can't write the force, because to writing the force calculation you have to understand the diagram, applying the force, then consider your diagram, then you can find the net force on acting on the body. With the help of direct dimension formula you can't find the directly value of force. I can't directly write like that with this diameter formula force is 10 Newton, or you can say 20 Newton. That was all kinds of things are wrong, because with the help of direct dimension formula we can't write direct the magnitude of force. So that is the main thing. Dimension formula mainly refers to that this physical quantity on which factor it is depending. Mainly it containing mass, length, and time. So that means it is showing to you that force is depending upon mass, length, and time. Okay, it directly showcases the clear idea on which factor this physical quantity is depending. It does not give you the exact value. Understood by everyone? Is it understood by everyone? Any doubt regarding to dimension formula? Anyone, he and she can ask me in the, you can say, chat bot. If anyone who want to some repetition, I can also repeat my you can say statements. Kindly reply so that I will get some clear idea regarding to your understanding. Okay. Any doubt? Kindly reply. Okay, I think nobody is replying. Okay, let's continue with our next topic. Okay. So the next topic is dimension formula and dimension equation. I have already told you that how can you find dimension formula and how can you write dimension equation. So you have already know that force can be written as mass into acceleration. So mass is already given. Acceleration you will be write rate of change of velocity, which means dv by dt. And this is also velocity. Velocity is also written as distance upon time. So you will be write distance upon time, and time is also present in the denominator, that will be also t. So force can be written as mass distance upon time. So dimension formula you will be write mass means capital M, whose value is 1. Distance means the value of L, that value that's power is 1, and t square, that is the, you can say, time unit. Okay, time, that is the t square. T square having the denominator form, at the numerator power comes to be the negative form. So dimension of force you will be written as m1 l1 t minus 2 with the help of this dimension, this formula. Okay, so one of the most important thing to write the dimension formula of any physical quantity, you have to understand about their formulas. Any formula you can be write, it's not a specific, any formula. You can say the complete physics which you have studied in your complete experience, you have to use your entire knowledge to getting the such type of formula in which force is containing, and after do some calculation regarding to units, and then you will get your exact dimension formula of any physical quantity. Got it? Here are some basic physical quantity you can see on which you should know about their dimension. So volume dimension will be m0 l cube t0. I have already derived you. Velocity dimension is already given as m0 l1 t minus 1. That is also derived by me. Acceleration dimension I have already given you that m0 l1 t minus 2. And density dimension is already given as m1 l minus 3 and t0. Density given as the mass upon volume. Mass dimension is m1, volume dimension is l cube. So you can be written as m1 l minus 3 and t0. That is the dimension of density. So that kinds of you can say formula. With the help of this formula, you can easily find the dimension of any physical quantity. Anyone who have any doubt regarding to dimension formula, kindly he and she can ask me, so that we can continue with the question solving. Anyone who have any doubt? Anyone who have any doubt, he and she can ask me. Okay, I think nobody has any doubt. Sir, please repeat this, sir. Okay. Thank you so much for asking this question. Mainly, you have to understand how can you write dimension formula of any physical quantity. For example, I can also written in front of you that a physical quantity Q, which is depending upon some mass, length, and you can say temperature, like written as temperature, okay, upon acceleration. Let's say this physical quantity is depending upon this factor and multiply by time. I have writing some factor on which this physical Q quantity is depending. So firstly, you have to identify what are the basic, firstly, you have to convert this formula into the base physical quantities like temperature, length, mass, time, or you can say amperes, mole, or you can say kdm. Okay. So temperature is also part of the basic unit. So you can be write K for temperature. If look at this statement, temperature is the base unit of the dimensions. Okay. So you will be write K for temperature. So temperature I have already written K. Time having value T. Again, acceleration. Acceleration is what? Acceleration formula is acceleration unit is meter per second square. Meter is what? Meter is length. So I will be write meter per second square. Second square written as a denominator. So it will be comes to the numerator. So you will be write temperature, which is K, multiply by time period, which is T, divided by meter, which means length. Length means you will be write L, and second square you will be write value of T square. Got it? So physical quantities, the new physical quantity which are depending upon temperature, acceleration, and time, its dimension you will be written as K and T3, and L is in the denominator, so you will write L minus 1. So it is the dimension formula of physical quantity Q. Everyone understood how am I write this dimension formula of this new physical quantity? Firstly, relation is already given in the question. You just write their base unit, or you can say just convert this physical quantity formula into the base units. Okay. So I have changed acceleration into the meter and time form because time and meter is the base form in the units and dimension. Okay. And after you can say writing these base values like mass can be converted as the capital M, time can be converted as a T, length could be converted as a L, and you can say current I convert into the A, temperature convert into the K, and mole convert into the mole. Okay? Any doubt? Any doubt? Adi, did you understand? Okay, okay, okay. So, with the help of this, you can say calculation, you can easily find out the dimension formula of any physical quantity. Okay, okay. Nothing is question. Okay, we have one more question. Okay, dimension analysis and its application. What is dimension? So with the you can say with the help of dimension formula, we can also find the unit of any physical quantity. With the help of dimension formula, we can be find the unit of any physical quantity. How? For example, a quantity Q is given as, who have dimension formula is M1 L1 T minus 2. Got it? And what if I ask you, what is the quantity? What is the quantity Q, and what about its unit? So we have dimension formula of Q. You have to identify what is Q and what is the unit of it. So with the help of dimension formula, you can answer. So with the help of dimension formula, how will you answer of this question? So mainly, Q quantity is mainly depending upon mass, length, and time. So you just convert their mass into the kg. Length written, you can write as, you can say, meter. And T minus 2, you will be written as a denominator, you will be write second square. So can you see this particular thing? Kg, which means small m, and meter per second square is the acceleration. So this quantity is showing to you Q equals to mn. Q equals to mn. What is this? It is the force. Q is to ma equals to force. So Q is the force. And what is the unit of this Q? You have already derived kg meter per second square. So unit will be kg meter per second square. So that is your answer. So with the help of dimension, you can easily identify what is quantity and what is the unit of this quantity. Okay. Sometimes it could be difficult. How can you identify the quantities? Okay. It could be force, it could be acceleration, it could be, you can say, stress, etc. These kinds of identifications you can be assumed whenever you have you have to know about their perfect formula, because I am giving the result m into a. So if you don't know about what is m into a, is it force, acceleration, is what, then you can't find the exact value of this quantity. What is this? And if you know, is it the force formula, then you can say that Q is the force. Okay. So with the help of dimension formula, you can find the quantity also, and you can also find the unit of this physical quantity, which is given to you as a dimension formula wise. Anyone who have any doubt, he and she can ask me. Everyone understood what I'm saying? How can we find quantity as well as their unit with the help of dimension formula? Any doubt regarding to this? Any doubt regarding to this, my statement? Okay, okay. So now these statements are saying dimensional analysis helps in checking correctness of equation, okay, finding relation between physical quantities, and ensuring dimension consistency. Okay, okay. So these three kinds of things I have already explained to you. If a quantity whose dimension formula like this, and someone is telling to me this physical quantity is current, okay, and someone told me, no, sir, it is the force. So with the help of this dimension formula, and after doing my analysis calculation, I got Q refers to the MA and MA is the force. So current statement showing percent was wrong answer. Force giving answer, that is the correct. Okay. So with the help of dimension formula, I can also find the correctness of my equation. Okay. I can get my correctness F equals to MA. That was the unit of force. So with the help of dimension analysis, I can check this physical quantity showing to me the force unit, and this physical quantity is the force with the help of dimension formula. Second thing which we can understand, finding relation between physical quantities. How force depending upon mass, length, and time period. So we can see that With the help of this relation, we can say that force is directly proportional to mass, force is directly proportional to length, force is inversely proportional to time square. Okay, that kinds of thing we can assume with the help of dimension analysis. Third thing, ensuring dimensional consistency. Ensuring dimensional consistency means if dimension formula is correct, then my unit answer will always correct. If dimensional formula is right, if dimensional formula is right, and I'm showing to you that this physical dimension formula is correct and this physical quantity is force, then after dimension analysis, by doing this calculation, my dimension formula gives me the exact value of the unit of force, that is kilogram meter per second square. Okay, so that kinds of consistency also given me with the help of dimensional consistency. Okay, next point is saying only quantities with the same dimension can be added or subtracted. Okay, so main thing is that the same quantities, okay, can be added or subtracted, which means mass can be added with the mass can be separated with the mass. We can't subtract mass into the temperature. What if I tell you subtract this quantity 5 kg minus 10 degrees centigrade? Can I write this equation? No, it is not defined, because same unit can be separated from the same unit. Got it? So this thing is already telling you. Next thing, in any correct physical equation, dimension of LHS and RHS must be the same. Again, same thing I'm telling to you. Let's say this physical quantity is force, and force unit is, you can say, meter, kg meter and second square. Okay, so at the LHS, unit is kg meter per second square. So at the RHS, it should be comes out to the same result like LHS, kg meter per second square. Okay, then we can say that the correct physical equation was right. A dimensionally wrong equation is definitely wrong, but dimensionally correct equation may still not be fully correct. Okay, again same thing which I'm giving to you. Sometimes we can say that two physical quantity who have same units, two physical quantity who have same units, then they could be have, you can say, same dimension formula. So we can't say that if a particular dimension, if a particular, you can say, if I talk about, you can say, pressure. Let's take an example, pressure, and let's take an example about stress. Everyone knows about that. Pressure can be written as force upon area. Stress is also written as force upon area, but both are different physical quantity. Okay, because pressure sometimes compressible, and sometimes pressure is always compressible nature, but stress sometimes, you can say, tensile nature as well as compressible nature also. So both are different quantity. But if I talk about their formulas are totally same. Formulas are totally same. And if I talk about their, you can say, dimension, then I can say that their dimension is also will be same, m1 l1 t minus 2 upon l2. So you will be get m1 l minus 1 t minus 2, and same dimension you will be written like this. So if two physical quantity who have same dimension formula, then we can't say that those are referring to the same physical quantity. They could be different also. So main thing the question is saying, a dimensionally wrong equation is definitely wrong, that is always correct, but a dimensionally correct equation may still not be fully correct. Okay, still not be fully correct means it doesn't mean that it will give you only single physical quantity. It could be referred to the more than two physical quantity. For an example, stress and pressure. Any doubt? Any doubt regarding to this? Any doubt regarding to this, you can say, explanation? He and she can ask me. Anyone who have any question? Everyone who can ask me. And if is it understandable, then kindly share your review. Okay. So let's talk about the question. Again, this is the simple question, the dimension formula of force. Let's write the dimensional formula of force. Can you solve by self? Dimensional formula of force. Let's solve by yourself, kindly. Please solve this question by yourself. And give me the response in your chat bot, okay? So some student is replying option A. Okay, I already discussed to you. Force is written as m into A, then you will get correct answer is m1 l1 t minus 2. Okay. That thing I have already discussed. The force dimension formula will be A. Okay. Now, let's the second thing, 1.7, introduction of error. What is error? Error is mainly mistake. Error is mainly mistakes which are doing by yours and by instruments. For an example, any instrument can be measure exact value of measurement, but not always. Sometimes it could have some slightly different value. For an example, if you are writing, if I talk about projectile motion, okay, if I talk about projectile motion, then we are using some assumption to find in the range. So we have our assumption is right. Our assumption we are considering neglect the air resistance, neglect the, you can say, curvature of earth. Okay, curvature of earth, neglect the rotation of earth. So after neglection of this thing, we are getting range formula used for sine to theta upon g like this. So if I talk about real practical example, in practical way, we are not neglecting this kinds of thing. Air resistor are happening, earth is also rotating, curvature of earth is also depending. So if you are by theoretically, you are getting your answer, you can say 10 meter of range, but practically you will get 9.7 meter. That is nearest to the 10 meter, okay, but practically it is getting some, you can say, lesser value. So lesser value, which means your answer is not matching to your practical value. That means your answer having some error. Your answer having some error. Error is what? That is 0.3 meter is your error. It could be sometime plus and it could be sometime minus also. For an example, by theoretically, I can also give you 10 meter, and by theoretically, I can also give you 9.4 meter. And the correct answer is lying, it is 9.7. So it could be 0.3 meter less, and it could be 0.3 meter more. So error you will be written as 0.3 plus minus. That is your error. Error is what? Your incorrectness to finding the exact measurement of a particular physical quantity. Any doubt? That is your error. So I'm writing the simple, I'm giving you some explanation saying an error is the difference between the measured value and the true value of a physical quantity. Every measurement has some uncertainty, so error are unavoidable. Are you getting my point? This same kind of thing already mentioned in this, you can say, paragraph. So main thing paragraph is saying that every physical quantity, whenever you are doing some measurement, the true value sometimes we give true value, that is a true value, but your measurement sometimes give you the uncertainty. Uncertainty means sometimes it give you some, you can say, error. Just giving the example of range. Range can you are finding by theoretically you are getting 10 meter by doing some assumption, but in practical life assumption are not happened. Okay, real life air resistance is occurring. Earth rotation is also taking the part to finding the calculation, and also you can say curvature of earth we can't do neglect. So by practically your correct answer will be different from your theoretical answer. That means in your theoretical answer there are some uncertainty due to assumption, and this uncertainty is called error. Any doubt? Any doubt regarding to error? Any doubt regarding to this explanation? He and she can ask me. Okay, nobody has any doubt. Let's move our next step. So error are these types of error. Okay, we are considering about the types of error. So firstly, systematic error. The occur due to faulty instrument or improper experimental techniques. They are consistent and can be corrected. Example, zero error in vernier caliper and faulty stopwatch. Okay, what is systematic error? Systematic error mainly refers to you that whenever error or uncertainty of your measurement you are getting by your equipment, or you can say if equipment having some faulty, if equipment is reading some faulty value, then you can say that error measured by the equipment, that is called systematic error. Got it? For an example, let's say I am in front of you and I just give you a question and just solve this question within 5 minutes. I have given you a timer, and after 5 minutes you will stop your answer. So you are doing your question within 5 minutes and I am wasting my time till the 5 minutes. And after I am stopping my time, my stopwatch is not stopping due to some systematic fault. So it has stopped after, you can say, 5 minutes extra. It has stopped after 5 seconds more. So my actual true value is 5 minutes, but my stopwatch stopped at 5.05 seconds. That means this 0.05, it's my uncertainty, and this uncertainty has I have got with the help of this my instrument on which I am measuring the time. So this instrumental error, you can say this faulty instrumental error, that is they called systematic error. Got it? So that is the systematic error. So random error, this occur due to unpredictable change in experimental condition. They vary randomly and cannot be completed eliminated. Gross error, these are human errors like wrong reading, incorrect reading, or calculation mistake. Yeah, that is the simple thing. Random error means you are using exactly correct answer. You are doing exactly correct. You are doing exactly correct question. Question does not have any error. Formula is you are using also will be correct, but you are doing some calculation mistake and you are getting wrong answer. For example, a mass of the body whose mass is 10 kg and acceleration due to gravity is 10. Okay, acceleration due to gravity is 10. I have already given what is the force acting on the body due to gravity. So you will write m into g. So some students writing g equals to 9.8 meter per second square, and some students will be use my questions answer formula, which is 10 meter per second square. So some students will write, sir, 100 Newton will be the force due to gravity, and some students will say 98 Newton, sir, due to gravity. So according to this phenomena, so you are getting some different value, and it is my dependency which option I am giving the correct. If I give you that, do your calculation according to this data, then 100 Newton answer will be correct. But if you are using your own brain and getting the correct answer regarding to this force, you are getting 98 Newton. That could be wrong according to this question. Okay, that could be uncertainty. So uncertainty is what? There is a 2. Uncertainty is 2. So your error is the 2. So main thing is that whenever you are doing right thing, whenever system is also correct, whenever you are using right formula, and by randomly, by your own, you can say mistake, or you can say, or by your mental condition, you are writing wrong reading, wrong formula, you are writing wrong values, and you are getting wrong answer. So that uncertainty, by your getting your wrong answer, that uncertainty are called as random error. Got it? So here are 2 more types of error formula. Firstly, absolute error, and second, relative error. What is absolute error and what is relative error? So absolute error can be written as absolute error is equals to measured value minus true value. For multiple reading, mean absolute error, sum of all absolute error divided by number of reading. So absolute error is what? Absolute error is the simple, you can say, whenever you are, you can say, measuring a particular length. Okay, and this actual length, you can say 10 centimeter. And I'm not showing the actual length. I just give you this diagram, and I'm asking to 5 students, what is the length of this line? I'm asking to 5 students, and I'm asking to them, what is the length of this line? So someone is replying, sir, that is the 10.5 centimeter. They are using their brain. Someone is also saying, sir, this is the, you can say, 10.8 centimeter. And also someone is saying, sir, it is the 9.5 centimeter. And someone is saying, sir, it is the 9.2 centimeter. It's look like, because everyone are using their own brain. And so every brain are doing their own calculation and giving their different answer. So to solving this problem, to getting the absolute error, what is the overall error which are doing by the humans? So you will get their average. So average you will get all measurement due to all person. So you will write sum of all absolute error by your all, you can say, measurement person divided by number of reading. How many person are reading to how many person are, you can say, assuming this, you can say, measurement. Okay. So if 5 students are measuring this, you can say, reading, so you will return 5, and you will be write their error, which are 0.5, because exact value is 5. Exact value is 10 centimeters. So error will be 0.5, and that is the minus 0.5, and that is the 0.5. minus 0.8, and that is plus 0.8. So exact error you will be write total sum of 1 divided by number of readings which you are taking. Okay. So for multiple reading, you will be use mean absolute error. That is the mean absolute error for multiple reading. And for single reading, you just write absolute error equals to measured value minus true value, which means your measured value is according to this length is 10.5 centimeter. Okay. And actual length is 10 centimeter. Then absolute error formula you will be written as measured value by yours, that is 10.5, minus actual value, that is 10 centimeter, divided by, not dividation, that is the your error. That will you will get 0.5 centimeter is your error in the length, and you will be write delta L. Any doubt? Okay. So this absolute error can be positive, can be negative. Positive means you are giving the larger value from the, you can say, true value, and negative value, that means you are giving not exact value but giving some lesser value from the true value. So it could be, you can say, it could be acceptable whenever you are getting positive or negative value or absolute value. Okay. And if you have multiple reading by multiple person, then you will be right mean absolute error, that could be sum of all absolute error, which means sum of all readings. Readings means error by all person, sum of all errors by the all person divided by number of readings which are taken by the all person. Now let's talk about the relative error. Relative error means absolute error divided by mean value. That is the simple, you can say, formula. That means if I asking to you that let's say here is the area of the circle, okay, and area of the circle's radius I have not given to you, okay. So you, most of the students firstly replying radius could be 10.3, radius could be 10 point, you can say 4, okay, and radius could be 10.7, okay. And what if I tell you, and some student is replying to me that one of the students is directly showing to me that, sir, absolute value is 10.4 and my answer is correct. Then to check their correctness, we are finding, you can say, relative error. Relative error is what? Relative error is what? Mean absolute error, or mean absolute error of this, you can say, radius calculation, and which means you can say absolute error by 1% divided by mean absolute error. Okay, so 1% is saying absolute error is 0.4, sir, according to me, and mean absolute error means 0.3 plus 0.7 plus 0.4, that will be 1.4. So this is your mean absolute error which you are calculating. That is called relative error. Got it? And after doing this calculation, you will get relative error, and after multiply by 100, you will get your percentage. Okay, so any doubt regarding to any error calculation? After we will do some calculation. Okay, someone is asking, Ella Nithilin, sir, when we will get notes, sir? Okay, we will get notes. I will notify after some time. Okay, firstly, you just understand this concept. After I will ask to the operational team, they will reply to you. Okay. Okay. Relative error is one more time. Okay, no problem. Relative error is very simple. It is directly showcasing to you that whenever 10 persons are measuring some particular physical quantity, okay, so every person can do some mistakes. So every person can do some mistake during the calculation. That means every person can have some errors. So relative error mainly refers to you that if one person showing to that, sir, my error is not faulty, my error is completely, you can say, my answer is totally correct. So to identify their correctness, we will assume a relative error to identify their correctness. For an example, 10% are reading a radius of the scale, radius of the circle, that will be 10.4, 10.3, 10.7. 3% are measuring their radius of the, you can say, circle. Okay, so they are showing 10.3, 10.4, 10.7, and true value, which means exact value of radius, this is 10 centimeter. So what are the error due to all person? So first person error will be 0.3, second person error is 0.7, third person error is the 0.4, and one of person who is saying, sir, my answer is not faulty, my error is very less as compared to other. Then to check their identification, we are using relative error. How we are using? You will be just write the absolute error of that person who are claimed to my error is so less. So you will be write 0.4 as a numerator, absolute value of first person, and divided by mean error. Mean error is what? According to this formula, mean absolute error what? Of all students, which means 0.4 absolute error for all persons, 0.3 plus 0.7 divided by number of readings which you are taking. So 0.3 is 0.4, 0.7 divided by 4. So you will be right 0.4 upon you can say 1.4 divided by 4. That is your absolute error by 1% divided by mean error by all. So that will give you the relative error. That is the simple formula. Okay, we will understand this thing. Hello. Okay, wait. Then I called someone. Okay, so we have done the error calculation. Okay, so relative error, have you understood? Okay, if someone have still confused, we will solve some question regarding to this. Then we can continue with chapter 2. So we have some we have a question on which we have to find some calculation. Student measure the length of a rod 5 times and obtains the readings 10.2, 10.4, 10.3, 10.5 and 10.2. Calculate the mean value of the length. How can you find the mean value of the length? So mean value of the length you will be right according to the formula, sum of all absolute errors divided by number of reading. Okay, sum of all absolute error. So absolute error is what? If you can say actual reading of rod is 10 centimeter. Okay, then what is the error due to all of these readings? So first one is doing 0.2 plus 0.4 plus 0.3 plus 0.5 plus 0.2 divided by number of readings. That will give you the mean absolute error. Okay, so with the help of this formula you can be calculate the absolute error. Calculate the absolute error in each measurement. So absolute error, if rod actual length is 10 centimeter, then absolute error is 0.2, 0.4, 0.3, 0.5 and 0.2. By using the formula absolute error, you are getting this value. Find the mean absolute error. Okay. First question is saying find the mean value of length. Mean value of length means total sum of these all length divided by 5. Sorry, this first calculation which I have done in front of you, that is the mean absolute error calculation. Okay, so third one I have already solved you. I have to solve again the mean value of length. So mean value of length you will be get 10.2, 10.4, 10.3 and 10.5 plus 10.2 divided by 5. So you will get L average of the length. So you will get average length of the, you can say, rod. Second one is saying calculate the absolute error in each measurement. So according to this calculation, if actual length is not given in front of you, then you will be right absolute error will equals to, you can say, L average, not L average, sorry, measurement minus L average. Okay, so you can find, so L average you have to find by yourself, and after subtraction you will get absolute error. Now calculate the mean absolute error. Mean absolute error means firstly you have to find absolute error for every reading, and then add of them divided by absolute error, which means I'm showing to you that firstly calculate absolute error due to all readings like this, and divided by 5. So you will get mean absolute error. Calculate the relative error. Relative error you will again find. You will be firstly write absolute error of this wire. You will be write like 0.2 divided by mean absolute error due to rod. So you will be get calculate the relative error. Find the percentage error. Again multiply by mean absolute error, multiply by 100. Relative, you will be right. Finding relative error due to all measurement, multiply by 100. It will give you the percentage error of every reading. Got it? So I think this question should be done by yourself by using the formula. If you are finding some any, you can say, problem, he and she can ask me in the next classes. Okay. So this chapter, this question you have to done by yourself. I have already give you the, you can say, some overview regarding to this. Let's do some another question, another chapter, which is motion in straight line. So straight line motion, that is very simple. Whenever any particle changes its position with respect to time in a particular frame of reference, that kinds of thing is called motion. For example, motion is common everywhere: walking, moving vehicle, falling leaves, flowing water, earth revolving around the sun. These all of kinds of example are directly showing to you that these are all in the motion example. Okay, so motion equals to change in position with time. That is also change in position with time. Also add few things is that with the particular frame, because frame of reference is playing key role to telling about the particle motion. For example, if you are standing in the train, so according to you, all passengers are rest according to yours. But if I talk about the ground person which are looking to the train, so according to the ground standing person, all persons are having in the motion. So motion can be defined in the particular frame of reference. Okay, so the changing of the position of a particular particle or the particular person with respect to time with a particular frame of reference, that kinds of thing is called motion of a, you can say, motion of a particle. Okay, so in kinematics we study motion without considering causes. Here we study motion only one dimensional motion, which means in kinematics is what? Kinematics is the branch of physics in which we are studying about the motion of a particle, how it will behave, like how particle will behave whenever it is under in the motion. Okay, that kinds of thing we are doing in the kinematics. So in this lecture we are considering only one dimensional motion. So firstly, position and displacement. Position is what? Position is with respect to particular point, how much distance away, or you can say how much particle, how particle is standing with respect to another person. For example, A, B, and C are standing like this. So A having 10-meter distance from B, C having 5-meter distance from, you can say from B, and A is the, you can say, 15-meter distance from C. What if I ask you what is the position whenever we are considering a particular point? So what if I ask you from the C, how far is A? So you are saying yes, 15-meter. So 15-meter is the position from point C. So position is what? Position is the, you can say, it is the, you can say, the distance from a particular point of another point with respect to particular frame of reference. Okay, so if I talk about from point C, how far is A? A is 15-meter. From point B, how far is A from B? You can say 10 meters. So 10 meters is the position from B. Okay, so what is displacement? Displacement is the consider two points from A to B and the minimum distance from initial point to the final point. That is the called displacement. For example, if you want to go from some A city to B city, so whenever you are moving by road, that means you are covering your distance. But if you are moving by flight, so flight covers the shortest path from A to B. So flight covers displacement, road covers distance. So that kinds of thing we can consider what is displacement and what is distance. So displacement is what? Displacement is the shortest distance between initial point to final point. And distance is what? Distance is the total path length covered by the particle from A to B. That is the final thing. Now, displacement is the vector quantity. Distance is the scalar quantity. Displacement, distance cannot be decreases over the time, but displacement can be decreases over the time because it mainly depends upon how far is particle A situated from particle B. It depends upon final and initial position. For an example, if I draw a graph, this is origin, and this is, you can say, point B, and this is point A. Okay, let's say a particle is moving like this, and it reaches at point C. It reaches as point C. So A to C displacement is 10 meter. Okay, and when particle comes to the point C dash, which is far from the 5 meter, it doesn't mean that firstly particle comes to the point C and come back to the point C dash. Then total distance, total displacement, you will be right 15 meter. No, it is not displacement, it is the distance. So displacement will be initial point to final point. What is the minimum distance? That is a 5. So displacement can be decreases, displacement can be increases. It is depending upon initial to final position of the both destination. And similarly, distance is could be total path length covered by the particle during the time interval. Got it? So overall, I have already given. And if you have a particular coordinate system, then you will be write displacement of a particle. Displacement you will be written as x2 minus x1. If particle moving along x-axis, is particle moving y-axis, then you will be write y2 minus y1 and z2 minus z1. Okay. If you have particular vector form, I, j, and k cap. Okay. So that is the displacement vector by doing, you can say, vector calculation. Okay. So let's consider a question regarding to displacement and distance. A particle moves from point 2 to 2,3 to point 8, 5 and then to point 5, 11. Find the magnitude of displacement of the particle from A to C. So you have 2 points, A, B, and C. Point A having coordinate 2, 3, point B having coordinate 8, 15, and point C having coordinate 5, 11. Okay, you have to find displacement from A to C. So question is saying you have to find displacement from A to C. A to C means just match your destination from A to C. Doesn't mean B is where standing. You have to consider displacement from A to C. And how will you write displacement? Displacement you will write as a vector form, or you can say by coordinate form. You will write displacement is x2 minus x1 plus y2 minus y1. Okay, or displacement you will be written x2 minus x1, you will be write 3, okay, comma, and y2 minus y1 will be 3, that is the x displacement, you will be write I cap, and y2 minus y1 will be 11 minus 3, that will be written 8 j cap, that is the displacement. So what is the magnitude of the displacement? You will be right, magnitude will be 9 plus 64, a square plus b square. So you will be right 64 plus 9. Minus x1. Okay, I think a particle moves from point A to 2, 3 to point 8, 15, and then point 2, the magnitude of displacement of the particle. I think magnitude is also correct, 173. X2 minus x1, that could be 3, and y2 minus y1, 11 minus 3, that could be 8. 8 is 64. Some question error, it could be written as under root 73. Okay, so option B will be correct. So mainly consider 2 points A to C and find your displacement from A to C is x2 minus x1 plus y2 minus y1 whenever you have a coordinate. Okay, so that is the question, so that you can get understanding regarding to, you can say, displacement. Now let's consider about average velocity. Average velocity is what? Average velocity, you can say that velocity is the, you can say, vector quantity, and speed is the, you can say, scalar quantity. Speed can be written as distance upon time. Okay, and velocity is the displacement upon time. Displacement upon time. So what is average velocity and average speed? Average speed is the total distance covered by the particle. Total distance covered by the particle divided by total time taken. Okay, total time taken. While displacement is also average displacement average velocity can be written as total displacement covered by the particle in delta t time upon time interval.
Sir,
V average, you will be right delta x upon delta t, that is your average velocity.
Rakesh
Average.
sir, so can you repeat the previous slide?
Previous slide you want to see?
Yeah, sir.
Okay. Wait a minute. Previous slide is, you can say that is the question.
Yes, sir.
Any doubt?
So can you repeat it again? Full.
Okay. Question mainly saying is that a particle moves from point A 2,3 to point 8,15. Okay. Firstly, it reaches point A to point B, and then it comes to point C 5,11. Then find the magnitude of the displacement of the particle from A to C. So 3 points are standing A, B, and C. So firstly, particle moving from A to B and A to C. If I write AB plus BC, and I'm just giving to that is displacement, so that was the wrong thing, because it is the distance, because it is the total path length from A to C. But what is the displacement? Displacement is the shortest distance between A to C. Shortest distance between A to C. So it could be A to C. I will join directly A to C, and it is the displacement. And displacement you will be right by the distance formula. You can also written under root x2 minus x1 whole square plus y2 minus y1 whole square. Got it? X2 minus x1 give you the 3 I cap, y2 minus give you 8 j I cap. And after squaring of both, you will get 9 plus 64, and you will get 73. Got it? So this is your displacement. Any doubt? Any doubt? Someone who asked me question? Sandhyana Mardana, do you have any doubt? Okay. Let's move over average velocity formula. Okay. So average velocity mainly directly telling to you that the total displacement covered by the particle in the given time interval upon time interval. Average velocity measure how fast position changes. Yeah, main thing is say this average velocity mainly refers to you say how fast particle changes its position. If a particle having greater value of average velocity, which means it is changing its position very fast, and if someone having, you can say, lower value of average velocity, that means it's slower to changing its position. Okay, example 20 minutes in 4 seconds, that means average again that means 20 minutes 20 meter in 4 seconds. So 20 meter means this particle covers 20 meter in 4 second time interval. So you will be right 20, that is the displacement covered by the particle, and upon time, that is the 4. So you will get 5 meter per second. This is your velocity of is what? This is average velocity. Now let's talk about instantaneous velocity. Instantaneous velocity, that means whenever particle also covering some distance with a particular time interval, and during this time interval, I just ask you suddenly, what is the displacement of the particle at this instant? So at this instant, just instantly, particle covers at this time, let's say t is very small, delta t is very small. That could be written as dt for a minimum time duration. So you can say at a small time duration, at just instant, particle covers very less value of displacement, that is dx. On time duration will be very less, that is dt. So on that time, this velocity will be very instantaneous. For an example, a car is moving with a 20 meter per second in a particular straight road. Okay, and road having, you can say, 20 meter length. So if a car moving in the from t equals to 0 to t equals to 10 second, and total road distance is 20 meter, so average velocity will be 20 divided by 10, that will be 2 meter per second. But what if I ask you during the duration of time, what is the velocity of, you can say, what is the velocity of car at just t equals to 11 seconds? So at just t equals to 11 seconds, you will click a photograph of this, you can say, car. Then you can see that just nearest to the 11 second, car covers slightly displaced by dx, and slightly time difference will be dt. So on that time, dx by dt ratio will give you the instantaneous acceleration. That means it give you the instantaneous velocity at a particular time. So it also give you velocity at a particular instant, that is the instantaneous velocity. Slope of the tangent on xt graph, that will give you the instantaneous velocity. Do you know about the slope formula? Slope formula mainly written as, if you have a particular curve and you can say if displacement is varying according to this graph, then slope you will be written as, let's say, from q to point p. X coordinate of point p is x1, and x coordinate of point q is x2. Y coordinate of point p is y1. Y coordinate of point q is y2. So slope you will be right y2 minus y1 upon x2 minus x1. Give you the v instantaneous. Okay, v instantaneous. Okay, so mainly it will give you also delta y upon, okay, x2 minus x1 also, this is the along x-axis. So x coordinate mainly give you the time interval. Okay, that is t1, that is t1, t2. Because if it is along x-axis and x-axis is the time, then you will write t1 and t2. If y is the displacement along the, you can say, particle along y-axis, then you will be write y2 minus y1 upon t2 minus t1. Got it? So mainly it is refers to us whenever you have a displacement versus time curve, and whenever you are finding the slope, then y-axis will give you the displacement of the particle, and x-axis along the direction of time. Then you will write delta t equals to t2 minus t1, delta x equals to y2 minus y1. Yeah, it could be x2 minus x1 also. It depends upon graph which is given in front of you. So mainly you have to understand is that the slope between displacement versus time curve will give you the instantaneous velocity. Got it? Let's talk about speed. Speed, I have already told you, speed is a scalar quantity, and speed is refers to us, speed will equal to total distance upon total time. So speed is the magnitude of velocity. Yeah, sometimes we can say that could be correct when distance is totally equal to displacement. This definition will be correct when displacement is totally equal to distance. For an example, when a particle moving along straight line path, okay, and it is moving then A to B, and it not come back to the point A, and again it is moving from point C to B to C. So displacement is also, you can say, AC, and distance is also AC, and let's say time duration to reach A to C is delta t. So velocity will be AC upon delta t, and speed will also given as AC upon delta t. So on that time we can say the magnitude of velocity, whenever particles displacement and distance having same value, then magnitude of speed, or you can say the magnitude of velocity, will give you the magnitude of speed. Got it? But it is not true always. So mainly speed is refers to us distance upon time, and velocity will refers to us displacement upon time. That is the main thing. Dimension formula of speed can be measured as meter per second. So you will write L1 t minus 1, that is dimension formula, and m is 0 because no mass is including during the calculation. So that is the simple dimension formula which I am giving to you. So velocity could be positive and negative, but speed always positive. Velocity positive means velocity particles motion in the positive axis, positive axis of the coordinate system, and if a particle having negative velocity means particle having opposite direction of motion. Got it? But speed will never to the negative. Now we have a question. Let's solve this question, and to identify how can you calculate speed and, you can say, velocity of a particular problem which are given in front of you. A car travels the first 1/3 of distance at 20 km per hour, the next 1/3 distance at 40 km per hour, and the last 1/3 distance at 60 km per hour. Then find average speed for the particle entire journey. You have to find average speed. Okay. Firstly, do yourself. After that, I will solve this question with yours. Okay. Just do this question. Just do this question quickly. I can give you only 1 minute. I can give you only 1 minute. Let's solve this question quickly. Okay. At 11:56, I will solve this question. Okay. Kindly reply fast. Nobody is replying. Still no. Kindly reply fast for this question. Okay. One student is giving sir option D is the correct answer. Okay, no problem. Let's solve this calculation with perfectly understanding. This is point A, this is point B. Particle reaches to the point A to point B. So particle travels first one third distance at 20 km/h, which means let's say total distance is D. So D by 3 distance covered by the velocity. You can say speed with 20 km/h. Okay. And next one third distance covered by the particle is 40 km/h. So V2 is 40 km/h. Okay, no problem. And last one third distance covered by the particle with the velocity is 60 km/h. So you have to find average speed. So average speed you will be written as total distance covered by the particle. Total distance will be, it is capital small d, and total time will be, let's say point A to, let's say this is point E and this is point A. So A to F particle takes T1 time, and C to F particle takes T2 time, and F to B particle takes T3 time. So you have to write total distance, this is T, and total time will be T1 plus T2 plus T3. So to identify the T1, T2, T3 addition value, you will be write your distance formula. You can say you have to write your velocity formula for this A to C. So A to C velocity is 20 km/h. Distance covered by the particle is d by 3, and time taken by the particle is T1. So T1 you will be write d by 60. Is it right? Similarly, T2 you will be write d by 3 divided by velocity at C to F, that will be 40. So you will be write d by 120, and T3 you can be find d by 3 divided by 60 km, that will be 60. So d by 180. So T1, T2, T3 value you will be get total, you can say average speed, as speed you will be get d by 60 plus d by 120 plus d by 180. So d will be cancelled, and LCM of this terms you will get 180. So 3 plus 2 plus 1, and 180 comes to the numerator. So average speed you will get 180 divided by 3 plus 2 1, 3 plus 2 5, 5 plus 1 6. So you will get average speed 30 km/h, which is your answer. What is the correct answer? Option C. So option C is the correct answer. I hope you have understood this problem. Anyone who have any doubt regarding the discussion, he and she can ask me. So Ella Nithilian, you got your wrong answer. Sorry, you got 40 meter per second. That 40 km/h. That was your wrong answer. Correct answer is 30 km/h. Any doubt? Any doubt regarding to this question? He and she can ask me. Sir, formula. No. Formula is very simple. You have to consider total distance covered by the particle divided by total time taken. Got it? So from A to B, particle covers total distance is d, but time duration is different because velocity at every part is different. D by d, first initial d by 3 distance covered by the particle with 20 km/h, which means it will take T1 time because velocity speed is different. Another particle having some, you can say, different velocity, so it takes T2 time. Third distance covered by the particle with again different velocity, it takes T3 times. So average velocity you will be by total distance covered by the particle, that will be small d, divided by total time, which will be T1 plus T2 plus T3. Okay. So I have written like this: T1 plus T2 plus T3. So to find the correct answer, I need to identify the actual value of T1, T2, T3. So I will be write speed, you will be write distance upon time. So time you will be write distance upon speed. Got it? So for T1 time duration, T1 I can be write d by 3 distance upon time is 20. Sorry, upon velocity is 20. Again T2 you can be write d by 3 divided by velocity of second part will be 40, and after multiplication it has got d by 120, and T1 got d by 60, and you can say T3 we had got d by 3 multiplied by velocity at third section, that will be 60 km/h. So you got d by 180. So total time will be T1 plus T2 plus T3. So I have simply add of this thing. So d will be cancelled out because it is the common, and after addition you will get 180 is the, you can say, LCM, and you will get 3 plus 2 plus 1. Again, that is come again 6 upon 180. Okay, so 180 comes to the numerator. So I have written 180 divided by 6, and after division you got average speed will be 30 km/h. Any doubt? Any doubt regarding to this? Adi, any doubt? Any doubt from this question? He and she can ask me. If you have still confusion, you can ask me. You just use your simple formula. Total distance upon total time. If time duration is different, then find time duration by part separately. Sir, please piece up your speed. We have to complete class 11. Okay. Okay. So let's topic will be position versus time graph. Position of time graph, which is totally different. How particle changes its position with respect to time. So this graph is directly showing in front of you. So if particle takes equal distance with equal time duration, that path will be, you can say, straight line, which means x is directly proportional to t. So that path you can consider as a straight line. So distance position versus time graph mainly refers to the position versus graph instantaneous position of a particle plotted in the y-axis in the time taken, known as the position versus time graph. That is the simple. Y-axis along the direction of displacement, x-axis along the direction of time. So variation of displacement with respect to time, that will be shown by the graph, that is called position versus time graph. Okay. Position of time graph of uniform motion when object is in uniform motion, travel equal distance in equal time interval of time. So whenever you are considering when x is directly proportional to t, then their position versus time graph will be straight line. Straight line means by increasing of time interval, particle also increasing its displacement. Okay, so that is the uniform motion. Therefore, in uniform rectilinear motion, position versus time graph of an object will be straight line. That is according to this diagram. Got it? Here, the velocity of the object can be calculated using position versus time graph slope. Also, I already told you that the slope of the velocity displacement versus time graph will give you the velocity of a particle. Got it? Now let's deal about acceleration. Acceleration is what? Acceleration is the rate of change of velocity. For example, if a particle is moving the straight line direction, and the particle having velocity, initial velocity is 10 meters per second, suddenly it changes velocity into the 30 meters per second. Okay, with the time duration from 0 to 10 seconds. Then what is the velocity? What is the acceleration? So acceleration can be referred as rate of change of velocity. So change in velocity upon time interval of this upon time interval of this, you can say changing. So rate of change of velocity will be change in velocity upon time interval. So you can write this if a particle changes its speed from 10 to 15. So you will write final velocity minus initial velocity upon time interval. It's given by the question. So that will give you the acceleration of the particle. Acceleration of the particle refers to you how velocity is changing with respect to time. It could be positive, it could be negative. It is the vector quantity. Got it? So formula is directly given in front of you. It is also very simple. Change in velocity upon time. Okay. Uniform and non-uniform acceleration. Uniform and non-uniform acceleration, that means if a particle changes its velocity constantly, that will be called uniform acceleration. Uniform acceleration means velocity changes its velocity with constant rate. For example, uniform acceleration example, we can say that whenever any particle drop out from a particular height, then acceleration due to gravity is always constant, which is 9.8 meter per second square. That means at every second of time, particle increases its velocity with 9.8 meter per second. So at t equals to 0, particle having velocity 0. At t equals to 1 second, particle having velocity 9.8 meter per second. But at t equals to 2 seconds, particle having velocity 2 into 9.8 meter per second. That means velocity increases constantly with respect to time. That is the uniform acceleration motion. At the similarly, we can say that when acceleration is non-uniform, that means particle changes its you can say velocity, you can say non-uniformly. It's just an example that whenever you are driving your bike in a market, then by you can say by crowded people, by vehicle, and by your suddenly a vehicle comes in front of you, you suddenly changes your velocity. Okay, so if your suddenly change of your velocity is not uniform, it is totally randomness. Totally depends upon your time, on which time you are applying your brake, and velocity is changing at ununiformly. That phenomena, we can say that when velocity is changing with not constant rate, that is the called non-uniform motion. So this phenomena is directly told you that it is uniform acceleration, that is non-uniform acceleration. When acceleration is constant in complete time interval, that is called uniform acceleration. If acceleration is varying with respect to time, that means that is non-uniform acceleration. So that is the basic definition regarding to uniform acceleration and non-uniform acceleration. Got it? And here is the simple graph. Okay, so this thing I have already told you. Now let's talk about the instantaneous acceleration. So just like instantaneous velocity, instantaneous acceleration can also be considered like this. Whenever, let's say for example, if you are moving in a particular market by the vehicle and you are suddenly changing your velocity by during the driving. Okay, so what if I tell you what is the acceleration of yours when you are moving to the market at t equals to 5 seconds? So at exact time on which I am asking to you what is the value of acceleration, that instant of time on which I am asking to you the acceleration value, that is the called instantaneous acceleration. Well, acceleration at a particular instance, that is called instantaneous acceleration. Okay, so on that time you will be find instantaneous acceleration. It's depending upon your velocity of a particle. If your velocity is changing with respect to time t, then acceleration you will be write the instantaneous acceleration you will be write as differentiation of your velocity with respect to time, and that equation will give you the instantaneous acceleration. So another thing which you can understand with the help of instantaneous acceleration, when you have a velocity versus time graph, the slope between velocity versus time graph will give you the instantaneous acceleration. Got it? So here is the particular diagram. Let's say velocity is changing with respect to time like this curve, and the slope at a particular time, let's say t1 time, I'm drawing the slope. So that is the instantaneous acceleration at a time t1. Got it? So here is the basic understanding regarding the instantaneous acceleration. Okay, so according to curve, slope between velocity versus time will give you the instantaneous acceleration, and in a particular equation, just differentiate velocity equation with respect to time, they will give you the instantaneous acceleration equation with at a particular time. Now, kinematic equation, uniform accelerated motion. So what is mainly kinematic equation mainly refers to you when acceleration is constant, then you can do every kinds of calculation during the motion, which means if a particle having initial velocity like this at t equals to 5 seconds, what is the velocity of the particle when acceleration is given to you? So that kinds of thing. And whenever particle fall from the height up to height h, and if gravitational acceleration is given to you, then how much time it will take to reach to the ground, that kinds of calculation we can easily do with the help of kinematic equation. So kinematic equation when refers to that, we have three types of kinematic equation when we can apply when acceleration is constant, which is v equals to u plus at, v square equals to u square plus 2as, and s equals to ut plus half at square by 2, where s is the displacement, v equals to final velocity, u equals to initial velocity, and t equals to time taken by the particle. So here are three major equations so that we can solve kinematic. We can study about any particle at any time period to finding velocity, acceleration, you can say displacement of the particle. Got it? So these are same thing which I have written in front of you. Third equation, fourth equation is what? Okay, that is also same. Now free fall. Free fall is the, you can say, application of your motion equation. Okay. On that case, you just imagine that whenever particle moving in the direction of the acceleration, if direction of motion and direction of acceleration is same, then you can consider acceleration as a positive value. If direction of motion and acceleration value is the, you can say, opposite direction, then you can write negative value of acceleration. Got it? That is the first thing. Second thing which you can be use a acceleration due to in a particular motion. When particle undergoes in the motion under the gravity, then acceleration comes to the g, and g acceleration will be written as the 9.8 meter per second square, and rest of all of this thing will be same during the calculation. Final velocity, initial velocity, and you can say displacement covered by the particle, it could be measured as a height. Got it? So that is the free fall of a particle. If I talk about the free fall motion of a particle, then we can see that at a particular time, what is the velocity of a particle when I free of a particle from a particular height? Let's say particular height is h, and initial velocity, particle is lying on my hand, so its initial velocity is 0. But I after free this particle, so at time t, its velocity becomes, apply the first equation of motion, you will be right, v equals to u plus at. So initial velocity is 0, final velocity you have to find, v equals to g acceleration acting along the direction of current, along the direction of motion. So you will be right positive value of g. So final velocity you will be right gt. That is your result. So overall, your mainly logical approach will be helpful to finding the, you can say, solving that type of problem. Okay, just apply motion equation according to the direction of acceleration, and just apply according to your calculation. Okay. Okay, let's chat up chapter 3. Chapter 3 is laws of motion. Laws of motion is what? Firstly, force. So in the kinematics, we have discussed particle is undergo inside the motion. So third chapter will give you the laws of motion. Laws of motion means it will refers to us how how particle will undergo in the motion. What is the root cause behind the motion of the particle? Because let's say the pen is on rest in front of me. So if I not apply any kinds of external register, or you can say external activity on the, you can say, this pen, then it will not under the motion. Okay, look like this. So these kinds of thing, whenever we are consider about the what is the cause of motion, that will be understand with the help of laws of motion. Got it? So mainly it directly replied indicates to you there how particle behave in the motion. Okay. So the root cause behind the motion of the particle, or you can say the root cause behind the position changing of a particle with respect to time, is you are applying some external force, or you can say some internal force. Due to some internal or external activity, a particle undergoes in the motion. So main thing behind the motion of the particle is force. So force is defined as, it is defined as push or pull acting on object resulting from its. Mainly the pull and push to the particular object is the called a force. Whenever I lift a pen, which means I am pulling the pen in opposite direction of gravity. That's why it is going according to motion. So that I am applying a force on it. So here are some basic example regarding to force. Is that force can be measured as mass into acceleration. SI unit of force is Newton. And here are some, you can say, diagram like this. Whenever you are having wedge, and wedge having some, a block is situated on the wedge, then you can say the wedge block is moving in the downward direction. Why it is moving downward direction? Because one component of gravitational force is applying a force towards the downward direction of inclined plane. That's why it is going undergo in the motion. So the root cause behind the motion is that we are applying a force, external force is applying on the block. That's why it is moving in the downward direction. Same thing, you can see that a boy is applying a force on the, you can say, rightward direction. That's why block is moving in the leftward direction. So every mainly main kinds of things you can imagine that the root cause behind the motion is that we are applying a force internally or externally on the particle. That's why it feels motion. Okay. Now we have a question so that we can answer. A force F produces an acceleration of a part of acceleration is 5 meter per second square in a body. The same force produces an acceleration 2 meter per second square in another body. If both bodies are tied together, okay, what will be the acceleration producing by the same force? Okay, that is the very common question which I'm asking to you. Firstly, a body whose mass I don't know, but I'm applying a force F, then his acceleration comes to the 5 meter per second square. Then if I write the calculation regarding to you can say force, F equals to m1 multiplied by 5. So what is the value of m1? M1 you will be get F upon 5. Got it? Now second thing, the same force produces an acceleration of 2 meter per second square of another body. Another body whose mass you can say m2 and same force is applied F, then particle m2 body having acceleration is 2 meter per second square. So again, right, force will be m2 multiplied by 2. So m2 value you will be get, you can say F by 2. Got it? So there is the mass of m1 and m2. So now question is asking, when two bodies are joined together and I applying same force, then how much acceleration it will get by two bodies, that is A dash. So that is m1, that is m2. So again you are applying same force, the F you will be written as m1 plus m2 multiplied by A dash is the acceleration. So m1, m2 is what? F upon 5 and F upon 2. So F you will get F upon 5 upon F upon 2 multiplied by A dash. So after doing this calculation, you will get 7F upon 10 and 10F. So you will get 10F equal to 7F. Okay, not 7F. Okay, 7F multiplied by A dash. F to F will be cancelled. A dash you will be right 10 by 7. That comes to be 1.4. So which one option is correct? That is 1.4 meter per second square. Everyone understood what is problem is saying? Everyone understood? Sir, how many chapters are there for today's session? Mainly our target is we have to complete class 11th. Okay. So we are reaching at class chapter 3. Got it? Okay. So when will be the break in time? Okay, I will give the, you can say, response. I will give the notify about it break. So question I have already solved in front of you. Next, effects of force. Effects of force. A force applied to an object can be produced several effects. First, move a stationary object, stop an object, change the speed, change the direction of motion, change the shape of object. All of these kinds of things you have already familiar about it. Stationary object can be moved, moving object can be stopped, change the speed, okay, and change the direction of motion. It is also possible, and change the shape of the size. So effects of force can be possible. Now, forces in mechanics. How many force are we can study in the physics? So mainly force is can be classified into two parts, which is contact force and non-contact force. Contact force means whenever I am applying a force on a particular body, so applying factor and the body both are contact to each other. That means force R is called contact force. For example, forces that arise due to physical contact between two objects. That is also simple. Whenever I applying a force on the marker on the pen, then my body and this pen are contact physically to each other. That means I am applying contact force. And whenever two bodies does not contact physically to each other during the force applying, then that will be called non-contact force. Okay, these force cannot act from a distance. The force is exerted only when the object are touching. I think this statement may be wrong. Force is exerted only when the object are touching. It's not 100% true, because there are some, okay, contact force, okay. It's the definition of contact force. So in the contact force, it is possible. Contact force can be applied when both objects can be touched. Okay. Let's talk about forces, contact force examples. Friction for what? Whenever any body is, you can say, moving on the surface, the friction force is always opposing the relative motion of the two surfaces. Okay, always opposite to the relative motion of two bodies. So friction force is the contact force, because it is acting between two contact of the surface. Normal force is the also contact force, because it is always acting normal to the surface of the another surface. Tension force is also contact force. Spring force is also contact force. Let's talk about the non-contact force. So non-contact force has a simple definition. Whenever two bodies does not have a physical contact during applying a force, that is the called non-contact force. These forces are act from a distance. These are also called action at a distance force. Okay, that is also called non-contact force. Now forces in the mechanics. So types of non-contact force which we are dealing with: the gravitational force, that is also non-contact force; electrostatic force, that is also non-contact force; magnetic force, it is also non-contact force. So these forces does not need any physical contact to acting on a particular body. Okay, so these are non-contact force. Let's talk about the force. First one, balanced force. Balanced force means when a particular body there are few forces which are acting in the different direction. So if two forces are acting in the opposite direction, that they could be balanced to each other and body still remain on the rest. Okay, so balanced force is what? Balanced force are two or more force acting on an object that are equal in magnitude but opposite in direction. That could be same thing. What if I tell you, if a block, you are applying a force F in the rightward direction, another person applying a force F in the opposite direction. So both forces are having equal magnitude but in opposite direction. That means net force on the block will be zero and block still remain in the, you can say, rest. So that is called balanced force. Effect on balanced force: do not cause a change in the object of state of motion. Yeah, object state of motion of the object will not be changed. Okay, and second thing, the object remains at rest or continues to move at a constant speed in a straight line. Okay, which means if any particle moving in the constant speed, okay, and during this constant speed, you are applying a force in the rightward direction and you are applying the force in the leftward direction. The net force on the particle will be zero. That means the initial velocity of the particle will be again same whenever you are applying the force, because net force is zero. Got it? So that's why particle still remain its original, you can say, state. It could be motion and it could be rest. So it depends upon how much force you are applying in which direction. Okay, let's talk about example. A book resting on a table, gravity pulls the book down while the, okay, same thing. Let's say book is standing on the table, gravity pulls books in the downward direction, let's mg force, and normal reaction force applying on the opposite direction of, you can say, gravitational force, and both are balancing to each other. That's why book will stay in the, you can say, desk. If any one of force having different magnitude, that means book will be motion according to, you can say, higher magnitude direction of forces. If normal reaction is higher than, you can say, gravitational force, then book moves to the upward. If gravitational force is greater than normal, then book moves to the downward direction. Okay, let's talk about types of force. So types of force means, firstly, balanced force we have already discussed. Unbalanced force means those force which are acting in the opposite, you can say, different direction with, you can say, with different magnitudes. That means particle is not in the, you can say, is on rest, or you can say particle having does not feel F net equals to zero. Then that forces are called unbalanced force. For an example, unbalanced force occur when the force acting on an object are not equal in the magnitude and direction. The net force is not zero. That is the same thing when two forces which have different magnitude and having some different direction, that's and result is that net force on the body will not be zero. So that forces combination are called unbalanced force. Got it? Effect of unbalanced force: cause a change in the object state of motion. Cause a change in the object state of motion. Okay, that can be, it can be change state of the motion if forces are unbalanced. Why? Because unbalanced force F net is not zero. F net is not zero, which means particle having some acceleration. If particle having some acceleration, that means it will change its velocity with respect to time. So that's why if particle changing velocity with respect to time, means its state will not be constant during the unbalanced force acting on the object. Got it? So it could be accelerated, it could be deaccelerated, depends upon the direction of the net force. Is it, if net force acting along the direction of motion, particle will be accelerated. If force acting opposite direction of the motion, then particle will be non-accelerated. It means deaccelerated. The object will move in the direction of the greater force. Okay, which force will be greater? Object will be moved in that direction. For example, kicking a stationary football, your foot applies an unbalanced force, causing the ball move in the tug of war. Okay, there one team pulls harder, the rope moves the direction of the strongest team. Same thing we can see that whenever rope pulling you are feel in your school time, when 3 persons are standing in front of you, you are applying just 100 Newton and 3% applying 300 Newton. Then rope will be shifted on that side where larger value of force is applying. Okay, so that is the example of unbalanced force, and this is the example of balanced force. 300 Newton apply on the rightward, 300 Newton apply in the leftward, and if force are same, then rope will not be, you can say, move. So that is called balanced force. Let's talk about the inertia. What is inertia? Inertia is the, you can say, opposing nature of any particle to changes its, you can say, state, or you can say it is the tendency of an object to opposing its change. opposing its state change. For example, the definition is saying inertia is the natural tendency of an object to resist any change in their state of rest or motion. For example, I have my phone, okay, and if I want to move my phone in the, you can say, particular direction, then I applying a force. So this phone does not want to change its motion. So this phenomena on which object having tendency to resist to change its motion, this phenomena is called inertia. This inertia is mainly based upon mass. A particle who have higher mass, whose inertia having more. A particle having lower mass, his inertia is less. It can easily move. And particle having higher mass, it will be difficult to move. Okay, that is the inertia. What is the type of inertia? Inertia have three types. First, inertia of rest, inertia of motion, and inertia of direction. So it's totally depending upon how much you how type of motion you want to perform from the particular object. If an object is on rest and you want to move this, or if you want to this object having some motion, then if you're applying a force when particle is on rest, that's that tendency of a particle when it opposing your, you can say, your state of motion, that inertia is called rest. Okay, so particle is on already rest, then inertia is called, you can say, inertia of rest. Inertia of motion is same, tendency of a particle keep moving with the same speed, that is called, you can say, inertia of motion, and it's also oppose the direction also. Inertia of direction is also same, when particle maintain the same direction of motion, that will be called inertia of direction. Got it? Now let's talk about the Newton's first law of motion. So Newton's first law of motion is totally based upon the law. It is also called the law of inertia, which means if any particle, if you are not applying any external force, on the particle, that means particle will always be on his initial state. Which means if you are not applying any external push and pull on the particle or any object, then particle will not change its state. It will always be in its initial state. That is the Newton first law. Okay, so mainly question Newton first law is saying an object remains at rest or uniform motion in straight line unless acted upon by external unbalanced force. Okay, so if you are applying unbalanced external force, then particle can be changed its state. So that is the, you can say, Newton's laws of statement. This law mainly apply whenever you are whenever you are, you can say, projecting a rocket inside the, you can say, space. Then you can see that after reaching the space, rocket have constant velocity, and it again moves to the any kinds of direction without you can say changing its speeds, without changing its direction. Because why? Because no external force are acting on the rocket in the space. That's why it has always continuous moving in its initial state. So according to Newton's first law, if no external force is applying on the particular body or a rocket, or you can say any kinds of object, its states remain same always. That is the Newton's first law. It mainly refers law of inertia. Any doubt regarding to this? Okay, let's talk about the momentum. What is momentum? Momentum mainly defines to you if any mass body having some velocity v, then momentum mainly defined to you that any particle of object, how much speed it have and what is the direction of it. With the help of directly momentum directly referred to you, it is the physical quantity which describes the motion of an object. Okay, how particle motion along the, according to the direction of the, you can say, according to velocity. Okay, it defines the product of the object of mass and its velocity. So mainly momentum mainly defined, it is the vector quantity which is defined as mass multiplied by velocity. Momentum, it is the vector quality, unit is kilogram meter per second. You can easily find with the help of dimension formula. Dimension formula will be mass LT minus 1. Okay. Importance of momentum in observation. Mass effect. And second, speed effect. Heavier bodies need more force to start, stop in the same time. Obviously, that kinds of thing we can identify with the help of momentum. If any body which have constant same, if three bodies who have same velocity but have different masses, then momentum will clarify to you that which body will get, which body will have higher inertia, so that it will stop very difficultly. Okay, on which body, if I apply external force on it, on which body uh, will resist more during the motion, okay, opposite to the force. So that kinds of thing we can be say with the help of momentum due to mass effect. So for example, if a truck is moving 50 kilometer per hour, okay, and another car is moving with the 10 meter per hour, and I apply you can say wall, and the truck mass is 100 kg and car mass is you can say 10 kg. So both of them having same momentum, but the truck is heavier than you can say car. So wall could have more wall will have more difficult to stop truck, not a car. So that kinds of thing information we can be find with the help of momentum. Second thing, speed effect. Higher speed, more stopping force needed. For example, bullet. Bullet have very smaller mass, but it have higher velocity. So stopping the bullet is very difficult. How difficulty I can assume because its momentum is higher. So with the help of momentum, we can easily clarify that how much difficulty I will face whenever I change the state of the particular object. Got it? Now let's talk about this Newton's second law. So Newton's second law mainly refers to you the change in momentum phenomenon. If you want to change the momentum of a particular body, then you need to apply a force. And if you apply a force, then rate of change of momentum will directly proportional to applying force, which gives to you F is directly proportional to mass, we already know, and F is also proportional to rate of change of momentum. So if I combine these two quantity, then F vector you will get m dv by dt if mass of the body is constant, and dv by dt is what? Rate of change of moment. Rate of change of momentum can be read m dv by dt, and dv by dt is the rate of change of velocity. So rate of change of velocity can also refers to you m into a. So that is mass into acceleration product will give you the force on any body. So mainly Newton's second law mainly states to you the rate of change of momentum of an object is directly proportional to the applied unbalanced force on the occur in the direction of the force. Mathematically, it is written as F vector is equals to ma vector. Whenever you are applying unbalanced force on the particular body, then body changes its momentum. So rate of change of momentum at a particular time that will comes directly equal to F external applying on the back on the you can say object. Okay, so Newton's second law mainly states to you rate of change of momentum. Again, it is the common factor derivation of Newton's second law. I have already derived you. Rate of change of momentum can be written as m dv by dt, and dv by dt can be written as F equals to m into a vector. So this is the simple derivation which I given in front of you. Relation with the Newton's second law. So Newton's second law you can be act like that. If a body you can say this is the body and force is acting along x-axis, this is acting along y-axis, and let's say these forces are acting along z-axis. So if three forces are acting in different axes, that means momentum will be changed in different axes also. So particle velocity could be changed along z-axis, velocity change, and along x-axis, velocity can be changed. Velocity can change, and along y-axis velocity can change. So if velocity is changing by applying the external force, so I can write fx, I can write m multiplied by dvx upon dt. Okay, fy I can write m dvy upon dt, and fz I can write m dvz upon dt. So I can also write fx is m into ax, fy equals to m into ay, and fz will equals to m into az. So main key points of the statement made is that whenever force is applying in the different direction, then momentum will be changing in the different direction also. If momentum changes in the x direction, then you will be right. Then you can see that particle having acceleration along the x-axis. Then the force applying on the particle along the x-axis, you will be right m into ax. Similarly for m into ay, similar for m into az. That is the relation with the Newton's second law with acceleration. Okay. Here are some examples regarding the Newton's second law. Kicking of football, that is your example. Catching a cricket ball. So catching the cricket ball means ball is moving in front of your hand. So ball having some motion. You are applying external force by the hand. That's why ball gets stops. So momentum of balls getting stopped. So firstly, ball having momentum mv, and suddenly momentum becomes zero. That means momentum it's changed. If momentum is changed, that means you are applying external force on the ball. So that is the, you can say, example of Newton's second law whenever you are catching the cricket ball. Similarly for car acceleration, let's solve this question which is based upon Newton's second law. A body of mass 4 kg initially at rest, a constant force of 8 Newton act on it for 5 seconds, then find the final velocity of the ball. So that is the simple question based upon the Newton's second law. The force you will be write m multiplied by dv by dt, which is rate of change of momentum. So m you will be write 8, that is force, and mass of the body is 4, and rate of change of velocity. Final velocity we have to find. Initial velocity is 0 because particle is on rest, and time duration will be 5. So you will be get 4 ones are 4, 4 twos are 8, and 5 twos are 10. So final velocity you will be get 10 meter per second. Got it? Which one is the correct answer? Option B is the correct answer. So you can solve this type of question with the help of this. You can say with the help of this simple formula of Newton's second law. Got it? If anyone have any doubt, he and she can ask me. Let's solve the second question. That after the third question, after that I will deal with impulse. Okay. Okay. Let's solve the second question. A body of mass 2 kg is moving with velocity 6 meter per second. A force is applied to bring the to it rest in 3 seconds. Find the magnitude of the force. Okay, again simple question. F you will be write m, again dv by dt. So F you will be write m. Rate of change of velocity. Initial velocity is what? Initial velocity is 6 meter per second. Final velocity is rest. So you will be write initial velocity is 0. Final velocity is 6 meter per second. So you will write 6. Upon time duration is 3. Mass of the body is 2. So F you will be get 2 multiplied by minus 6 upon 3. That you will get minus 3, and F equals to 6 Newton. So minus 6 Newton means you have to apply a force in the opposite direction of velocity. Got it? So that is the direction. Okay. And magnitude is 6. So correct answer is C. Have you understood how to deal with that type of problem? Just apply Newton's second law and solve the numerical. Got it? Let's solve this fifth question. I think you have to solve this fifth question by yourself and getting the correct answer. So question mainly saying a force of 10 Newton acts on a body which has rest at 2 seconds. If mass of the body is 5 kg, then find the velocity required. That is simple question. You have to do by yourself. Okay. Let's discuss about the next topic, which is impulse. Impulse is what? Impulse, you can say it's like a shock. Shock is what? Whenever you are applying higher value of force with small interval of time, that is called, you can say, impulse. For example, when your mother slap on your, you can say, cheek. So your mother apply a force on your cheek with higher value, with smaller time duration. That's why your impact is so high. Your cheek will be comes to the red. That was the impact. So this phenomena, whenever higher value of force is applying in the smaller duration of time, this phenomena is called impulse. Impulse mainly defined as delta P, which is change in momentum. That is m into dv. Got it? So impulse is the effect produced when the force acts on an object for a short time interval. Got it? And here is the diagram of impulse. So impulse you can be write force applying higher value with a small duration of time. That is the called impulse. So can I write force equals to rate of change of momentum dp by dt? So I can also say F vector equals to m dv by dt. So dt comes to the come with the multiplication of F. So m dv can be written as F dt. Okay. So m dv is what? M dv is the, you can say, impulse. Impulse I can be write I will equals to F dt. So this is the differential form. So this equation mainly shows to you when you have force versus time curve, the area under the force versus time curve will give you the impulse value. The area under the force versus time curve will give you the impulse value. Similar kinds of thing, if you have a particular time interval, let's say delta t, then impulse you can be written as J equals to F times of delta t. And similarly, if you want to find differential form, then you can be just write F dot dt. After integrating this equation, you can find impulse for a particular time duration. Got it? Impulse is the vector quantity. The unit of impulse is Newton into second. Again, impulse momentum theorem. So impulse momentum theorem mainly refers to you J. J is the change in momentum. Change in momentum. And if we have already momentum, if we have already J given, J will equal to M V minus M U. So M into V directly will give you J plus M U. That is the impulse momentum equation. Whenever impulse is given in a question, then you can easily find initial and final velocity. You can find initial and final velocity with the help of this impulse momentum equation mathematically. The impulse of force acting on an object is equal to the change in momentum of the object. That was the simple thing which I have already explained to you. Okay. That was a simple thing. Let's question we have to discuss. If force varies with time as shown, it increases uniformly from 0 to 20 Newton in 2 seconds, then decreases uniformly from 0 to in next 2 seconds. Find the total impulse. I think diagram should be given. Firstly, initially force increases in 2 seconds is 20 Newton. So I can write the diagram. Force increases up to 20 Newton in 0 to 2 seconds. 0 to, you can say t equals to 2 seconds. Got it? And after that, then decreases uniformly to 0 in next 2 seconds. After that, it uniformly decreases from next 2 seconds. That means at 4 seconds come back to the 0. You have to find total impulse. What is the impulse? Impulse is the area under by the Ft curve. Got it? Area under by the Ft curve. Here are the triangle whose height is 20, base is 4. So impulse you will be right 1 by 2. Base is 4 multiplied by height is 20. So impulse you will be get 2 or impulse you will be get 40 Newton second. Got it? I have already told you that if you have a force and time curve, then impulse you will be written as area under by Ft curve. Laws of conservation of momentum. That is another same thing. When external force on the body is 0, if net external force on the body is 0, then momentum of the body will always conserve. For an example, if a body having some changing its velocity, but external force is 0, then I can say that P initial will equal to P final, or we can say that delta P is 0 for that case. Because if external force is 0, that means delta P is also 0. Okay. So laws of momentum conservation is that the total momentum of isolated system of interacting particle remains constant. Okay, that is the simple thing. For two masses m1 m2 with initial velocities u1 and u2 and final velocity v1 and v2, then total initial momentum can be written as m1 u1 plus m2 u2. Final momentum written as m1 v1 plus m2 u2. So mainly laws of momentum is saying to you initial momentum of both particle m1 has velocity u1. Particle m2 velocity is u2. After that, particle m1 velocity becomes v1. After that, velocity of particle m2 is v2. So according to momentum conservation, initial momentum can be written as m1 u1 m2 u2 will equals to m1 v1 plus m2 v2. That is the simple thing. And initial momentum of complete system will equals to in final momentum of complete system. That kinds of thing will be applied when external force is 0. Let's talk about third law of motion. Third law of motion is mainly states to you whenever you are applying a force on a particular body, then this body will apply a reaction force on a first body. That relation is also called action-reaction phenomena according to Newton's third law. So Newton's third law mainly saying to you, for every action, there is an equal and opposite reaction. Okay. This means that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force in the first object. That is the simple thing. That is the main example regarding to action reaction force. You can say whenever you are jumping on a particular surface, when you are jumping on a particular surface, then firstly your legs apply a force in the downward direction to the surface. Then surface will apply upward force on yours. So you are applying less value of force in the surface, so surface is very large, it will not move according to yours. But when surface apply your same amount of force on yours, then your body is light, so you will be moved in upward direction with certain height. So that is a phenomenon of jumping that is totally based upon Newton's third law. Similar kinds of thing you can be assumed as a rocket explosion, rocket moving inside the sky. You can see that the gas exert a pressure on the surface, then surface again will apply a force to the rocket. So higher value of force applying rocket on the surface, then that equal amount of force higher value apply surface on the rocket. So that's why rocket fly in the, you can say, space. So that kinds of thing we can study in the Newton's third law. So for example, if you are standing on a particular object like this, and object is applying force on the surface like F12, surface 2, and that is surface 1. So object is applying force is applying due to surface 2 on 1, then object is also applying force on surface due to 1. So that is called F21 will equals to minus times of F2, F12. So main thing is that forces having same magnitude but direction is opposite. That is called Newton's third law. That is again example jumping. I have already told you. Recoil of a gun, again same thing. Whenever you are firing a gun, then gun having some velocity in the forward direction where your target is given in front of you. But suddenly guns also having some reaction force due to bullet. This action reaction pair is the example of, you can say, Newton's third law. Got it? So these kinds of things you have to understood. Let's solve some particular question regarding to this. A gun having mass 2 kg fires a bullet of mass 0.01 kg with velocity 200 meter per second. Find its recoil velocity. Again, that is the example of Newton's third law. So you have to apply your Newton's third law of motion to find the answer. So in the overall journey, whenever you are shooting a particular bullet from the gun, then you are not applying any external force on the bullet and gun. Just because of internal mechanism, bullet is firing to the target. So main thing is that external force is 0. That means no momentum will be changed of both guns plus, you can say, bullet. So we can apply it simply momentum conservation equation. So for example, this is your gun and you are firing a, you can say, bullet. Let's say bullet velocity has v1, and after firing, gun's velocity becomes v2 in the backward direction. So initially guns and, you can say, bullet are on the rest. Initial velocity is 0. Initial momentum is 0, and final momentum, I can say, if guns, if a bullet have mass small m and gun have mass capital M, so you can consider that in the x direction, velocity will be positive. In the negative x direction, velocity could be negative. So you will write momentum will be m multiplied by v1, and velocity is opposite to the gun's velocity, that you will be right capital M multiplied by v2. v2 is the velocity of gun after reaction, and v1 is the velocity of, you can say, bullet after firing. So velocity of gun, you can be right m capital M multiplied by v2 equals to some small m multiplied by v1. Capital v2 velocity of gun will be m v1 by capital M. Let's put the value. A gun of mass 2 kg fires a bullet 0.01 kg mass, velocity 2 meter per second. Find the recoil velocity of the gun. So you have to find v2. So v2, how will you find? You can be find mass of bullet will be 0.01 multiplied by velocity 200 meter and divided by mass of the gun, that is 2 kg. So you can be right. 2 0 2 0 cancel it. 1 2 1 are 2 2 again it will be cut. 1 meter per second will the recoil velocity of the gun. That is your first option will be correct. Everyone getting understand what I'm saying? Is it understand? Is it understandable for yours? Which I already told you. Kindly reply. Okay. So we have discussed about the recoil velocity. Okay. Let's talk about the pseudo force. That is also interesting force. Okay. So pseudo force is what? Whenever you are doing the calculation of Newton's second law, then you can see that this Newton's law is totally depend upon a frame of reference. This Newton's second law is totally depend upon frame of reference. For an example, let's consider, according to this notes, apparent force observed in the non-inertial frame make Newton's second law valid in that frame. occur when the frame of reference is accelerating with respect to initial frame, then F pseudo force is the mass into a area of frame of reference. For example, I am just giving a simple approach to you. For example, whenever you are standing on the car and you are standing in front, a block is standing in front of you, that is the, you can say, movable surface, and one of person is standing on the, you can say, ground, and one of person is standing on the, you can say, movable object. Okay, so let's say this object is moving in the you can say rightward acceleration. So according to this person, this block is rest according to yours, but according to this person, this block having acceleration a. So can I say, according to this person, if I ask to this person how much force is applying on this block, then this person is saying if a acceleration is acting on the block in the rightward direction, if this block having mass m, then I can say that force on the block will F will equals to m into a. That is the good. That is the true. But according to this person, this block is on rest. If block this is on rest, then acceleration of this particle will be zero. If acceleration of this particle will be zero, then it is saying no, force is zero. So who is right? Who is right? Block feels force, or block feels does not having any force. So the clear statement is that yes, for block is feeling some force. But what is the contraflict of this statement? Why this is showing zero force? So to solving this problem of this both statement, we are considering when you have a, you can say, initial frame of reference. When you have an initial frame of reference, then you can consider opposite. You can consider you can say apparent force. When you have an initial frame of reference like this, you are standing on the movable object and object is moving with the a acceleration. So solution of this problem is that you can consider you can say apparent force, which is always acting opposite direction of the acceleration. That could be called Fp, that is pseudo force. And this apparent force value will come to be m into a. Got it? And its direction will be opposite direction of the acceleration. So this phenomena was introduced as a pseudo force to solving this type of problem. So mainly this problem mainly contradict the Newton's second law. On that case, Newton's second law are failing. So to resolving this problem, we are considering the acceleration's opposite direction force will be applied. That will be called pseudo force. And this force is not actual force. This is your assumption to finding the right calculation. Got it? So that is the pseudo force formula. So that is the few things which I am asking to you. Apparent force observed on a non-inertial frame to make Newton's second law valid. That nature. That is the good thing. Occurs when the reference frame is accelerating with respect to an initial frame. That is the second thing. Pseudo force will be applied m minus times of m into acceleration of the frame. Minus sign means opposite direction of the acceleration. Second thing, always acts opposite to the direction of the non-inertial frame. That is the again same thing. Not a real force, has no physical source. Okay. Magnitude proportional to the mass of the body and acceleration of the frame of reference because of same of formula F equals to mn. Example, in a bus accelerating forward, passenger feels a backward push due to a pseudo force magma acting opposite to the bus. Acceleration is the frame of reference. That is also example of, you can say, pseudo force. Whenever bus suddenly stop, you are feeling a force in the forward direction. That means pseudo force is applying in the opposite direction of the acceleration. Got it? Let's consider this lift diagram also. When lift is moving with g acceleration a, then how will you find your actual weight? Let's say lift is moving with g acceleration towards upward. Then pseudo force will be act in the downward, and gravitational force is also acting in the downward direction. The net force acting on the, you can say, particle will be mg plus ma in the downward direction. So can I write m into a effective or a net equal to mg plus ma? M to m will be cancelled. So a effective you will get g plus a. Okay. So that is the calculation of, you can say, acceleration, you can say net force with the help of pseudo force. Okay. Whenever lift is moving with downward with a acceleration. So with a acceleration, when lift is moving downward, then you can assume that if a block is putting inside the lift, then gravitational force acting in the downward direction and pseudo force is acting in the opposite direction. The net force acting on the, you can say, block F net will be mg minus n into a, then a net you will be get g minus a. Got it? So this is a simple phenomena of the lift. So this is the, again second thing which I am giving to you. If a equals to g, then net force will be zero. If net force will be zero, then you will be feel as a weightless. Got it? And if a is greater than g, that means net force acting in the upward direction. That means your weight comes out to be lesser value to the actual value. And if g is greater than a, that means your weight has increased as compared to actual value. That kinds of thing you can be identified with the help of g case. Okay. So that kinds of thing I have already discussed to you. Let's solve this problem. A person is standing inside a lift accelerating upward with acceleration 2 meters per second. What is the direction of the solar force in the person? Again, same question. Lift is moving upward direction 2 meters per second square. Acceleration of the lift is 2 meters per second square upward. Then pseudo force will be act in the downward. So option B is the correct answer. Got it? Okay, let's talk about a friction. Then how much part has left? Okay. Again, few things are still pending. Okay, let's talk about the friction. So earlier or case, we are not dealing with the friction. Friction is what? Friction is the force which is always acting to oppose the relative motion of the two surfaces. For an example, here is my phone. When I want to move my phone on my surface, on my hand, then according to this point, my hand is moving in the backward direction. So friction force will be act in the forward direction to stop this relative motion. So friction force mainly act to, you can say, stopping the relative motion between the, you can say, two surface. So that is the contact force between two forces. So friction force is the component of the contact force parallel to the surface in the contact that opposes impending or actual relative motion between them. It always opposes the relative motion between them. It has three types: static friction, kinetic friction, and rolling friction. Static friction means from the rest of the particle, from the rest of the object. Whenever I want to move this object from the rest to motion, then on that time when particle, then friction force acting from a rest position, and it has some maximum value, so that particle does not having, you can say, relative motion when particle is on rest. That type of friction force is called static friction, and it always having maximum value because it applies over whole power, so that relative motion will not occur. So that's why it apply its maximum value. So that is the static friction. Kinetic friction is about when object is already moving and friction force during the motion of the particle to oppose the relative motion from the surface, that is called kinetic friction. Act when objects are sliding past each other. Okay. And rolling friction, when object is rolled on the surface, then friction force due to rolling surface is called rolling friction. Okay. A block sliding or rest on a rough surface. Let's talk about the static friction. Static friction, again same. Firstly, object is on rest. You are applying a force in the rightward direction. So this point, according to this second one point, which are acting on the surface. So according to this point, this surface point, when object move in the rightward direction, so we can say this point is moving in the leftward direction. So friction force will be applied on this particle in the leftward direction. And similarly, according to this point, this particle is moving in the rightward direction. So friction force will be applied in the leftward direction. So friction force will be applied in both contact point in the different directions, so the relative motion will not occur. So this friction force, when object is on rest, then applying a force to so that particle can be moved. This friction force is called static friction, and the static friction maximum value is mu s multiply n. Mu s is the coefficient of friction, which depends upon roughness of the surface, or you can say roughness of the surface mainly depend, or n is the normal reaction force which are acting in the perpendicular to the surface. Okay, so that is the static friction. Okay, acts when the object is on rest but force is applied. It prevents the object from the starting to move. Maximum static friction is given by. Okay, and same thing which we can say limiting friction. Maximum force of static friction just before the object starts moving, it's equal, you can say F net. It is simple. The maximum value of static friction, so the object can't be moved. That is called limited friction. Again, kinetic friction, same thing. When object is already moving in the particular direction, then friction force during the motion of the particle to oppose the relative motion, that is called kinetic friction, and it is always smaller value than static friction. So static friction is greater than kinetic friction. Got it? This is your second thing which you have to understood. So mu k is less than mu s. Sorry. Yes, that is correct. Mu k is less than mu s because kinetic friction coefficient will be less than to the static friction coefficient. Here is the some graph by which you can understand. At limiting side, at point A, static friction is maximum, but according to point B, static friction having maximum value at point C. So Fk is less than Fs according to this diagram also. Got it? Advantages of friction and disadvantages friction also we can also say that. So first advantage of friction is that whenever I'm writing something in front of you in the screen. So I am writing my pen on my pen tab. So my pen tab applying a friction on the pen, and my pen is also applying a friction on the pen tab. So that with the help of this friction force, I can write something in the, you can say, on your screen. Similar kinds of thing we can also imagine whenever in the school blackboard you are writing something on by the chalk, then chalk apply the, you can say, friction opposite direction of your writing, and forces also apply a friction in the opposite direction of the chalk. So that kinds of thing you can say with the help of friction force you can write something on the blackboard. Okay. Second thing, helps to walk uh, on the surface. It provides a grip between feet and ground. Because after absence of friction, you will be totally slip on the surface and accidentally fall on the surface. Allow friction to move. That is also same thing. Enables brakes to the stop of the vehicles. Also, if I talk about the, you can say, whenever any ball you are applying, whenever every ball you are moving in the particular direction, so suddenly it sometimes suddenly it stops after some time. Why? Because of friction and because of air resistance also. If I neglect the air resistance, then ball will be stopped because friction will be applied on that case. Okay. So enables brake to helps to holding and gripping object, that is also provide traction for climbing or running. That is also same thing. These kinds of things will be advantage of the friction. Second thing, friction always loss your energy. If I talk about vehicles phenomena, definitely it helps to move a vehicle, but it also loses the energy of the fuel. If I talk about particular statistics, the 30% of fuel energy has been lost due to friction. Okay, so that kinds of it also reduce your efficiency of the energy. Okay, suppose motion cause extra effort, that means it will lose your energy, cause wear and tears of moving parts. Okay, it sometimes whenever every machinery parts are working during the some, you can say, instrument, then it can also affect their parts also. Wastage energy as heat during the motion, that is also third thing. Reduces efficiency of machine, I already told you. Requires frequent maintenance due to damage. Yes, that kinds of disadvantage of the friction. Got it? So here are few things regarding to friction which I explained you. Why it stopped? Oh shit. Okay. Now is it visible? So everyone understood what I'm saying? Everyone understood whatever I told to you? Everyone who have any doubt, he and she can ask me. Someone is still replying, sir, when will we get notes, sir? We will get notes. Kindly wait, bro. Kindly firstly watch this lecture. And if you have, after completing this lecture, the notes will be provided to yours. Okay. Okay. Any doubt regarding to this explanation? If anyone who have any doubt, he and she can ask me. Okay. Nobody else? Let's continue our next topic. So let's continue with the uniform circular motion. Okay, and after that, what chapter is left? Uniform circular motion. After that, work power energy. Okay, that is also very simple. We will complete it. And conversation of mechanical energy, unit of power. Okay, collision, and then we can continue. Okay, So within 1 to 1.5 hour, we can complete this complete PDF. Okay. Where we had completed. So let's talk about uniform circular motion. How circular motion will be performed when particle having some motion in the particular direction with constant velocity, and suddenly a force is applied in the, you can say, perpendicular, always perpendicular to the velocity. Invert the, you can say, perpendicular to the perpendicular force applying on the velocity. Then on that time, particle motion comes to the curve linear motion, and that curve linear motion, or in this case, is called circular motion. So motion in a circle at constant speed but changing direction is called uniform circular motion. That is called also same thing. When a particle is moving along the circle, that is called the circular motion. Why circular motion is happening? Because whenever particle having velocity in the tangentially, but a force is applying in the perpendicular to the, you can say, perpendicular to the velocity, then on that case, at every case, if force is applying perpendicular to the velocity, so that motion will combine into the circular motion. And what is uniform circular motion? When particle does not changes its speed during the complete circumference, that circular motion is called uniform circular motion. Velocity is constant in magnitude but changes its direction. Yes, velocity magnitude wise will be constant, but it will change its direction. The motion is accelerated. Acceleration is called centripetal acceleration. Okay, few things which I explaining to you. If velocity is constant in the circumference, that means no acceleration taking a part of this, you can say, along the circumference. So if no acceleration is acting on the particle, that means no external force is applying along the circumference. So one of only single force is applying in this towards the center, that will be called centripetal force, that is FC. So acceleration due to this centripetal force is called centripetal acceleration. So FC is called centripetal force. That value will be mv square by r, and m into AC will equals to mv square by r. So centripetal acceleration will be v square by r. Got it? So that is the few things regarding to centripetal acceleration. And centripetal force I already explained you. That is the responsible to moving of a particular object according to circular path, because it's always act perpendicular to the velocity and always directed towards the center. So net force toward the center during the circular motion is called centripetal force, and centripetal force value will be mv square by r. Got it? So here is the magnitude, and here is the direction of the centripetal acceleration. I already told you. Vehicle on a circular road. Okay, when any vehicle are covering some distance in the circular road, then what kinds of thing is happening during the circular motion? Okay, let's discuss this kinds of thing with a brief, you can say, diagram. Okay, I'm explaining to you. Let's say a particular circular track which is acting like this. Okay, I'm drawing with separately. Okay, here is the circular track. Okay, I'm drawing one more thing. Here's the highway, which is along, you can say, circular track. Okay, and here is the car who have velocity v. So at every turn, velocity is tangential. At every turn, velocity is tangential. Okay. Okay. So main thing is that whenever you are inside in the class, inside in the car, then you can feel that outward direction force is applying on the, you can say, car. That will be called centrifugal force. Whenever you are studying in the car side, centrifugal force. Okay, and whenever you are studying outside the, you can say, circular part, then it is called centripetal force toward the center. That kinds of thing we can consider. Okay, so according to centrifugal force, which are acting always outward direction of the circular path, and circular path having radius r. So main thing is that during the driving, when I increase the velocity, centrifugal force value will be mv square by r. So when I increasing my velocity during the complete circular path, centrifugal force is always increasing with respect to velocity. So it could be possible that after reaching the certain value, car directly comes out to the circular path. And let's say if it is the water ocean, then due to this phenomena, car directly drop into the ocean. and the accident will occur. How can we solve this problem? So main thing is that if it is the road, so road must have applying a friction. Road must have applying the friction. So if I talk about here is the circular track and here is the center on which I am calculating centrifugal force. That is the 2D diagram. Okay. So centrifugal force acting on the outward the circular track, which is mfc, which is mv square by r. And let's say these tires are moving with certain velocity due to centrifugal force, but one of another force on the road will be applied to oppose the relative motion of this, you can say, tire. That is called friction force. So can I say that if friction force can be balanced centrifugal force, then this car, or you can say this object, will not fall in the ocean. So we have to maintain some certain velocity on which friction force can be balanced to the centrifugal force. So friction force on that time will be act as the kinetic friction, or you can say as a, you can say static friction also. So friction force, kinetic friction will be act as mu k multiplied by normal force, that will equal to mv square by r. That is the minimum velocity on which you can have during the circular track. Okay. And what is the value of n? N you can be get with the help of this value of normal reaction mg act in the downward direction. Normal reaction force will be n. So n equals to mg. Okay. So minimum velocity, so that you can be safe in during the driving, you will be mu k multiplied by mg, that will be greater than equal to m v square minimum upon r. Got it? M to m will be cancelled out. So minimum velocity you will be get mu g r with the square root value. That is the minimum velocity. So everyone understood how can we use circular motion for solving this that type of real life mechanical problem? So that kinds of thing we have already explained you. That look at here. The vehicle moves in a circle on a flat road. Friction force provides the necessary centripetal force like this, and centrifugal force acting in the outward the circular path. Okay. So small f equals to mv square by r. For limited friction, f max equals to mu s into n equals to mu s into mg. That is also same which I already told you. So f max, v max you will be get maximum velocity so that you can safely move in the circular track, that will be equal to mu s multiplied by gr. Everyone understood this phenomena which I already explained you? Anyone who have any doubt, he and she can ask me during this calculation. Anyone who have any doubt, kindly ask me. If anyone who have any doubt, he and she can ask me. After that, we can continue with our next topic. Okay, I think nobody has any doubt. Let's continue with our next thing, which is numerical. A block of mass 2 kg is placed on a rough horizontal surface with coefficient of friction 0.5. Find the maximum friction force. Oh, that is a very simple question. Block is placed in the horizontal surface. Mass is the 2 kg. And the coefficient of friction, that is mu s equals to 0.5 because it is rest. So I will write static friction. So what is the maximum value of friction force? So friction force will be written as mu s into n, that will be f max. And mu s into n, what is 20 Newton apply in the downward direction m into g, and normal reaction will be opposite direction of the gravitational force perpendicular to the surface. So n will be 20. So maximum friction force you will be get f max, you will be write 0.5 multiplied by 20. That means you will be get f max will equals to 10 Newton, and this is your answer. Understood by everyone? Understood by everyone? That is my answer. Got it? Let's look the third question. A force of 20 Newton is applied on the block. It does not move. The friction force acting on is. What is the answer? Kindly answer this question. I'm waiting for your answer. I can give you only 2 minutes to think about this question. Everyone, be serious. I'm asking a question to you. Kindly solve this question and give me the correct response regarding to this question. What is the correct answer regarding to this question is? What is the correct answer for this question? This is very interesting question. I can give you only 2 minutes. Force of 20 Newton is applied on the block. What it does not move, the friction force acting is. But the friction force acting is. You have to find friction force value. Someone is saying greater than me. My answer is it is wrong. Why? So main thing is that you question is not asking about the what is the maximum value of friction force, because if you are applying 20 Newton force, if block is not moving, that means friction force does not reach its maximum value. It will reach maximum value when I increase the force at a certain limit. If I apply F equals to 30 Newton, if I apply F equals to 30 Newton, that means friction force will apply its maximum strength to stopping this relative motion. That means friction force will apply F max. That could be maybe possible more than 20 Newton. Got it? But in this case, I just applied 20 Newton friction force, suddenly stop this force, suddenly stop this block, which means it does not apply its maximum value. Then the friction force value during this stopping this block will be directly equal to 20 Newton. That's why block does not move. Got it? If you are saying friction force is more than 20 Newton, that means friction force, let's say applying 25 Newton. Okay. So rightward direction force is 25 Newton and leftward direction is 20 Newton is to left rightward and 25 is leftward. So net force will be along the leftward direction, and block should be moved with the 5 Newton force, but it is still stopped. That means both forces are equal. So main thing is that friction force will be vary according to external force will be vary. External force is 20 Newton, then friction force is 20 Newton. External force is 10 Newton, friction force is again 10 Newton. That's why block will still remain rest. Okay, so that correct answer is option C. Everyone getting my point? Understood this question? Who have any doubt? He and she can ask me. Okay, okay. Mohit, what is your doubt? Mohit, what is your doubt? Mohit, you raise your hand. Yeah, say. Explain again, please. Okay, okay, no problem. Main thing is simple. Firstly, look at it, it is my phone, okay? So my hand apply maximum friction up to 25 Newton, okay? But I am applying 20 Newton. But my phone is not moving. Why? Because it can maximum apply 25 Newton. But if apply this force is 25 Newton in the rightward direction, then phone automatically move to the 5 Newton force. With the help of 5 Newton force, phone will automatically move. But I am applying 20 Newton, phone is also applying 20 Newton in the backward direction so that relative motion will not apply. Got it? Now, in this case, it is also saying if I apply a 20 Newton force on a block, block does not move. That means friction force is applying 20 Newton force in the opposite direction. And same thing it is saying, what is the value of friction force acting on it? Then option C is this 20 Newton. But if question is asking what is the maximum value of friction force, then on that time, the option D is correct. It could be greater than 20 Newton. Any doubt? Any doubt? Mohit, did you understand what I'm saying? Mohit. Okay, okay, okay. So that's a new thing which I have already told you, that friction force changing its value according to external force. Let's a question in front of you. A solid sphere rolls on an inclined plane of angle 30 degree without slipping. Okay, find its acceleration. Oh, so this question I think could be mixture of a rotational motion. No, because solid sphere, you can say solid sphere radius is not given. No, I think it could be especially from in translational motion. Okay, so angle of inclination is theta. So it's a simple mechanics related problem. Firstly, gravitational force apply in the vertically downward direction. Okay, so break down this, you can say gravitational force into components. So if this angle is 30 degree, that is 90, that is 60. And if you can say, okay, let's write a separate diagram regarding to it. Okay, so that you can easily understand. Okay, okay. So gravitational force is acting vertically downward, that is mg, that is 30 degree, that is 90, and that is 60. Okay, okay. So if this angle is, you can say, if this angle is, you can say 60 degree, that this angle is again 30 degree, and this angle is 30 degree, then component of mg along 30 degree will be mg cos 30, and this component will be mg sin 30. Got it? Now normal reaction will be act on the sphere in the vertically upward direction. Vertically, you can say perpendicular to the surface, that will be n. So n you will be get mg cos 30, and horizontal force which are acting, find its acceleration. Okay, we need to find acceleration. So n equals to mg. So in the vertical plane, no acceleration is acting. In the horizontal direction, no force is acting opposite direction to the mg sin theta. So F net along downward will be mg sin 30. So acceleration will be mg sin 30 divided by small m to m will be cancelled out. So acceleration will be g sin 30, and g sin 30 is what? 10 multiplied by sin 30 is 1 by 2. So that comes equals to 5 meter per second square. That is your acceleration, and option D is the correct answer. Any doubt? Any doubt regarding to this question? Anyone? Anyone who have any doubt, he and she can ask me. Okay, thank you very much, sir. Okay, no problem. We can't on mic, sir. Okay, if you can't mic on, you can write on the chat bot. Okay. Nithilian, what are you saying? Once again, okay. Simple thing. Question is simply saying mg acting in the downward direction. You have to break down components along the inclined plane and along the perpendicular to the surface. So two forces are acting on the, you can say, on the sphere. So sphere is contact on the inclined plane. So perpendicular force, normal force acting on the upward, and mg sin theta acting on the opposite direction of normal force. So both forces will be balanced to each other. So no acceleration taking a part in the, you can say, vertically downward direction. And in, you can say, horizontal direction, the force is acting mg sin theta. So net force is alone acting is mg sin theta. So F net will equal to mg sin theta. F net will equal to mg sin theta by m. M to m will be cancelled out. G sin theta will be a acceleration, a net, which is acting on the, you can say, sphere. So g sin theta value you will put as the g equals to 10 meter per second, 10 meter per second square, which is already given in the question. So 10 multiplied by 1 by 2, 2 to 10 will be cancelled out. A will be get 5 meter per second square. That is your answer. Got it? Okay, let's talk about the fourth chapter, which is work energy power. This is also very simple question. This is also very simple chapter, and I think it is okay. It is last chapter for your PDF. Okay, no problem. Okay, so let's talk about the work energy power. Work energy power. What is work done? Work done is simple. By applying any external force when object having some displacement along the direction of force with having some angle theta, as well as, then that phenomena is called work done. When you are applying a force, whenever you are applying a force and object getting some displacement, so that phenomena on which after applying a force and for object having some displacement, that phenomena is called work. Okay. Now work done can be calculated with the scientifically with the help of dot product. So work done we can be find F dot S. Okay, and F dot S means what? F into S multiplied by cos theta. Theta is what? Theta is angle between force and displacement S. Got it? So this is a simple thing. So mainly definition is say work done by the force is equal to the product of the force and the displacement of the object is the direction of the force. That is the simple. Got it? If Under a constant force F acting on the displaced through a distance x, the work done by the force will be F dot S cos theta. That is the simple thing. So sometimes we can say that force where A is the, okay, someone is saying where A is the smaller angle, not angle, is the theta. Where theta is the smaller angle between F and S, work is scalar quantity, the SI unit of force work done is joule and CGS is earth. That is the same thing. Unit you have to consider, SI unit of you can say work done is joule and CGS unit is erg, and 1 erg equals to 1 joule equals to 10 to the power 7 erg. Okay, dimension formula you can also consider F dot S M1 L1 T minus 2 multiplied by L1. So dimension formula you will get M L2 T minus 2. So that formula you can be get with the help of formula. Okay. So work done mainly is saying to you whenever you are applying a force on the particular body, that means when body getting some displacement, then dot product of force with the displacement will give you the work done. Okay. Now notation of work and kinetic energy, the work energy theorem. So work energy theorem mainly refers to you that whenever some forces are applying on the body like F1, F2, F3, like this, and part body having some displacement like X1, X2, X3. Okay, so net work done due to all forces will directly equal to change in kinetic energy according to work energy theorem. Got it? We can do some simple derivation, not derivation, we can do some simple question regarding to this so that you can get a better understanding regarding to it. What if I give you a simple question to you, like regarding to work energy theorem, what if I ask you, object is, you can say connected with a string and object mass is small m, a bullet whose mass is small m, whose velocity is, you can say, u. After, you can say, after colliding this bullet inside this capital M mass m, it immerses in the small m, capital M mass, and it both system reaches to particular height. Okay, and after that, their velocity becomes 0. So, what is the maximum height gained by the body? What is the maximum height gained by these two bodies? That kinds of problem we can solve with the help of work energy theorem. So firstly, whenever bullet immerses inside the, you can say, capital M mass, this mass comes to the height h. What is the work done by the, you can say, gravitational force? Work done by the gravitational force will be capital M small m multiplied by g multiplied by h, and it is negative value. Why? Because force acting in the upward direction, force acting in the downward direction, body moves to the upward direction. So you will write minus capital M plus small m into g into h. That will equals to change in kinetic energy. Final kinetic energy will be 0 because velocity becomes 0. Initial kinetic energy will be half m u square. So initial kinetic energy will be minus half m u square. Minus to minus will be cancel out. So h you will be get m u square by 2 capital M plus small m. So with the help of work energy theorem, you can do this type of calculation. So main thing is that you just understand that work done by the all forces, that will be equal to change in kinetic energy, and with the help of different situation analyze by yourself, and you can find any kinds of, you can say, question which is asking into your examination. Okay, so that is the simple example which I given in front of you. Work energy theorem mainly refers to you that whenever different forces acting on the body, then work done due to all forces, that will be equal to change in kinetic energy, and change in kinetic energy you will return Ke final minus Ke initial. Got it? So this is your simple formula. Okay, let's move the particular question. A force of 10 Newton acts body, it displays by 5 meters in the direction of force. Find the work done. Simple. Work done will be force dot displacement. Direction of force means theta equals to 0 degree between them, because direction according to force and displacement having same direction, that means theta equals to 0 degree. So work done will be F into S into cos, and displacement is 5 Newton, cos 0 equals 1. So work done you will be get 50 joule. This is your answer, and option B is the correct. Any doubt? He and she can write. Okay, someone Nithilian. Okay, Nithilian, in which slide you have a doubt? You told once again, sir. Okay, I think it could be previous. Okay, so any doubt regarding to this question calculation? Okay, nobody has. Let's solve about the kinetic energy. Kinetic energy is very simple. It is the type of energy whenever particle having some motion and it has some velocity v, then energy on that particle whenever it is undergoing in the motion, that energy is called kinetic energy. And kinetic energy is called k equals to half m v square. V is the velocity of the particle. It is the scalar quantity because energy is the scalar quantity. So you can directly add with the simply algebraic sum and subtraction. It represents the energy possessed by the body due to its motion. Greater mass of greater speed means greater kinetic energy. So with the help of formula, that this line is mainly addressing to you that if any body who have a greater mass and greater velocity, that means it have larger kinetic energy. Got it? Okay. Work done by variable force. So if a work done is if a force is variable, if force is variable according to distance, then you can write work done will equals to F dot dx. Okay, and work done you can be write like this: dw will equals to F dot dx. And if you have a curve on which work done is varying according to displacement like this, then area under by displacement and force will give you the work done. Got it? That is the few things which you have to know. So work done when force is variable, force variable means forces vary according to displacement. So you need just to integrate work done with respect to dx, then you can find work done by the force. And same thing which I already told you, work done by the variable force is equal to the area under the fx curve. I already gave you. Okay. Now work energy theorem for the variable work done. So work energy theorem for variable work done is that the net work done, that is dw, from W1 to W2, that is W net, will equals to change in kinetic energy. Got it? And this dw I can be write F dot dx from x1 to x2, that will be equals to change in kinetic energy. Got it? So here is the few things. Whenever you have a variable force, then net work done by the variable force will be equals to F dot dx with integration x1 to x2, that will be equals to change in kinetic energy. So that is the few things whenever we have to find work energy, whenever you have to apply work energy theorem for a variable forces. Got it? This theorem is an integral form of a Newton's second law. That is the same thing. Hence, even of variable force change in kinetic energy equals to work done. Now, the concept of the potential energy. So the main thing is that potential energy for a single particle, for a single point, it's not defined in the complete physics. We can define the change in potential energy. Okay, this kinds of informative line is written in the S.C. Verma book, which is very famous of the physics. They have already written is that potential energy is not defined for any particle. We can define only change in potential energy. Okay, so that kinds of thing you have to understood. So potential energy is the stored energy of a body due to its position or configuration. That is very simple. Okay, for example, a body at height stretch bow compressed spring for a body of mass small m at height h earth surface. For an example, if I have a, you can say, bow, and that is my arrow. So when I put my bow at this rubber band and then I pull this arrow in the backward side, that means my hand apply a force, and with the help of this force my work done is doing to bow arrow push to the backward. So this work done is stored in the form of potential energy, and after pushing this after release this arrow, my arrow will get kinetic energy. So I am totally doing energy conversion. Firstly, I am applying a force so that my work done is stored in the terms of potential energy, and after releasing this arrow, my potential energy directly converts into the kinetic energy. So that kinds of thing we can see that potential energy is the stored energy, so that we can use after some time after releasing. Okay, same kinds of thing we can say that whenever you are standing on the tower, which means your potential energy due to gravity is stored due to tower. But after tower is left, whenever you are dropped from the tower, your motion will be convert, your potential energy will be converted into the kinetic energy, and you comes out to the surface. Okay, so that kinds of thing you can say that that is the conversion of potential energy into the kinetic energy, or you can say potential energy is what? Potential is the stored energy so that you can be used to reach a particular position configuration. Okay, so same thing we can say that Earth's potential energy will be mgh. Potential energy association with conservative force. Conservative force is what? Conservative force is that type of force which does not depend upon the path. It only depends upon the final condition to final position to initial position. Okay, so gravitational force is a conservative force, or you can say electrostatic force is also conservative force. So for the conservative forces, conservative forces and potential energy relations will be Fx. You will be written as minus du by dx. Du is what? Change in potential energy. Okay, so minus change in potential energy you can be written as minus Fx dx, and by integration you can find the change in potential energy. Got it? So that is the few thing which I explaining to you. Now, conservation of mechanical energy. That is the second phenomena of you can say work energy theorem. So work energy theorem is the ideal theorem which can be applied everywhere. But if you have a conservative forces, then we can see by practically that for the conservative forces, mechanical energy of a complete system is totally constant. For an example, at initially, which I give you an example of arrow and bow, initially body is on rest, kinetic energy is 0, and potential energy is 0. After applying, you can say, after applying a force and stored a potential energy, then final potential energy, potential and final kinetic energy will be, that comes equal to, you can say, kinetic energy, which means it directly showing to you that initial mechanical energy, mechanical energy is equal to total sum of potential energy plus kinetic energy of a system. Okay, will be conserved under the conservative force. Okay, so the statement is say if only conservative force act, then the total mechanical energy remains constant. Mechanical energy is equal to kinetic energy plus potential energy. It is the total sum of kinetic energy plus potential energy. K plus V equals to constant. Okay. So the means energy may change from kinetic energy to potential or vice versa, but the total remains unchanged. Again, same thing which I am giving to you. Total mechanical energy of the system will be constant. Got it? Energy can be converted, but can't be created. We can convert one energy to the another energy, but we can't be convert, and we can't be, you can say, decrease this energy. We can be convert to the one form to another form. A falling body loses potential energy and gains kinetic energy. That is again simple example of work energy, mechanical energy conservation. Okay, again types of energy, and then we will discuss about the power. Okay. So potential energy due to spring, again that is the same thing. Whenever is spring having in this natural, then when I apply the compression, when I apply a force, so that spring gets compressed, so that let's say spring get compressed, then spring also applying a restoring force in the backward direction. So on that case, spring applying force in the backward direction and compression is moving in the inward direction. That means fling work done by the spring will be negative. Work done by the spring will be negative. So work done by the spring will be negative. That will be minus kx dx. So work done will be, you will be equal to work done by the spring will be equal to minus half k x square. Okay, and that work done by the spring will be, that is the potential energy of the spring which is stored during the applying the external force. Got it? So work done by the spring, potential energy due to spring can be written as half k x square, and negative value will directly showing to you that compression inside and force acting in the opposite direction of the compression. That is the you can say negative sign value. Overall magnitude will be half k x square. Okay, so these kinds of things we have discussed about the potential energy due to spring. So again, statement says spring potential energy is the energy stored in the spring when it is stretched or compressed. It is the type of elastic potential energy which is the energy stored in the object when it is deformed from its equilibrium position. Again, same thing when you compress the spring again apply the force opposite direction of your external force, then so that it can regain its original configuration. Got it? That same kinds of thing we can study in the spring. Okay. So spring kinetic potential energy we have discussed. U is the potential energy stored in the spring. K is the spring constant. X is the displacement of the spring from equilibrium position. That is the simple thing. The potential energy of the spring is always positive since the spring can only store energy when stretched or compressed. Potential energy due to spring is always positive because F external applying on the spring in the direction of displacement. That's why work done by the F external will be equal to the work done by the spring, which is equal to half k x square. Got it? Now, types of energy. There are few types of energy which you can study while you are studying the physics. Mechanical energy, I already told you. Chemical energy inside the battery so that electricity can be. Chemical energy is what? You have already written, you have already studied about exothermic and endothermic reaction, in which when energy released, that kinds of energy is exothermic reaction. So energy released by the exothermic reaction, that is called the chemical energy. Electrical energy, I already told you, whenever charge is flowing in the particular circuit, then during the charge flow, energy gets by the every parts of the circuit, that is called electrical energy. Third one is magnetic energy. Magnetic energy, that means if any charged particle getting energy due to magnetic force, that will be called magnetic energy. Nuclear energy we have already discussed. Inside the nuclear bomb, higher amount of energy has been released, so that energy is called nuclear energy. Ionization energy, I have already told you, when electron we want to pick this electron from outermost shell, that energy is called ionization energy. Elastic energy we will study in the next PDF. Gravitational energy we have already told you, mgh. Thermal energy, that is also whenever you are increasing the temperature, the internal energy of the particle having some, you can say, oscillatory motion. Due to oscillatory motion, every particle collision increases. Due to all the collision increases, thermal temperature of the body increases. That energy is called thermal energy. Heat energy is that simply to transfer, to increase the temperature, we are putting some external energy, that is called heat energy. Unit of energy is the joule, and name as honor of James Prisman Joule. Okay, that is the scientist name on which, with the help, because of this name, we are using joules. Okay, energy of the, you can say, energy units. Okay, what is power? Power is that is very simple. Work done to perform a particular task to a particular timing, that is called the work done. For example, I am teaching to you, so I am losing my energy till 10 to 5. So this timing calculation to a particular timing is called my power. If I can teach particular student with 10 hours and another faculty which are teaching students for 12 hours, that means that faculty can reduce their energy till up to more, you can say, more timing. So that faculty is the more powerful. So main thing is that power is what? Power is, you can say, work done by the particle at a particular time. You can say rate of work done is called the power. Okay. So the power is a physical concept with several different meaning depending on the context and available information. We can define power as the rate of doing work done to amount of energy consumed per unit of the time. So power is also depend person to person. I am releasing my power by teaching. You are gaining your power by consuming some content. So I am releasing my power for a certain time interval. So energy released for a particular time, that is my power. And consuming energy by at per unit time, that is your power for your brain. So power you can calculate as a rate of work done at a particular time. Okay, so power you will get P equals to W upon T, which show rate of work done. So dP you can be write as a differential for dW by dt. Got it? So power could be electrical form, power could be mechanical form, power could be kinetic form, that kinds of everything. So every energy which you are releasing at a certain particular time, which means you are releasing your power. Got it? So that is your power formula. So unit of the power will be according to popular standard. The SI unit of the formula, none of SI unit of the power is the, you can say, work done per your unit of motion is joule, and time unit is second. So unit of the power will be joule per second. Got it? That is the first unit. And the famous unit of the power, it is watt, which is represented by symbol W. Okay, 1 joule per second is also equal to the 1 watt. So 1 joule per second, that will equals to 1 watt. Interestingly, the name was kept in the recognition of James Watt, who invented the consider for the steam engine. The inventor of the steam engines was James Watt. So for the respect, that type of person, we consider the unit of the power will be watt. Got it? So 1 watt equals to 1 joule. 1 joule equals to 1 kg meter square per second cube. Got it? And 1 joule, another thing which I am giving to you, 1 joule equals to, okay, 1 calorie, sorry, 1 calorie of energy will equals to 4.2 joule. That relation is also very useful for your chemistry as well as some physics problem also. Okay, that is the calorie, not kilocalorie. 1 calorie will equals to 4.2 joule. Got it? This is also coined the terms, however, which is the older unit of power it can be dissipated as. Okay, let's talk about the collision. Collision is what? When two bodies combines to each other, or you can say when two body directly strikes to each other, that phenomena is called collision. You can see as accident, you can see as some kinds of, you can say, whenever you are playing rolling ball, whenever you are playing, like you can say cricket. Okay, so cricket ball hits the, you can say, cricket bat. That means ball collide with the bat. So that phenomena is called the collision. So collision is what? Collision is an interaction in which two bodies strike each other at a shorter time and exchange momentum and energy. That is very simple. Let's say two bodies having velocity u1 and u2, and everyone knows about that. After collision, their velocity can be changed, which means they are changing their momentum. So main thing regarding to collision is that when two bodies are interacting with due to some reason, and after interaction of the short period of time and after changing their momentum, that phenomena is called collision. The main idea, total linear momentum is always conserved in the collision. Yes, absolutely. Because two bodies are interacting to each other without any external forces. So without using of external forces, these two bodies will perform collision and momentum will be conserved. Now, types of collision. So based upon energy loss, types of collision have 3 types. First one, elastic collision. Second one, inelastic collision. Third one is completely inelastic collision. So firstly, we have to discuss about one-dimensional collision. Inelastic collision is what? Both momentum and kinetic energy are conserved. Inelastic collision, momentum is conserved, but kinetic energy is not conserved. And completely inelastic, both bodies stick together after collision. That is very simple. In elastic collision, kinetic energy will be conserved and momentum is also conserved. So Ke initial will equal to Ke final for elastic collision. Okay. And for inelastic collision, momentum is conserved, but you can say kinetic energy is not conserved, because on that case we are using coefficient of restitution, that whose value is velocity of separation. Sorry, E will equal to velocity of approach upon velocity of separation. Sorry, formula is you can say reciprocal. Velocity of separation upon velocity of approach. So with the help of this phenomena, E have some certain value. So with the help of this E value, final velocity may be changed. So if final velocity is changed, then we can say that energy will not be conserved for the inelastic collision. And for completely inelastic collision, in that case, when two bodies are combined to each other and combines, and after they are moving with certain velocity, this collision is called inelastic collision. Now, one-dimensional collision, if all velocities are along the same straight line. For completely inelastic collision, m1 v1, okay, initial momentum will equal to final momentum. For inelastic collision, initial momentum will equal to final momentum. Initial momentum will equal to m1 u1, m2 u2, and final momentum after combining of them both mass will be added, m1 plus m2, and both have will combine velocity, that is v. So you can write this formula for the perfectly inelastic collision. Okay, and for elastic collision, one dimensional, m1 v1 initial will equals to m2. Okay, m1 v1 equals to m1 v1 plus m2 u2. Okay. For a single body, I think I should explain it with separately. For an example, let's two body having, you can say, velocity, that is u1, that is u2, that is mass m1, that is m2. For example, for initial movement of both, p initial for first body m1 u1, and initial movement by second body, that is minus m2 u2. And let's say after collision, both body comes to the opposite direction. Okay, like v1 and v2, and that is velocity of mass m1, and that is m2. So after, you can say, collision, their momentum will be different direction. So final momentum will be m2 v2 minus m1 v1. So that is your momentum equation. P initial will equal to P final, that you can apply for any types of collision. Okay, so for elastic collision, you can apply like this. Got it? So that kinds of thing I have written m2v. So it is it can also add m1 u1 also. Okay, that will be m1 u1 equals to m2 u2. Okay, and the kinetic energy will be conserved, half m v1 square, half m u1 square, half m2 u2 square, that will be equal to half m v1 square, half m v2 square. For elastic collision, kinetic energy will be conserved, that means final equals to initial. Okay, so for elastic collision, kinetic energy will be conserved, momentum conservation we can apply. For inelastic collision, kinetic energy will not conserve, but momentum equation we can be apply. For total inelastic collision, momentum equation can be applied, but you can say kinetic energy will not be conserved. Let's talk about the again collision. Collision is an interaction in which two bodies strike each other or short period of time and exchange momentum and energy. I already told you. Meanwhile, the total linear momentum is already conserved, and kinetic energy may or may not be conserved. I already told you regarding to this. Elastic collision, I already explained to you. Elastic collision, both momentum and kinetic energy are conserved. Elastic collision, momentum and is conserved, but kinetic energy is not conserved. And third thing, completely inelastic collision, bodies stick together, but after collision. Okay, let's talk about the collision. One-dimensional collision, I already told you, when direction of the, you can say, direction of the velocity during the one-dimensional collision, if are having the straight line, that is called collision in the one-dimensional. Example, like this two particles having velocity v1 and v2. If these two velocities direction having the same straight line, that is called collision in the one-dimensional. Okay. And two-dimensional collision, momentum is conserved separately in xy direction. So we solve velocity into components and apply conservation equation along the both axes. That is called like this. One body having this momentum, one body having this momentum. So it could be possible that at this point they can be collide. So momentum can be conserved in the along direction. So you can be applied px equals to px initial equals to px final, momentum conserved along the x-axis, and py initial equals to py final, momentum conserved according to y direction. So you can apply two-dimensional collision with the help of this formula. Okay, so let's talk about the, you can say, some questions regarding to this. A force of 20 Newton acts on the body at an angle 60 degree to the direction of displacement. If the displacement is 10 meter, then find the work done. Same question. Angle between displacement is 60 degree. Angle between displacement and force is 60 degree. Force acting is 20 Newton, and displacement having d equals to 10 meter. So work done, you will be get F dot D multiplied by cos 60. So work done, you will get 20 multiplied by 10 multiplied by cos 60 is 1 by 2. And work done, you will get 100 joule. This is your answer. So first option is correct. Got it? Okay. Let's go about first question again is saying, okay, second question. A body of mass 2 kg moving with velocity 10 meter per second Find its kinetic energy. Again, it is simple. Kinetic energy, you will write half m v square. That means half mass of the body 2 kg and velocity is 10 multiplied by 10. Half m v square. 2 to 2 will be cancelled out. 100 joule energy. Okay. That is our kinetic energy. Got it? Okay. Third question. A body falls freely from height of 20 meter. Find its velocity just before hitting the ground. Find its velocity just before hitting the ground. That means free fall. So you will be right. You can also solve this question with the, you can say, kinematic equation, but I can solve this question with the help of work energy theorem. So ball having velocity, initial velocity is 0. After hitting the ground, velocity becomes v. Okay. So height is already given as how much height? 20 meter. Okay. So work done by the gravity to reaching this ground. Work done by the gravity. Only one force is acting on the ball, which is work done by the gravity. So work done by the gravity will be mg multiplied by 20. That will be equal to change in kinetic energy, because I am using work energy theorem. So v final I half m v square I have to find. Initial velocity is 0, which means initial kinetic energy is 0. M to M will be cancelled out. So you will get 2 times of G multiplied by 20, that will be equal to V square, and G should be written as a 10. So 10 multiplied by 10, 100, 100 multiplied by 4, 400. So 400 will equal to V square, and square root value of 400 will be 20 meter per second. Any doubt? That was the third question. And the fourth one question, a ball of mass 1 kg moving with velocity 10 meter per second collide head-on collision elastically with another ball of mass which are on rest. Find the velocity of the second ball. Again, that is a simple question. You have to apply momentum equation for this question. So second body is rest. That means initial velocity is 0. Okay. A ball is mass 1 kg. Ball mass 1 kg moving with velocity 10 meter per second. Okay, elastically head-on collision with another ball with the same mass. Okay, find the final velocity. Let's say after collision, final velocity becomes in the negative x direction, and second ball having velocity v2 in the forward direction. So let's solve this question. So firstly, initial momentum you have to write. So initial momentum for this ball, that will be 0. Final initial momentum for this, that will be 10. Final momentum for second ball will be 1 times of v2, and for first ball will be minus v1. So another ball of a ball of mass 10 kg collides head-on collision with another ball of mass same at rest. Find the velocity of second ball after collision. Okay, what about first ball? Okay. We can also apply the you can say kinetic energy equation. So initial kinetic energy you can apply half m1 u1 square plus half m2 u2 square. You can also apply elastic collision. Kinetic energy will be conserved. So half m1 v1 square plus half m2 v2 square. Got it? So that value will be 0 because initially ball is in rest. M1 value is 1. 10 square, which means 100. 100 divided by 2, yani 50. That will equal to mass is 1. So v1 square by 2 plus v2 square by 2. So again, we will get v1 square plus v2 square will equal to 100. Okay, let's solve this equation. So v2 minus v1, you have 10. And how can I solve this equation? Can I write like this? V2 square minus v1 square will equal to v2 minus v1 and v1 plus v2. Can I write like this? So v2 minus v1 can be written as 10, or v1 plus v2. I can be write, how can I write? I think we should solve this equation. Let's solve this separately. 10 will equal to, again, what is question is saying? 10 will equal to v2 minus v1. Okay. 10 will equal to v2 minus v1. And again, we are applying v1 square. What is the same thing after collision? Is it understandable? A ball of mass 1 kg moving with velocity. Okay, I think we should solve this question with the, you can say, option also to losing calculation. Okay, it could be solved in the exam point of view. We can be solved with the option also. So V2 minus V1 is 10 and V1 square plus V2 square is 100. So we need to choose that option which is which can be helpful to satisfy this equation. So find the velocity of second ball. Find the velocity of second ball. If second ball velocity is 0, then V2 becomes 10. V2 becomes 10. Okay. And if again that is equation will be proof. And second ball, if V2 is 25. Okay. V2 is 5, then V1 equals to 5. Okay, and if it is become 10, then overall this value becomes 20, and 20, that option will be wrong. And I think first option will be right, because this first option will satisfy the equation of this two. V2 minus V1 equals to 10, V1 square plus V2 square equals to 20. Okay, let's solve the next question. I think PDF has ended. So your first few chapter has completed. Sir, can you please send this 11th physics PDF now? You want now? Okay, I will ask to the operational team. Then I can send you. Okay. I think we have completed half portion of 11th syllabus. Okay. I think nobody has any doubt. Let's continue with our second PDF. Okay. Which is the part B of our syllabus completion. This is look like second. So in the second PDF, what we have covered. So firstly, our first topic is mechanical properties of solid and fluid. Okay, we will discuss about it. So firstly, stress and strain, elastic behavior of solid and elastic material. That kinds of thing we have discussed. So firstly, what is stress and what is strain? So in before discussing about this, let's discuss about elastic behavior of solid. So elastic behavior of solid mainly refers to you that it is the tendency of any solid to regain its original configuration up to the elastic limit. Whenever we are applying external force on a particular solid, then solid have a tendency to regain its original configuration up to elastic limits. This type of phenomena is called elastic behavior of a solid. Got it? And whenever you are applying a force on the particular object on a particular area, this force is called stress. And after configuration changing, if and when after applying the force, particle or object changing its you can say configuration, this configuration change is called strain. Got it? So these three things we have discussed. So firstly, again the definition, material that have, wait a minute. Oh, wait a minute. I again open the PDF. I think PDF has closed. Okay, wait. Okay, we have to one more PDF. Okay, we have to discuss about it. COVID, no problem. Okay. So we have to discuss this. Okay, okay. Again, it have opened. So my screen is visible to everyone. Okay. Okay. So now elastic material that have tendency. Oh, okay, wait. Okay. I have to change the color. It should be blue, green. Okay. Elastic material that have a tendency to return back to their original configuration upon their removal of deforming force. Example, rubber band. This property is called elastic. For an example, in a rubber band phenomena, you can see that whenever you are applying a force, so that rubber band gets stretched, and after removing this force, rubber band gain its original configuration. So this tendency to getting the original configuration of any material after applying a after applying a F external, this material property, this tendency is called elastic material, or this property is called elasticity. Got it? I think I should increase the thickness also. Okay, that is the good. So that is the elastic materials. Now, what is plastic material? That material who does not have elastic property, that material are called plastic material. So definition, according to definition, material that do not have tendency to return back their original configuration upon the removal of deforming forces, this material gets permanently deformed. Example, clay. Okay, so clay is the example, is the, you can say, plastic material on which whenever you are applying a force on the clay, this you can say shape of the clay is changed, but it will not regain to this original configuration. This property is called plasticity. Okay, stress, strain, and Hooke's law. So stress is mainly defined as whenever you are applying a force, so that material changing its configuration, that force is called stress. The restoring force per unit area is known as a stress. Magnitude of stress is sigma equals to F upon A. F is force, A means area. Okay, and the SI unit, Newton per square, dimension M1, L minus 1, T minus 2. Got it? Now, stress have three types. One is longitudinal stress, second shearing stress, third one is hydraulic stress. So what is longitudinal stress? Longitudinal stress is a type of stress in which when the force is applied along the length of the body or normal to its cross-sectional area. It could be tensile stress, it could be compressive stress. Whenever we are applying a force so that material increases its length, then this stress is called tensile strength. And whenever material decreases its strength after applying the restoring force, then this stress is called compressive stress. Okay. Let's talk about the shearing stress. When the force are applied parallel to the cross-sectional area of the body, it is known as tangential stress. It's look like a jelly. Have you understood about the jelly? Jelly first have a position like this. When you are applying a force on the surface of the jelly, then you can see that the deformation is looks like some shifting have been happen, but configuration does not change. Main thing, it's shifted to the towards right and again regain to its position. So that stress, whenever you are applying a force on a particular body, and that area, or you can say that body configuration shifted to certain angle, that stress or strain is called shear stress. Okay, and that is hydraulic stress. Hydraulic stress is what? It is also called volumetric stress. That means whenever we are immerse a body in a particular liquid and liquid applied a force in the every direction of the solid surface. So due to every direction of force, this solid surface volume decreased. Okay, let's say original volume is V, then decreased volume will be V minus dV. Okay, so this is the volumetric stress, or you can say hydraulic stress. If a body subjected to a uniform pressure for all sides, then the stress is referred to the hydraulic stress. Okay, let's talk about the strain. Strain, it is a ratio of change in dimension of the original configuration. Original dimension of the original to the dimension is called strain. That is very simple. Strain mainly defined as change in configuration upon original configuration. That is called strain. Got it? That is the simple formula. So with the help of this formula, we can say that strain have three types. If I am changing the length according to my applying stress, let's say length changing to L to delta L, and the original length is L, then strain is called according to their length will be delta L by L, that is called longitudinal strain. Similarly, longitude shearing strain, that is also equal. You can say whenever you are applying a, that is, you can say jelly, and you are applying a force, and after applying the force, jelly shifted like this, and this shift is, you can call as x naught, and this height you can say that is called L. So shearing strain can be applied as a theta. How much it's shifted? So tan theta you will be written as perpendicular upon base, that will be x naught upon L. So this is tan theta is called shearing strain. Got it? And third one is volumetric or bulk strain. Volumetric strain, that is also called as a beta, that will be equals to delta V by V. It is called volumetric strain. Volumetric strain. Got it? So it is a deformation. It is the deformation of the any object whenever you are applying a stress. So this strain deformation upon original deformation ratio is called strain. Got it? Now let's talk about the longitudinal strain. So that is again simple. Whenever you are applying a restoring force to a particular body, then if this body changes its length, then according to this changing the length, the changing length upon the original length ratio, that is called longitudinal strain. Longitudinal strain is a ratio of the change in length to the original strength. That's simple. And it is also written as delta L by L. Similarly, shearing strain, I already told you. Shearing strain written as a theta. That is the angle of theta. Let's say this length is L and shifting is x naught. So shearing strain will be tan theta, can be written as x naught upon L. That is your shearing strain. Got it? And let's talk about a volume or bulk strain. That is again, I have already explained you. Bulk strain is the ratio of the change in volume to the original volume. So bulk strain you can assume as a beta, that will be delta V by V. This is your bulk strain. Now let's talk about the Hooke's law. Hooke's law, what is the statement? So for small deformation, the stress and strain are the proportional to each other. This is known Hooke's law. Mainly it's directly showcasing to you for a small deformation, whenever you are applying small force on the particular object, then when you are increase your stress, then strain will also proportional to, you can say, your applying force. Okay, so you can mainly Hooke's law is saying stress is directly proportional to strain of what? Up to elastic limit. Up to elastic limit. So up to elastic limit, stress is directly proportional to strain. That is the key statement of Hooke's law, where K is the proportionality constant and is known as modulus of elasticity. In case of longitudinal stress, Young's modulus we are using. What is Young's modulus? So according to, you can say, whenever you are dealing with, you can say, longitudinal strain, for example, this is a wire and it is fixed. Okay. And whenever you are applying F external, so you can say that this wire will have tendency to regain its original configuration. So this applying restoring force. Okay. So due to restoring force, it is a restoring force that which any object can regain its original configuration. So in this case, F external is directly equal to F restoring. So most of the cases I will write F restoring instead of F external. Okay. So F external upon area, that is stress, will directly proportional to longitudinal strain, that is delta L by L. And after removing this proportionality constant, I will write F external upon A will equal to Y delta L by L. That is your relation of stress, strain, and along with Young modulus of elasticity. Second thing which you have to understood, Y is the elasticity constant. Elasticity constant, which mainly depends which mainly depends upon material only, which mainly depends upon material. For an example, if I give you a question like this, two wires who have who have who have length L, and area of cross sectional is, you can say, A and 2A, and if F force is applying longitudinally, then ratio of their Young modulus y1 by y2 will equals to. So in this scenario, wire are same, but length are also same, but area of cross sectional A and 2A, and F force is applied whenever you are applying as a longitudinally to changing its length, then ratio of y1 or y2 will always equal to 1, because wires which means Young's modulus of elasticity does not depend upon the force, does not depend upon the area, only depends upon the material. If same material are acting during the longitudinal strain, then we can say that Young's modulus of both ratio will be equal. Overall meaning is same. Young's modulus of elasticity will be constant whenever material is same. Let's talk about the stress and strain curve. Okay. The stress and strain curves vary from material to material. Obviously, this curve helps us to understand how a given material deform with increasing loads. So this stress and strain curve mainly give you the information there how material will behave whenever you are increasing the stress value up to certain elastic limits, and sometimes whenever you are cross the elastic limit. And this stress strain curve is totally different for different material. For iron, it is different. For silver, it will be also different. For, you can say, copper, it will also different. So for different material, elastic behavior will be different, and stress strain curve will be also different. Got it? Let's talk about the region. Let's talk about the particular regions. That is the explanation about the, you can say, stress strain curve. So O to A, how O to A defines something. O to A, the curve is linear. Hooke's law is obeyed. The body regains its original dimension when the applied force is removed. In this region, the solid behaves as an elastic body. Slope of the line OA. So mainly O to A mainly explain to you that every object on which O to A region will define to you that it will follow Hooke's law. It will follow Hooke's law. And Hooke's law, what is saying? Hooke's law mainly saying that force is directly, or you can not force, stress is directly proportional to strain. So if you apply a stress more, strain will be more. And if you reduce the stress, then body will come back to the original configuration. So that kinds of thing, O to A, mainly refers to you that Hooke's law. Okay. So O to A, material will be behave like a originally perfectly, you can say, elastic body. So it will behave like elastic body. It will regain to its original configuration. And slope of line OA will define to you like Hooke's law is obey, because it is having straight line. Okay. So O to A mainly defined to you that material will behave elastic behavior. In the region from A to B, for A to B, stress and strain are not proportional, which means stress and strain are not proportional. Whenever you are increase the stress, strain could be maximum or minimum, not are proportional. Nevertheless, the body still return to its original dimension, but when applied force is removed, stress or strain will not be proportional to each other, but body will again regain to this original configuration. That means elastic property will not use from A to B. Got it? The point B in the curve is known as yield point, also known as elastic limit. That point B is the elastic limit. Okay. up to this elastic limit point B, material will not get to the, you can say, original configuration. Got it? Okay, I think someone asking some question. PDF will be provided. Okay, okay. Okay, okay. I think you are asking with the operational team. Okay, no problem. Okay, the point B in the curve is known as the yield point, also known as the elastic limit, and the corresponding stress is known as yield strength of the material. That's the very simple. A stress on which you are applying for the elastic limit, up to elastic limit. So that stress maximum value on which material will regain to its original configuration, that stress is called yield strength. Okay, that is very simple. The point B. Let's talk about the B2D. Let's talk about the B2D. When the load is removed, the body does not regain its original dimension. In this case, when the material is said to have permanent set, the deformation is said to be plastic deformation. The point D on the graph is the ultimate tensile strength of the material, which means from B to D, material will not follow Hooke's law. Material will not regain its original configuration, which means material will lose their elastic tendency, and overall I would say material will lose their elastic property and comes to the plastic behavior. Got it? So that is the B to D portion. And if I talk about D to E, beyond point D, additional strain is produced even by the reduced applied force, and fracture occurs at point E. Okay. And if the ultimate strength and the fracture point D and E are close, the material is said to be brittle. If they are far apart, the material is said to be ductile. That means D to E portion mainly saying to you that whenever you are applying more force on the, you can say, particular material, then maybe you can say sometime material can be break, and that point to D can be showing to you that material comes to the your fracture point. Okay, and if any material by applying force from D to E has fractured due to some fracture point limit, then that material are called brittle. And if the material is not, you can say, fractured, and it is by increasing their length after applying the force, then that material is called ductile material. Got it? Let's talk about the elastomers. What is elastomers? Elastomers substance which can be stretched to cause large strains are called elastomers. Example, tissue of aorta and rubber. Same thing. Whenever any object, whenever you are applying a smaller amount of force and their strains are very high, then that material are called elastomers, like rubber band and like aorta. Got it? Okay, stress strain curve for elastomers. So elastic region is very large, but material does not obey Hooke's law over most of the region. Hooke's law mainly referring to you that stress is directly proportional to strain. Okay, proportionality is main thing. It doesn't mean that whenever you are applying a force and strain is occur, it does not mean that Hooke's law is follow. Hooke's law mainly follow when you are applying 4 Newton, then 4 unit change of strain you are feeling. That is the proportionality. But if I talk about the elastomers, their elastic limit so many, their elastic limit so large. That means they can be show elastic behavior up to more force limit. Okay, so that is the you can say property of elastomers, because they have large value of elastic limit. Second, there is no well-defined plastic region. Okay, we can also say elastomers does not have well-defined plastic region. Why? Because whenever you are applying a force more, they can again stretch plastic region forward of point on which they can be break. So elastomers sometimes does not have well-defined plastic region. Got it? So overall summary of this point is that elastic material have tendency to return back to their original configuration upon the removal of deforming force. Second point, plastic material do not have tendency to return back to their original configuration upon the removal of a deforming forces. And third point, which is the restoring force per unit area is known as the stress. Okay. and magnitude of the stress. Okay, the ratio of change of dimension to the original dimension is called strain. That is the main thing which I already explained you. For example, deformation, the stress and strain are proportional to each other. That is known as the Hooke's law. I already explained you. Hooke's law is valid only in linear part of the stress strain curve. That is also told you from A to B. Hooke's law will be followed. Got it? Now let's look about elastic moduli. Young's modulus. Okay. Young's modulus I already explained you. Okay, the ratio of stress strain is called modulus of elasticity. Again, I told you, according to Hooke's law, stress is directly proportional to strain. So if I write stress upon strain ratio, then it will give you the constant value. And this constant value will give you the E. E is what? Modulus of elasticity. Depending upon on which strain you are doing. If you have longitudinal strain, then that E modulus of elasticity convert into the Young's modulus of elasticity. And again we are saying tan theta, which I already told you, x naught upon L, that is also shear strain. Okay, and the ratio of shear strain upon shear stress F by A upon x naught by L, that is called again shear modulus. That is also represented as like this. And bulk modulus, it is also explained by the, you can say, whenever object emerges in the liquid and the delta P, that is P1 and that is P2. Delta P will already explain you delta V by V. So ratio of delta P upon delta V by V will give you the bulk modulus beta. Got it? So that is the modulus of elasticity, which I already explained you. So Young modulus, I already explained you, like this example in previous. So SI unit is also Pascal. Aluminium, iron, wood, glass, polystyrene, and copper. These are also few examples of Young's modulus of elasticity, or you can say longitudinal stress and strain. Glass is also example of shear stress. Okay, let's solve some practice problem regarding to this, and then we can move with the next topic. A wire of length L, cross-sectional area is A, is stretched by the force F, producing an extension delta L. Okay, if the length of the wire is doubled and the same force is applied, the new extension will be. Okay, so question very simple. Y will be defined as FL by A delta L. Is it right? F by A will equal to Y times of delta L by L. Okay, now the question is changed. If the length of the wire is doubled and force is applied is same, then new extension will be. So you need to find delta L dash. So Y again constant, force is applied is same. If the length of wire is double, that will be 2L divided by area of cross section is also A, and delta L comes to the L dash. Okay, so what will be the value of L dash? So write again same value FL by A delta L, because Y is the constant. So cancel out these values. FL, that will be cancelled. A will be cancelled. So delta L dash, that will be equal to 2 times of delta L, which means whenever you are applying a force F with the L length rod, then configuration you will be get delta L. But if you increase the length L to 2L, then configuration will be double 2 times of delta L from the initial. So answer you will get B. So B is the correct answer. Got it? Let's move to the next topic, determination of Young modulus of the material. That is also very simple, which is saying fixed rigid support, experimental wire, vernier scale, meter scale, okay, reference wire. Okay, the difference between two vernier reading gives the elongation produced the wire, and L let be the mass of the that produced and the elongation on the wire applied force. That is very simple. It's already showing to you that how can you find, you can say, determination of the Young's modulus. Let's say this is wire and this is length, natural length L naught. You are applying a device which is vernier calipers, which can be measured to your elongation. So initially it shows L naught L naught you can say length. And if I apply a block whose mass small m, then stress will be applied due to gravitational force, that is mg. So if wire cross sectional area is a, then stress will be applied on the wire will be mg by a, and this stress will directly proportional to delta L. So mg by a will directly proportional to delta L by L. So L I have already mentioned, L I have already measured by vernier caliper, that is L naught. And delta L I can measure, length could be increased as L plus delta L. So change in length will be L plus delta L, L naught plus delta L minus L naught. So you will get change in length will be delta L, which I have already written. So Young's modulus of elasticity you will be get mg by A, that will be equals to y, which is Young's modulus elasticity, which is delta L by L naught. So y you will be get mg L naught by A upon delta L, and this every kinds of thing you can be measured by practically. Mass of the object you have already understood. Gravitational acceleration you know 9.8. L naught is the initial length which you have already measured by the vernier caliper. Area of cross section you have already know, and delta you have already find with the help of vernier calculus. L plus delta L minus L naught. So delta L you will get with the subtraction of both elongation minus original length. Got it? So with the help of these values, you can be find easily Young's modulus of elasticity of any material. Now the question is asking why we are using two wires in the experiment. We are using two wires. Yes. So first wire mainly use, you can say both wire we can be used whenever you are changing the load. Whenever you are changing the load, stress, and you can say we can be considered like that. If first wire cross the elastic limit, then Young's modulus of then Hooke's law will not be followed. So on that case, we can't be apply this rule also. But if we have a two wire on which on the basis of first wire we can check it like that. According to first wire experiment, according to certain load, it follows Hooke's law, then it will be good. Then we can use our formula for the second wire. If it does not follow the Hooke's law, that means we have to change our mass in the second wire. So that kinds of understanding we can be applied with the help of two wires. Okay. Now the third thing which I given to you, the reference wire is used to compensate for any change in the length that may occur due to change in room temperature. Since any change in the length of the reference wire due to temperature change will be accomplished by an equal change in experimental. Also, this reference wire will also helpful to measure your accurate value, because you know what, whenever you are understand about thermal expansion, the thermal expansion mainly showing to you that due to increasing of temperature of surrounding, any wire or you can say any material changes its configuration. It could be length it could be increase their length, it could be increase their volume, it could be increase their area. So that kinds of thing will be happen when temperature is changed. So reference wire mainly helpful to recognize this kinds of thing. If reference wire increase their length, that means this loaded wire also increase their length according to temperature. So reference wire mainly refers to identify delta L calculation. Got it? Here are some questions, and after that we can study about the shear modulus and bulk modulus. Okay, and what will be the next topic? Again, we will discuss about it. Next topic will be Poisson ratio. Okay. Okay, next topic will be oscillation. Okay. Okay, let's talk about it. Where we have ended? Okay. Two wires having same material and same length having radii r and 2r, if same forces applied, the ratio of their extension. Again, same question. Force, which is F, area will be pi r square, and second one, area will be 4 pi r square because radius is 2r, will equals to y delta L by ratio of their extension. So delta L by L will equals to y delta L by L. So ratio of their extension L1 or L2. So delta L1 by L2, you will be get 4 pi r square comes to the numerator. So that will comes to the 4:1. This is your answer. Got it? So 4:1 is your answer. Let's talk about shear modulus and bulk modulus. I already told you shear modulus mainly written as uh, s- shear modulus can be written as you can say whenever we are applying a Hooke's law in the you can say as a shearing condition, then you can say shear modulus, which is shear stress, is directly proportional to shear strain, shear strain, which I already derived you as a theta. Okay. So if I remove this proportionality constant, that will be equal to shear stress will equal to G times of strain. Okay. वो भी shear strain. Okay. So that is the simple formula. So according to this, shear stress as defined as a tau, like this, and shear strain is defined as a gamma, and G is the modulus of shear modulus of rigidity. Okay. So you can be right. G will equal to tau by that is stress of shear stress, and strain will be you can assume like a gamma. Okay. That is the simple unit. Unit is Pascal, which is equivalent to the Newton per meter square. Okay. Here are some material on which their modulus of elasticity is given. Shear modulus is also given. That is the data. Okay. Which you can be know that. Okay. Young's modulus and shear modulus are measured in the Pascal or Newton per meter. It can be seen that shear modulus or modulus elasticity is generally less than the Young's modulus of elasticity. So this table mainly refers to you that shear's modulus of elasticity generally lesser value than Young's modulus of elasticity. Got it? Here is the here is the one more question. A block is subjected to a shear force over area A producing to a displacement x on the top surface, while bottom surface remains fixed. If the height of the block is doubled, then the shear strain, again, that is the value, again, tan theta related problem. So, tan theta you will get displacement of the surface, that is x, upon height of the material, that is L. Okay, and that is the shear strain. That is the shear strain. So you can be write shear strain as a x upon L naught. Okay. Now, bottom is if the height of the block is double, then shear strain will be initially shear strain will be L x upon L naught. If height is double, then that will be right x upon 2 L naught, which means shear strain becomes half from the initial. So option C will be correct. Now let's talk about the bulk modulus. The ratio of hydraulic stress to the corresponding hydraulic strain is called bulk modulus. It is denoted by symbol K equals to minus P upon delta V by V. Okay, it is very simple. Force, pressure which are acting on the surface of this sphere will be F by A, which is directly proportional to volumetric strain, that will be delta V by V, and the ratio of volumetric stress upon volumetric strain, that will be give you the bulk modulus of elasticity. So you will be get F by A is known as a pressure, that will be proportional to delta V by V. After removing this proportionality constant, you will be assumed as a K. So K will be, you will write P divided by delta V by V. Now I am writing as a negative sign. Why I am writing negative sign? That means volume has decreased. So final volume has lesser than initial value. That means delta V will be negative. So I have written minus times of K minus times of P delta V by V. That is the bulk modulus of elasticity. So these kinds of things I have already explained. Got it? So K is the bulk modulus of elasticity, P is the change in pressure, delta V is the change in the volume, and V is the original volume, which I have already give you. SI unit of this stress will be the negative sign, indicates the fact that that within increase in the pressure or decrease in the volume occurs. Okay, same thing which I already explained you. Due to pressure, volume is decreased. That's why negative sign has come. This the value of bulk modulus always positive. These values of bulk modulus will always positive. Okay. Let's talk about the next new thing. The reciprocal of the bulk modulus is called compressibility. So compressibility mainly known as the beta equals to 1 upon K, and K is also known as the delta P upon delta V by V. So reciprocal of this So beta you will be get, let's v comes to the numerator. So k beta, sorry, k will be written as p delta pv upon delta v, and reciprocal of both delta v upon delta p multiplied by v. That is your compressibility. Got it? And the unit of this compressibility is Pascal inverse or meter square upon Newton. That is the compressibility. Okay, compressibility. Compressibility. Got it? So that is the main important thing. It is also defined as a fraction change in the volume per unit increase in the pressure. Same thing I already told you. Delta V upon delta Py, delta V upon delta P multiplied by V. So according to the fractional change in the volume per unit increase pressure. Okay. According to definition, it is also same. Gases are about 1,000,000 times more compressible than solid. That is actually true. Why true? Because every solid particle having very less distance between each other. So to compression of solid, it's very tough. But if I talk about gaseous state particle having loose intermolecular interaction, they have loose value of intermolecular interaction force. They have larger distance between each other. So compression in the gases molecules is very easily because we have very enough of empty space. Got it? Let's talk about a liquid of volume 1 meter cube subjected to a pressure 2 into 10 to the power 10 Pascal. Bulk modulus is 2 into 10 to the power 6. Find the decreasing in the volume. That is very simple. So beta can be written as delta P upon delta V by V. So beta already given 2 into 10 to the power 9. Delta P is already given 2 into 10 to the power 6. Delta V I have to find, which is already showcasing to you decrease in the volume. So I will be write positive value. And volume is already given, that is 1 meter cube. So it will become into numerator and it will be 1 meter cube. So you can be write 2 to 2 will be cancelled and 10 to the power 6 cancelled by 10 to the power 3. So delta V you will get 10 to the power minus 3 meter cube. And this is your delta V. And final answer is first. So 1 into 10 to the power minus 3, that is your decrease in volume. Everyone understood what I'm solving? Everyone understood what I'm saying to you? If anyone who have any doubt, he and she can ask me. If anyone who have any doubt, he and she can ask to me. Anyone? Is it understand? Oh, once again, sir. Okay. Okay, if you have any problem, just type on the chat board so that I can recognize. Okay. Okay. Again, few things which I told to you. We have a question in which liquid have a volume 1 meter cube is subjected to a pressure 2 into 10 to the power 6. Bulk modulus is already given. Bulk modulus we can write as a delta P upon delta V by V. Is it right? So beta I can also written delta P multiplied by V divided by delta V because this comes to the numerator. So beta I have already given, that is 2 into 10 to the power 9. And delta P already given 2 into 10 to the power 6. And initial value I have already given, that is 1. And I have to find the decreasing volume, which means I have to find delta V. So delta V will be written like this. So 2 to 2 will be cancelled out. 10 to the power 6 will be cancelled out to 10 to the power 3. So delta V you will be get 1 into 10 to the power 3, 10 to the power minus 3 meter cube, which is showing option first. Any doubt? Any doubt? Konda Jashwant, any doubt? Kindly reply on the chat. I think you don't have any doubt, okay? Okay, let's come to the next topic, Poisson ratio and elastic potential energy in the stretched wire. So Poisson ratio is what? Poisson is not about the poison which are finding in the medical. It's not a poison, okay? It's not a Poisson ratio. It's a Poisson ratio of in the elasticity. The strain perpendicular to the applied force is called lateral strain. The strain perpendicular to the applied force is called lateral strain. The ratio of the lateral strain to the longitudinal strain in the stretched wire is called Poisson ratio. Okay. The original diameter of the wire contracted to the diameter under stress. The lateral strain upon longitudinal strain. So, okay. This mainly referred to you that what if I tell you, you have a particular wire and who have a cross-sectional area A, and if you are applying a force, on the wire so that its length is changing, and also if volume is constant, that means its area will be decreased. So area will also decreasing, length is also increasing. That means two types of strain I can see. First, area is changing. Second one, length is changing. Then the ratio of their. Okay. What is lateral strain? Lateral strain is the strain perpendicular to the applied force is called lateral strain. Such type of strain which is perpendicular to the applied force. Now area is changing like this and force is applying in the downward. So area is changing perpendicular to the applied force. That means that strain, that's area changing strain, it's called lateral strain. The ratio of lateral strain to the longitudinal strain is called stretch wire called Poisson ratio, which means delta A by A upon the lateral strain is the ratio of lateral strain to the lateral strain delta L by L. That is the Poisson ratio. Okay. So delta A by A upon delta L by L, it is called Poisson ratio. Let's look at the example. Now area is decreasing. That's why I am writing negative form. Okay. So that is the Poisson ratio. This is directly refers to you lateral strain upon longitudinal strain. That is what? That is Poisson ratio. Okay. If area is decreasing, that's why I'm writing negative. So that is Poisson ratio. Okay. It is also written as like this, according to this. So strain perpendicular to the applied force, I already derived you. Area is changing and force is applying. So strain is perpendicular to area. Longitudinal strain along the direction to the applied force. Okay. And after that, let's come to the next chapter, which is oscillation. Okay, question number 1. A wire is stretched such that longitudinal strain is 2 into 10 to the power minus 3 and lateral strain is 5 into 10 to the power minus 4. Then find the Poisson ratio. Poisson ratio, again, I already explained you. Lateral strain, that is 5 into 10 to the power minus 4. And upon longitudinal strain, which is 2 into 10 to the power minus 3. So 10 to the power minus 1, and you will get 2.5. So Poisson ratio, you will get 2.5 into 10 to the power minus 1. What is the unit of this Poisson ratio? Poisson ratio unit, no having any unit. Okay. It does not have any unit. Got it? So 2.5, which means 0.25 is the correct answer. Okay. Anyone who have any doubt regarding to elasticity, he and she can ask me. Anyone who have any doubt, because elasticity chapter has completed. Anyone who have any doubt, he and she can ask to me with the chats so that I will reply to everyone. Nobody has any doubt? Okay. So let's continue our next topics. Let's continue our next topic, which is oscillations. Okay. So oscillation we have to study. And how many topics are inside in this oscillation? Okay. These are all simples. Okay, nothing to be problem. Okay. There is only one separate chapter. Okay, I will discuss after that. I will discuss about rotational motion and gravitational. Okay, that will be very helpful for yours. So, firstly, what is oscillation? Oscillation. Introduction about the oscillation. So, many natural systems execute repetitive to and from motion about a mean position. For example, swinging pendulum, vibrating guitar string, Turing fork, atoms in the solid, heartbeat, AC current. Such motion is called oscillatory or vibratory motion. When oscillations are small and restoring force is linear, the motion is called motion is called simple harmonic motion, that is called SHM. SHM is the building block of waves, sound, light, and quantum mechanics. That is very simple thing. What is, you can say, oscillatory motion? Oscillatory motion, we can say that such type of motion in which repetition about to and fro. For example, look like this. So this motion is repetition about a pattern certain particular limits. Okay, so this motion is called oscillatory motion. And how this motion will call SHM? When displacement from the mean, that is the mean position, and displacement along the mean position, if is it very small, then this motion is called SHM. And if displacement from the mean position is very high, then this oscillatory motion is called SHM. So important key statement which I'm explaining to you, that every oscillatory motion is not SHM, but every SHM is a oscillatory motion. That is a very important key statement which you have to know. Every oscillatory motion is not a SHM, but every SHM is the oscillatory motion. Understood by everyone? Oscillatory motion can be considered as the SHM when particles having displacement from the mean position, it's very small. So if I talk about, you can say, guitar string which having very less displacement from the, you can say, mean position, that is called SHM. Okay, and according to SHM, this restoring force mainly directly proportional to displacement covered by the particle from the mean position. Got it? So mainly restoring force, mainly you can say this restoring force always apply in the opposite direction of, always applying opposite direction of the displacement of the particle. So this restoring force I can be write minus k times of x, because it is always opposing the displacement of the particle. So when particle reaches a mean position, restoring force is 0. When particle move to the highest point, the restoring force is applying in the towards the mean position. After reaching the mean position and after applying the restoring force, after moving to the highest point, again restoring force applying in the towards the mean position. So that is the responsible to moving particle executing in the SHM like this. Got it? So these few kinds of things you have to understand. If any particle execute repetitive to and fro, that is called mean position. From the name about a mean position, that is called oscillatory motion, swinging pendulum, vibrating string, touring fork, atoms in the solid, heartbeat, etc. Such motion is called oscillatory or vibratory motion. When oscillation are very small, restoring force is linear. Linear means the restoring force is depending upon the only value of x. That is called simple harmonic motion. SHM of a building block of waves, sound, light, and quantum mechanics. So it is a building block, which means it is the very basic, so that you can understand waves and mechanics, quantum mechanics also. So it is a very basic thing. Periodic and oscillatory motion. Again, same thing which I am giving to you. Periodic motion, motion that repeats itself after equal time interval, that is periodic motion. Example, Earth revolving around the sun, hands of a clock. If a particular body reaches to its initial position at a fixed time period, if a particular body having a motion and reaches to its original configuration, or you can say original position at a particular time period, that motion is called periodic motion. Got it? And oscillatory motion, periodic motion about a fixed mean position, that is called oscillatory motion. That's also very simple. Pendulum, spring, block, vibrating string, that are also example. Every oscillatory motion is periodic. The converse is not necessarily true, which means every oscillatory motion are periodic, but every periodic motion does not mean is it oscillatory motion. Got it? These are few important points which I am giving to you. Now again, time period, frequency, and displacement. I already told you. Let's talk about this example of pen. So that is the initial position of the pen when it is on rest. So this initial position on which pen feeling rest, this is called mean position. And after some displaced by some value, this pen comes to its regain to the reach to the initial position, that is mean position. Okay, so the displacement of the particle from the initial position, that is called the displacement, and the time period on which particle comes to again first reach mean position, again come and to reach to the final position. So the time reaching to the particle at the two times at the main position, that time period is called that time is called time period. And the number of oscillation at 1 second, the number of oscillation at 1 second, that is called frequency. Got it? So time period is the smallest time interval after which motion repeats unit motion repeat. It is called time period. So motion firstly starting with like this. So 1, 2, 3, and 4, and after that motion will come. The motion will again repeat. So 1, 2, 3, and 4. So this phenomena to covering these 4 steps and time taken to covering these 4 steps is called time period. Okay, and frequency or what? Frequency is mainly known as 1 upon time period. That is called frequency, and that means we mainly refers to that number of oscillation or number of repetition per unit time. That is called frequency. And unit of frequency is hertz, or you can say per second. Second inverse is the frequency unit. Got it? Angular frequency, same thing about, you can say about theta. If any angular frequency, you can also assume as omega. Omega you can assume as omega equals to 2 pi f. It is the relation between angular frequency or normal frequency. Got it? Displacement, physical quantity that changes with the time during the oscillation measured from the mean position, that is called displacement. I already told you, physical quantity that is measured from the mean position, that is vary with the time duration, that is called displacement. Can be linear according to spring, can be angular according to pendulum. So this displacement, in the pendulum case, this displacement is angular displacement because it completes some angle with the vertical. So that is angular displacement. And linear displacement for the spring case, when spring is connected with a particular block, and if the surface is frictionless and whenever you are applying a force, then no force again, you can say no force is again opposed to the direction of the motion of the, you can say, spring block. So if I apply F force on the spring on the block, then spring force again apply external to the outward direction. So after removing this force, we can see that after applying, so spring force applying a F force to the outward direction, so it will move outward. And again spring is stretched, then spring force applying toward the x direction. Okay, then it will come in, it will again pull to the block, and this thing will be happen. Spring will compress and then spring will stretch. So after stretching, after compressing, after stretching, after compressing, force applying due to spring will changing its direction according to compression and, you can say, compression and stretching time. So the displacement covered by the particle about a particular mean position, that is displacement, is linear displacement, that is called x. Okay, frequency can be written as 1 upon time period. Angular frequency can be written as T equals to omega equals to 2 pi by capital T, and omega equals to 2 pi f. These are angular frequency. These are again angular frequency, that is the frequency, and T is the time period. Let's talk about the simple harmonic motion. How can you identify this particular particle having simple harmonic motion? So simple harmonic motion, it is a special type of oscillatory motion, okay, in which the acceleration is directly proportional to the displacement. Acceleration is directly proportional to the displacement from the mean position. It is always directed towards the mean position. Equivalently, the restoring force is linearly displacement is directly proportional to minus x. I have already explained you the restoring force, which is the force on which particle come back to the mean position. That force is called restoring force. Okay, it is always proportional to minus x. Okay, it is always proportional to displacement. If any kinds of motion on which restoring force is directly proportional to x, that motion is called SHM. And after removing this constant, f can be called minus k into x. Got it? So that is the equivalent, the restoring force linear to the displacement in the SHM. Main thing which I again explain you, force can I written as m into a, that will be minus k into x. So a acceleration can be written as minus k by m multiplied by x. So acceleration is always acting on the towards the mean position, which means like I can also say acceleration is always opposite direction of displacement. So I can easily write acceleration equals to minus k by m into x. Got it? The particle oscillates between two extreme points, plus a and minus a, about the mean position. So main thing is that a and plus and minus a, it is the maximum displacement covered by the particle. Let's say particle cover some you can say this type of oscillation. So according to this oscillation, at highest point on which particle can be reached, and on that time after that particle comes to the downward direction. So this highest position of displacement, that is called amplitude, and amplitude can be written as plus a and minus a according to their direction. If amplitude cover distance in the positive x-axis, then I will be write positive a. If it covers minus negative x-axis, then I will be write negative minus a. Okay, so the particle oscillate between two extreme points as a plus of a and minus of a about the mean position. That means x equals to 0. So in the SHM, you can say acceleration due to restoring force I can be measured as minus k into x of function of t. Okay, k by m, and k by m we are known as it can be written as omega square. So acceleration in the SHM with the function of time t is written as minus omega square x is the function of time t. Okay, that is the acceleration. Got it? That kinds of thing we have discussed in the SHM, and F is the restoring force, and this kinds of thing we have finding with the help of this equation. Okay, so that is the SHM. And what is the equation of SHM? SHM equation can be written as x is the function of time t. It will be written as x is the a cos omega t plus 5. It can be also written as x equals to a sine omega t plus 5. And also it can be written as x is the function of time t will be a sine omega t. Okay, and x is also written as a cos omega t alone also. So these are the function. These are the function on which we can stay. That is the SHM equation. So the graph of this function, these are look like this. This is the graph of cos x function. So this function mainly refers to the displacement. Initially, displacement is maximum, and at you can say mean position, displacement becomes 0, and particle moves to the negative x-axis direction. That's why displacement becomes negative, and again come back to the initial position. That is mean position, and come back to the initial position, because particles start with plus a, and after reaching to the again it has reached to the plus a position. So this time duration is called, you can say, time period. Got it? The time period is the total time taken by the particle to reach its initial position during the SHM. That is called time period. So according to this graph, particle initial position at the topmost, and again it's come to the topmost position. So that time duration to covering this distance is called time period. Got it? That is the main thing. So if I talk about you can say some graph, x is the function of time t, that can be written as s cos omega t. So that SHM can be showing like this. Okay. So to reach the point, that means this equation mainly showing to you that initially particles are acting on the highest point, and then you are free. So this equation showing like this. Initially particle reaching at the highest point, and then we are free. So if I free this particle, then it will reach to the initial position, mean position, particle displacement is 0, and again come back to the negative x-axis direction. That means it have maximum displacement along negative x-axis, and again come back to the initial position. That means again displacement becomes 0, and come back to the initial point. That means that is the highest point. So this type of four point particle covers some distance with a particular time. This time is called time period. So have you understood what is the meaning of this equation? Similar kinds of thing we can be applying for the a sine omega t. Okay, so for a sine omega t, that refers this type of graph. And the meaning of this graph, that particle initially meaning of this graph is that particle initially lies on the mean position. You are applying a force so that it comes to the highest point. So at highest point, that means maximum displacement covered by the particle at this point. And after highest point, it comes back to the initial position. That means mean position displacement will be 0. Okay, again come back to the negative axis highest displacement, that is minus a, and again regain to this original position. So particle come back to the original position with 0 displacement. So that total time coverage to reaching this position, that is also time period t. Got it? So these kinds of things we have to understood in the oscillatory motion. So these things I have already told you. SHM equations, amplitude I have already told you, maximum displacement covered by the particle. Let's discuss about this. Particle execute SHM with amplitude 4 meter and angular frequency is 2 radian. Find the maximum velocity. So maximum velocity of the SHM you can be write V max with the direct formula omega multiplied by amplitude. So V max you will get amplitude is 4, omega is 2, and maximum velocity you will be get 8 meter per second. Got it? So it is a direct formula to finding maximum velocity of a particle undergoing the SHM. Okay, let's talk about the amplitude. Amplitude I already told you. Phase constant at omega. What is phase? Phase mainly explaining to you that you can say at a particular time where object will lie in the SHM. For an example, if I write like this equation, and this is already showing to you that particle reaching at initial point. Okay, so that equation you will write this displacement equation as right a sine omega t. But what if I tell you when particle starts their oscillation from this point? Okay, then how will you write equation of this oscillation? So you can consider at t equals to 0, particle lies at you can say a by root 2 distance. Particle lies at a by root 2 distance. At t equals to 0, particle lies a by root 2 distance from the you can say mean position. So you can be right, equation of the motion will be a sine omega t plus phi. Now phi is what? Phi is the additional initially displacement of the particle when t equals to 0. So if at t equals to 0, particle lies on the you can say a by root 2. So put the value of t equals to 0, then you will be get a by root 2, particle at t equals to 0 displacement, that will be a sine, that value comes to the 0, a sine phi. So you will get sine phi equals to 1 upon root 2, and phi becomes 45 degree. That means that is the initial phase of the you can say particle. So the correct equation of the SHM will be a sine omega t plus 45 degree. So that is the equation of the SHM when particle start their motion like this. Got it? And here is the time period of this oscillation. So with the help of phase or phase constant, we can find any equation of SHM. Got it? So amplitude I have already explained. Phase I have already explained. Quantity that specify the state of motion, position, and direction of the velocity. That kinds of thing we have already explained with the help of omega t plus phi. Phase depend on the choice of the instant at t equals to 0. At t equals to 0, where particle lies. So phase will be depends according to particle's initial condition where particle lies. Okay, and angular frequency, that is rate of change of phase, that is omega equals to 2 pi by t, 2 by f. For two SHM of same omega, difference in phi is called phase difference. Similarly, if you have a two equation of SHM like a sine omega t plus phi 1, that is y1, and y2 equals to a sine omega t plus phi 2. So the difference between you can say if the question is saying, okay, for two SHM, the difference between phi is called phase difference, which means the difference between this angular expression omega t plus phi 1 minus omega t minus phi 2. So phi 1 minus phi 2, which you are getting, that is the phase difference, which directly showcasing to you that one particle is how much far from other particle, or you can say one particle how much forward to another particle. That kinds of thing we can understand with the help of phase difference. Okay, so that thing we have already discussed. Time period we can already write omega, we can write 2 pi by capital T. Phase is the omega t plus phi. SHM as a projection of uniform circular motion. That is also very interesting thing. For an example, I have a spring like this. I have a spring on which mass is connected. And if I apply a force in the downward direction, spring moves to the upward direction. Then that SHM will be executed. Can I write this SHM motion according to you can say circular motion? Can I write like this? Obviously, we can write. How? You can just imagine like that. You have a particular circle, and just move your circle. I think you can consider another example is that if you have a particular object, and when you are moving your object in front of, you can say, shadow in front of light, and according to circular path, then you can see that your shadow will be moves like this. According to your displacement, look, moves like this. Got it? So this SHM connection on which we can consider every particle which are executing in SHM, we can consider as a uniform circular motion phenomenon. How is it possible? So consider a particle P moving along a circular uniformly on a circular radius A with angular speed omega. So let's look like this statement. It have linear velocity, okay, angular speed omega, and moving along the circle. Let P dash be the foot of perpendicular from P on a diameter. So P dash is the foot of perpendicular, that is X, I can say, and that is A. So P dash, OP dash, I can say X, I can write A cos omega t plus phi. Got it? That is the displacement. That is displacement from the mean position. This is mean position. And can I write this? So I can be write this, you can say y equals to, that is also known A cos omega t plus phi, A sin omega t plus phi, A sin omega t plus phi. So the displacement of the particle from the mean position is written as a y, that will showcase to you by the changing of value of y, by the changing of value of theta, y is also depending upon the, we can say, angular velocity omega. So that kind of thing is explained with the help of projection of uniform circular motion. Let P dash be the foot of perpendicular from the P on the diameter. Less as P moves on the projection P dash, execute SHM along the diameter. So P 0 to P dash and along to the, you can say, along to the circumference, again come back to the point O, again point A plus A2 minus A. That oscillation is called, you can say, along the x-axis SHM. But if I talk about the along y-axis, that is also plus A, that is also minus A. So that y displacement is also known as a SHM along y-axis. This circle is called reference circle of the SHM. Hence, SHM can be viewed as the 1D projection of UCM, uniform circular motion. So xt is so SHM along x-axis can be written as xt is to A cos omega t plus phi. But with the help of this expression, SHM along y-axis, you can be write displacement along y-axis is y, that is A sin omega t plus phi. So you can find equation of SHM with the help of phasor diagram also. Now let's talk about the velocity in SHM. Velocity you can define with the help of direct formula. Omega under root a square minus x square, and it could be positive, it could be negative, depends upon particle on which particle motion. Okay, so if a particle reaching to the mean position, that on the time velocity will be positive, and if a particle reaching to the highest one, that on that case velocity will be decreasing. Okay, so that kind of thing we can consider v equals to omega a under root a square minus x square. So velocity leads displacement by pi by 2 quarter period. Maximum speed v equals to omega by 2. sorry, a into omega, that is the mean position of the you can say maximum velocity of the particle. Velocity is zero at extreme position. Obviously, velocity will be zero at extreme position because x will becomes to the a. So a square minus a square will be equals to zero. Extreme position velocity will be zero. But if I talk about at the mean position where x is equals to zero, then velocity will be omega multiplied by a. That is showcased to you at mean position particle having maximum velocity. Got it? So this, with the help of this formula, you can find speed of the particle during SHM. Let's talk about the acceleration. Acceleration you can be written as, if I talk about a max you can be written omega square multiplied by amplitude. And at a normal time t, acceleration can be written as time function, which can be written as omega square multiplied by displacement covered by the particle at time t. Got it? So that is the acceleration due to particle during due to SHM. So it has negative value because acceleration always opposite direction of the motion in the SHM. So AT we can be write a minus a omega square cos omega t plus phi. That could be written as minus omega square s omega square x with the function of mt, acceleration of the particle. So what is saying? Acceleration is always directed towards the mean position. That means always opposite direction of the displacement. Maximum magnitude of acceleration, I already told you, omega square a. Acceleration is zero at the mean position. That is also correct. Acceleration is in phase operation. Pi out of phase with the displacement. Okay. So at any particular displacement, acceleration can be written as omega square x if displacement is constant. Got it? So phase relation between among x, v, and a. So phase relation is very simple. This is also giving to SHM motion. First one is a cos omega t plus phi, and second one minus a cos omega t plus phi. That equation mainly refers to you that one particle is free from the extreme position from x equals to a, and other particle is free from the x equals to minus a. Both particle executing SHM. These intersection points refers to you on which time period both will be meet to each other. Okay, that is the intersection points. So you can find the intersection whenever both displacement from the mean position will be equal. If both displacement from the mean position will be equal, then you can solve their equation. And after solving this equation, you can find the value of time period. And that time period value will give the time period of meeting. Got it? These are two equations of SHM. So phase relation between x, v, and a. Phase relation x leads v by n by 2. Okay. That these are mainly showing to that when particles reaches to the extreme position, to the, you can say these are the situation with these two particles, which is showing to the velocity v leads displacement x by pi by 2. Okay. So mainly this equation mainly showing to you the phases, or you can say relation of the velocity with respect to time t with acceleration. For an example, I am giving you a simple representation like this. If acceleration, if a particle's displacement is written as a sine omega t plus phi. Got it? So differentiation of this displacement with respect to time will give you the velocity that will comes a omega cos omega t plus phi. Okay, and double differentiation of this velocity will give you acceleration. So acceleration I will be right minus a omega square sine omega t plus phi. These three equations having these three graph. Initially, particles displacement will looks like this. Particles velocity will also looks like this. Like this. Okay, I'm writing this separately. Their graph will be showing look like this. Firstly, displacement equation. So displacement will look like this. Okay, and it has sine function. And now velocity will looks like has cos function. So it has cos function. And similarly, acceleration is also having sine function. So acceleration will also like this. So their intersection point are directly showing to you in this PDF. Here are here is the you can say here's the you can say velocity. Here is the equation of displacement. Here is the equation of you can say velocity, and here is the equation of again acceleration. And these graphs are showing in front of you, which is directly showing to you that acceleration having same phase with the displacement, but velocity having pi by 2 lead from the displacement. Okay, that kind of thing which we have understood with the help of velocity, acceleration, and you can say displacement. Force law for SHM. Force law SHM mainly defines to you A is equal to minus omega square x, F equals to minus kx. The helmet mark as Newton's second law, F equals to minus ma. Okay, that kind of thing I have. Okay, this thing I have already discussed to you. The force applied on the SHM towards the mean position, it is the restoring force. And after applying Newton's second law, m equals to a equals to minus kx. And after that, you are solving this equation. Acceleration, you will get omega square x, because k by m we can consider as omega square. Got it? So you will get this same expression. I have already derived this equation also. Okay, look at here. Now, spring mass system. Let's discuss about spring mass system, and then energy of SHM, energy of displacement, energy of time, and the simple pendulum. Okay. And force on the pendulum. Okay. Small angle approximation. After that, we have three questions. Okay. So let's cover this spring mass system. Spring mass system I have already discussed to you. Whenever you have a, you can say horizontal surface, whenever you have horizontal surface and you have a fixed rigid wall, this wall is connected with the you can say spring, and this spring is connected with the block of mass m. And what if I tell you, if I apply a force on the system and after suddenly I stop to applying the force, then this spring is compressed with certain distance, and during compression spring will apply restoring force. Spring will apply a force outward the direction, then it will again stretch, and after stretch spring will apply to the inward direction force, then it will again compress. This compression, this stretch, this compression, this stretch will be applying will be repeat with particular time period. Okay, so this F is called minus kx spring force, and it is depending upon the spring displacement. Okay, so can I write again acceleration will be minus k by m, that is x, and this k by m I already told you that is omega square x, that is acceleration a. So omega is already written as k by m, under root k by m. And what is the time period? Time period I can be write 2 pi by omega, that will be time period you will be get 2 pi under root m by k. That is the time period of spring pendulum whenever it has connected with a particular block. Understood by everyone? That is the time period. And omega angular frequency, omega, you can be written as m by k, will be under root. Okay. So that is the time period, that is the omega angular frequency. So a block m is attached to the spring force constant k, frictionless surface. Spring exert the restoring force F is to kx when x is displaced by x. I already told you. Therefore, the block execute SHM with angular frequency omega. And that kind of result I already derived to you. F spring will be applied as minus kx, which is directly proportional to x. That we can say that this block will execute simple harmonic motion. Okay, suffer spring, larger k, higher omega, smaller t. That is also correct. If I have a larger spring, hard spring, which k is very high, so omega will be very high. Omega will be very high. Then time period is also depending upon k. If k value is higher, time period will be less. That is very simple. Larger mass, also time period larger. This result the independent of amplitude of A. Okay. Energy of an SHM. Energy is what? Energy in the SHM, you can see that during the complete motion of SHM, particle having some velocity. If particle having velocity at a particular minute, that means particle having kinetic energy. Particle having kinetic energy. So EK can be written as half m v square. Oh, now you can see that at every point, particle changing its velocity. At highest point, velocity is zero. Initial point, velocity is maximum. Again, highest point, velocity is zero. That means kinetic energy is changing with respect to time. So that's why I can write, if I draw the diagram of the, you can say, particles kinetic energy with respect to time. So at t equals to 0, particle has maximum kinetic energy. Okay. At the extreme point, so this duration time period will be pi by 4. That means t by 4. So particle reaches zero maximum kinetic energy, because at highest point particle kinetic energy is zero. So at t by 4, particle has zero kinetic energy, and after at t by 2, particle having maximum kinetic energy, because on that time particles kinetic energy is the maximum because velocity is maximum. And again at x equals to mean position to the ending point, again kinetic energy becomes zero. So t by 2 kinetic energy is maximum, 3t by 4 kinetic energy again zero, and again reach to the initial position, kinetic energy again becomes higher. So here is the variation of kinetic energy according to particles motion. Got it? So kinetic energy, you can assume like that at a velocity at mean position should be maximum, and at highest point velocity of the particle will be minimum. So according to minimum to maximum, maximum to minimum, minimum to maximum, maximum to minimum, the graph of the particles SHM will be looks like this of kinetic energy. So I have already explained you kinetic energy given as looks like this, and at a certain point when particle having displacement x from the mean position, then kinetic energy you can be written as m multiplied by v, velocity of a particle at x displacement. So kinetic energy you will be written half m, velocity you will be write omega under a square minus x square, that will omega square multiplied by a square minus x square. This is your kinetic energy of a particle when particle covers displacement x. Got it? This is the kinetic energy. Now let's talk about the potential energy. You can see that in totally SHM, mechanical energy is totally conserved. That means kinetic energy convert into the, you can say, potential energy, and potential energy directly converts to the kinetic energy. So whenever particle cover to the at the maximum displacement, then at the time potential energy will be stored. Potential energy is maximum, and then kinetic energy is maximum, potential energy is zero, and again kinetic energy is zero, potential energy is maximum. At initial point again kinetic energy is maximum, potential energy is zero. So if I draw the variation of potential energy, so it will be looks like potential energy according to time graph. We can say initially potential energy is zero, highest point potential energy is maximum. So it will be looks like this. Again, particle comes to the initial point, potential energy is zero, and again reaching to the highest point, potential energy is maximum, and again come back to the initial point, potential energy is zero. So that is the variation of potential energy in the SHM during the complete time period. At t equals to 0, time period is 0. T equals to t by 4, potential energy is maximum. T equals to t by 2, potential energy again 0. And 3t by 4, potential energy is maximum. And 3t to t, sorry, and t, potential energy is again becomes to 0. So look at this two graph. It is the variation of potential energy according to time. Any doubt? Any doubt regarding to this concept? To and fro is called SHM, sir. Yeah. Oh, yeah. That was your previous question. Okay. Any doubt regarding to this explanation which I told you, kinetic energy and potential energy variation in the SHM? Anyone who have any doubt, he and she can ask me. Anyone? Who have any doubt? He and she can ask me. Okay, okay. No, I think nobody has any doubt. Okay. So total mechanical energy, I can be write kinetic energy plus potential energy, that is given as like this. Okay. Let's talk about the, you can say, how potential energy can be measured at a particular distance. So you can say half k x square, that is the potential energy at any displacement x. Okay. So maximum potential energy can be achieved by half k f displacement becomes maximum displacement, that will be half k a square. And maximum kinetic energy I have already give you 1 by 2 m. What is the velocity? Velocity will be omega square, uh, omega into a, okay, so, okay, omega square a square, that is the maximum kinetic energy. So E is dependent of X, energy is conserved, I already told you. E is proportional to A square, double the amplitude, 4 times the energy. That is the few things which I already gave you. Again, I already told you energy versus displacement graph, which is giving in front of you. So this is the only single, you can say, single displacement. According to this displacement, what is the variation of energies? Okay. So initially, potential energy is maximum. Initially, potential energy is maximum. And when it reaches to the, you can say, at, sorry, initially kinetic energy is maximum. Sorry, I gave you. Initially, kinetic energy is maximum. If when kinetic energy reaches, when particle reaches to the extreme position, kinetic energy becomes zero. And when particle reaches to the negative extreme position, again kinetic energy becomes zero. But on that case, potential energy are maximum. At mean position, potential energy is zero, and again at highest point, potential energy is maximum. Got it? So this is the variation of potential energy and kinetic energy graph. I am writing with separately. This is kinetic energy and this is potential energy. Got it? So it's look like this. You can easily compare with this also. Okay, by conceptually it is also correct, and by understanding is also correct. Again, this thing I already explained you how kinetic energy is varying with respect to time and how potential energy is varying with respect to time. I have already explained you according to time period. Look at this diagrams which I already explained you. Okay, so these are the combined diagram of both so that you can identify. Let's talk about the simple pendulum. Simple pendulum is very simple. Whenever you are applying a mass on a particular thread of, you can say, on a wire, then whenever you slightly displaced at a particular angle theta, then it will be perform SHM like this. And this phenomenon is called simple pendulum. Now we have discussed about the, you can say, time period about the simple pendulum. So how can we find? So you can find time period of the simple pendulum like this. Mg sine theta, and it's look like a, you can say, slightly circular motion. Got it? Like this. So can I say that mg cos theta will directly balanced by mv square by r? Can I write? Okay. And particle having velocity v. So total restoring force which are acting toward the mean position f net, which is always equal to mg sine theta. Can I write like this? Obviously, we can write. Let's say it is the displacement of the particle. That is x, and this is L, and this angle, smaller angle theta. If particle executing SHM according to simple pendulum, then theta should be very small. Theta should be very small. If theta should be very small, then sine theta will nearer equals to theta. So I can write f net equals to m multiplied by acceleration, that will be equals to m into g multiplied by theta, that will be equals to sine theta will becomes equals to theta, and cancelled. AC, sorry, AX acceleration of the, you can say, particle toward the mean position will be g multiplied by theta. Let's you can say let's convert this angle into the displacement x and the L form. How can you write? Can I say if angle is very small, then x will be equals to arc length. So can I write angle equals to arc upon radius? So radius of this wire is equal to L. So theta equals to x by L. Okay. Now let's put the value of theta. So A acceleration you will get g multiplied by x by L. So you can see that A will equal to g by L multiplied by x. That is the acceleration towards the mean position. Can I compare with this acceleration towards the omega square x? X is the displacement. This is also displacement. Omega square equals to g by L. So can I write omega equals to under root g by L? I think I should write in the next page. Okay, I am writing omega square equals to g by L, and omega you will be get under root g by L value. And time period you have already know, time period equals to 2 pi by omega. So time period of the simple pendulum you will be get 2 pi under root L upon g. That is your expression. Okay, that is the time period of simple pendulum. So what kinds of things we have discussed? So firstly, heavy point like bob mass I am suspended from the fixed rigid support a light inextensible string of length L. That kinds of thing I have already explained you what is simple pendulum. Displaced slightly from equilibrium position and relaxed to the bob swing in the vertical plane. Displaced by the slightly angle and free. Then it could be performed as a SHM. Okay. For small angular displacement, motion is approximately as such. I have already told you. Angular displacement is theta, plays the role of x. That kind of thing I have already discussed. Okay, look at this diagram. mg acting in the downward direction, and that angle will be, let's say, this angle is theta. Okay, if this angle is theta, why mg cos theta towards upward, not upward? mv square mg cos theta acting like this. Okay, and this will be balanced by tension. Okay, and mg sin theta will be act as a tangentially. Okay, that is mg sin theta. So that thing I have already discussed. F net towards the direction of the motion will be only mg sin theta, and we have do this type of calculation to find time period. So time period I have already discussed. So two forces act on the body. T equals to tension along the string, weight mg vertically, which I already gave you. Resolve mg along two direction, mg cos theta balanced by the t. I have already told you. This is the time, this is a t, and this is the mg cos theta. This direction is wrong. Okay, mg cos theta, and this is mg sin theta. And resolve mg. Okay, I already give you perpendicular to the string. Mg sin theta is the restoring force. Restoring force can be written as minus mg L sin theta. I have already told you. For smaller angle, theta can be converted into the theta. Again, due to angular frequency. That kinds of thing I have already derived to you. Okay. I have written as a form of x. Okay. But I have written this expression got with the help of, you can say, theta. So those of things will also correct, but you can consider x also. Got it? So this smaller d2 theta by dt square will equal to minus g by L into theta. So omega you will get g by L with the same expression with x I have already explained you, and time period you will get 2 pi under L upon g. So let's discuss about the question. A pendulum has time period capital T on Earth. It is taken to a planet where radius is same as Earth but mass is half. The new time period of the oscillation will be. So time period is mainly totally depend upon 2 pi under L upon g. L is what? L is for Earth. For Earth, time period is, you can say, T. Now, the another planet whose mass is half of the Earth but radius is same. That means gravitational acceleration can be written as J capital M by R square. So if radius is same, then mass is half, then we can say that the G new will be equal to G old divided by 2. Okay. If G old divided by, so I will be right, time period will be 2 pi under root L upon G new. G new will be G old divided by 2. That means equal to 2. So overall, what is this? G old multiplied by root 2. What is this? This is the time period of Earth. So T dash you will get T old multiplied by root 2. This is your answer. So which is the option is correct? Option B is the correct answer. Okay. I hope you are getting the understanding regarding to it. Let's solve the second question. A pendulum is taken to height equal to the earth radius. Okay. The ratio of new time period to the original time period will be. The question is slightly different. A pendulum is taken to height equal to the earth radius. Okay, equal to the earth radius. The ratio of new time period of original time period is. I think you have to solve by yourself because you need to use your brain also to solving this question. All of this question is totally depend upon the about theory. Kindly kindly solve this question by yourself, and tomorrow you can ask me any question regarding to this question. Okay, so after all, we have covered some few topics regarding to class 11th. If you have any doubt, he and she can ask me. After that, we can continue with our next chapter, which is rotational motion. Any doubt regarding to this chapter? Any doubt regarding to SHM, regarding to elasticity? If anyone have any doubt, he and she can ask me. Nobody has any doubt? Okay. What are you saying? Sandhyana? Sandhanya, what are you saying? Okay. Still, how many chapters are there? Only 2 chapters are pending. Or some thermometer related, that was lower weightage chapter are pending. Okay, someone is saying repeat again, sir. Okay, Sandhyana, what kinds of thing you want repetition? Time period of pendulum you want to repeat? You want repetition of time period of simple pendulum? Kindly reply. Okay, so let's talk about our new chapter, which is mainly refers to us as a gravitation mainly. So where is the PDF of gravitation? Okay. Wait a minute. Okay. So let's start our new chapter, which is gravitation. So gravitation is very simple. So at briefly introduction, I can give you the gravitation regarding to is gravitation is the force of attraction between two forces. This force was discovered by the Newton. It's mainly refers to us if any two bodies having mass, or you can say if two bodies having some momentum, then the force of attraction between the two masses is called gravitational force. And according to Newton's, this force of attraction mainly depends upon the distance between their masses. Okay, so this gravitational force mainly I am giving to you. Wait a minute. This gravitational force, I should increase the thickness. Okay, this gravitational force, it's mainly depending upon their distance square. This gravitational force is mainly depending upon their masses. So by using this expression, we can say gravitational force of attraction mainly explained to you that's G m1 m2 upon r square. R is what? Distance between distance between two masses. Okay, these are the same thing which I already explained to gravitational force and negative attraction force between two masses. You can read like this. Everyday example you have already understood about it. Whenever you are free fall of the object motion under the gravity, that is called the you can say gravitational force example. Orbital, you can say planet revolving around the sun, that is also called the gravitational force of explanation. Okay, from geocentric and heliocentric Plutony Earth-centric model, plants move in the complex epic cycle. Okay, simple and more accurate. Techno accumulated. Okay, these kinds of informative things that you have to understand. It's not you can say important for your syllabus. Okay, Lord, let's talk about the Kepler's law. What is Kepler's law is saying? Every planet moves in the elliptical orbit. That is a good thing. The path of revolving of any planet around the sun, that is elliptical path. The sun lies at one of the two foci of the ellipse. That is also called, we have discussed about the Kepler's law. Okay, so according to Kepler's law, every planet moves in the elliptical orbit, which I already discussed to you. The sun lies at the one of the two focal point of the ellipse, which I already told you, that is the first focal point, which is lies according to sun, and the second focal point can be considered as this point, which is unknown. And Aphelion is the farthest point from the sun. Okay, and perihelion is the closest point of the star. That is also I already discussed to you. Average distance between from the sun, average distance from the sun, average distance from the sun, that is semi-major axis. And eccentricity, I have already explained you, 1 plus b square by a square. B square is major axis and a is semi-major axis. Got it? Let's discuss about Kepler's law or law of areas. The line joining a planet to the sun sweeps out equal areas in equal time interval. That means, according to Kepler's law, every planet is revolving along the elliptical orbit. At least showcasing to you, if let's say Earth is revolving around the sun. So the area covering by the sun to point A to B, A, B, covered by the area by the Earth near to the sun, that will be equal to C, D, and F. Area of ABC directly equal to area of C, F. So what is the main thing and what main fact is inside this statement? So statement is tightly saving when you can see Earth is very far distance from the, you can say, sun, then their area velocity will be lesser. Okay, but when it comes to the close to Earth, then its velocity is high. So that is the meaning of this first statement. Consequence: planets move faster at perihelion, slower at aphelion. At the far having slower at the nearest point of the having faster, you can say, having higher speed. Okay, this law is the result of conversion of angular momentum. This law is the result of the conversion of you can say, angular momentum. How? Because no external torque is applied during the motion of the elliptical path. So we can say that angular momentum will be constant. So dA by dt, this is the aerial velocity. So aerial velocity can be written as dA by dt will equals to L upon 2m. L is what? L is angular momentum. L is angular momentum and m is the mass. Okay. Kepler's third law is saying the square of the period of revolution is proportional to the cube of the semi-major axis. The square of the period of the revolution is proportional to the cube of the semi-major axis. Square of the time period of revolution will directly proportional to the cube of the semi-major axis. That means 4 pi upon gm dot a cube. So according to this law, t square is directly proportional to the a cube, which is semi-major axis. Got it? Holds for every planet between the sun and satellite around the planet. Constant k equals to 4 pi or upon gm depends only the center of
Sir, your voice is not clear. Sir,
My voice
your
is clear?
not. So can you repeat this slide, Kepler third law?
Okay. My internet is lacking. Okay, no problem. So according to Kepler's third law, it's mainly saying to you the time period of revolution of square that directly proportional to semi-major axis cube. And here is the direct formula of time period so that you can find time period of revolution is 4 pi. We have discussed about Kepler's third law. So Kepler's third law mainly saying to you time period and you can say semi-major axis relation. So time period square is directly proportional to semi-major axis cube. That was your first statement of Kepler's law. Okay. Second thing which I am giving, this time periods equation will directly you pi square gm multiplied by a cube. So you can see that with the help of this equation, t square directly proportional to a cube. Got it? Let's discuss about the particular question. A planet moves in an elliptical orbit with the sun at one focus, at which point its angular momentum is maximum. So dA by dt will equal to L upon 2m. I already told you. So at which point where angular is maximum. So angular momentum maximum, that means at every point dA by dt is constant. At every point dA by dt is constant per second law. So at Ferri, same at all, and mass is also constant, then angular momentum is constant. Got it? So same at all point. Someone is replying something. Okay, nobody has replied. Okay, so we have discussed a question. I have already explained force can be defined as a G m1 m2 upon r square. That means it is always attractive in nature. Let's say we have to question two bodies of masses m and 4m are separated by distance smaller. Where should a third mass should be placed at gravitational force on its zero? That's the very simple question which I'm asking, which is placed in front of you. And that is the m mass, and that is the capital 4m mass are situated at a distance smaller. Now the question is saying where third mass should I placed so that net gravitational force will be zero. Let's consider third mass is putting like you can say like this at this point, okay, and its mass has m dash. So force due to first particle, let's say this is having distance x from the small m, and the remaining distance is r minus x from capital M. So if a net gravitational force should be zero, that means g f due to m dash, that will be equal to f due to 4 m dash into 4m. So you will be write g small m capital small m dash upon x square, that will be equal to g capital G 4m m dash upon small r minus x square. So let's cancel m dash will be cancelled, g will be g cancelled, m lp will be cancelled, and 1 upon x square will equal to 4 upon r minus x whole square. So 1 upon x will be equal to plus 2 upon r minus x. So we consider two values negative form. So firstly consider positive value. So 1 upon x will equal to 2 upon r minus x equals to 2x r by 3. Anyone have any option? At a distance r by 3 from small m. So first, okay, and second one at a distance r by 2 from 4m. No r by 2, r minus r by 3 distance comes to the 2r by 3. So it's not a correct answer. At a distance r by 3 for 4m, no. Distance 2r by 3 for 4m. So that's why B option is the correct answer. At midpoint, no, it is also wrong answer. So correct answer is r by 3 from the, you can say, lighter mass. Okay. Superposition principle. So superposition principle is the gravitational force to any particle, it is the sum of individual force. That is very simple. Each pair obeys Newton's laws independently, allow us to compute net force on a mass due to any distribution, extend to the continuous mass distribution via integration. So mainly this superposition mainly saying, let's say 3 particles are arranged in like this situation. Okay, so the net force on the not due to you can plus f due to m1m plus f due to m3m. Then you can also making a pair f due to m2 m1 and f due to m1 m3 and f due to m2 m3 has written. Okay, and M1, M3 as written. The net force will be acting by all pairs. So that is the superposition principle which is saying. So main thing is that according to superposition principle, if you have a two and more than objects who have separately masses, then F net due all total system that will be pairing of pair between two masses. Okay, it is the total. So that is again one more question which is asking three equal masses are placed at a vertex of an equilateral triangle. The net gravitational force on the mass placed at the centroid is, you have to do yourself. That is our HW. Okay. The gravitational constant again, G is the universal gravitational constant first measured by Henry Cavendish 1798 using a torsion balance. Same value throughout the universe independent of the medium. Value of G can be written as 6.67 multiplied by 10 to the power minus 11 Newton meter square upon kg power minus 2. These are all things are informative. You just have to understand regarding to this. SI unit of G will be N Newton meter square upon kg kg 2 inverse. Okay. That's gravitational scale. It is very small gravitational because G has very small. That's why gravitational force between two normal bodies are very less as compared to other. Of gravitational constant. Now let's discuss about the, if G equals to 1 in system of unit, the dimension of mass is, again that is simple. F will equals to G m1 m2 upon r square. Okay, so if G equals to 1 in the system units, that means the dimension of the mass will be, so dimension of force m1 L1 T minus 2. If G equals to 1, that is equals to 1, and mass unit will be, you can be written as m1 and not m1, you can assume as x to be, that is also considered as mass. So m I can consider as mx. Okay, so it is also again considered as x and L2. So x you will get L cube T minus 2, that is the dimension of mass. Which option is right? L cube T minus 2. Option A is the correct option. Got it? So now let's consider acceleration due to gravity. Acceleration experienced by the falling body nearest Earth's surface. Okay, Earth treated as a uniform sphere attracts body, all bodies using energy to G. G depends only mass and radius of the Earth of the free falling body. So mainly, whenever you are writing, weight of the body is given as m into G. G is what? That is the mg is what? Mg is the gravitational force due to Earth. So you can be write G capital M small m upon radius of the square of Earth, that is r square, that is equal to m into G. M to m will be cancelled out. This is what gravitational acceleration, and gravitational get G capital M upon the radius of Earth square. So that is a gravitational acceleration. So we have got these kinds of things. So Earth is attracted towards its center due to gravitational force, and this gravitational force intensity is also called gravitational acceleration, or you can say gravity.
Yes, sir.
So what?
Sir, your voice is not clear right now. Your voice is breaking.
Still,
Yes,
I
sir.
think, sir, due to internet connection issue. So can we continue this chapter in the next time? Because I am facing some internet connectivity. That's why my voice is not clear. Now my voice is clear, sir.
Yes.
Or
Right now
still
your voice
lagging?
is clear.
Right now my voice is clear.
Now your voice. Yes, right now your voice is clear.
Okay, let's continue with our chapter. Now, according to gravitational acceleration calculation, small g refers to.
Start breaking, sir.
Now my voice is breaking.
Now clear. Start.
Okay. Gravitational acceleration formula, we are getting G capital M upon radius of Earth square. Got it? Now let's put the value of mass of the Earth, that is 6 multiplied by 10 to the power 24 kg. That is very high value. And radius of Earth is 6.4 into 10 to the power 6. After putting this value, you will be get gravitational acceleration value is 9.8 meter per second square, which are you are using in the kinematics related problem. Okay, so this value comes out from this expression by the putting this value. Let's solve a particular one more question. A body is taken from Earth's surface to depth equal to half of Earth's radius. What will be the acceleration due to gravity? So whenever you are moving inside the Earth, the gravitational acceleration you can be write g dash equals to g plus 1 minus d upon r. D is what? D is the depth from surface. So depth from surface is given as Earth's radius. A body is taken from Earth's surface, depth is equal to half of the Earth radius, which means d equals to capital R by 2. So the g dash you will find r g multiply 1 minus r by 2 multiply by r to r will be cancelled out, 1 minus 1 by 2, that will be equal to 1 by 2. So g dash you will get g by 2, which means at depth d, which is equal to radius of the Earth, then gravitational acceleration becomes half of gravitational acceleration on the surface, that becomes g by 2. That is your answer. Now, variation of gravitational acceleration with height. So gravitational acceleration mainly depends upon the, you can say, distance between two objects. For example, if object which having, let's say this is the radius of Earth's mass is capital M, and let's say object having height h. So gravitational acceleration on this point due to height h will be g capital M upon radius of Earth plus height square. Okay. What if I tell you if this height is normally comparable to the radius of the Earth, then, but if this height is, you can say, very small as compared to radius, then this formula will be changed. How it will be changed? That it will be changed like this: g capital M by re plus h square. Okay, let's take common h. Let's take common r from the, you can say, expression. Then you will write g capital M upon r square 1 plus h square by 1 plus h square by r e square and whole power square. Now these terms will becomes very less. If I talk about in the maths, 1 plus x to the power n, and if x less than 1, that means your expression will be written as 1 plus n into that kinds of thing you will be applying. Okay, so how you will be applying? You will be write like this. This also looks like what? This also looks like at the surface. So you will be write according to this formula, g at small g at height h, you will get small g multiplied by 1 plus r square, sorry, h square upon r square power minus 2. So this expression will looks like 1 plus x to power minus n, and x is very less than 1, then you can be 1 minus nx. So you can expand this expression like this: if h square 1, so g at particular height you can be written like this: g multiplied by 1 minus nx. Nx means minus 2 multiplied by h upon re. Okay, so that is your gravitational acceleration up to height h. Looks like this. If h is very less than, you can say, radius of the Earth. So gravitational acceleration at height h, when h is less than r, then you will write g at surface multiplied by 1 minus 2h upon radius of the Earth. Got it? And at the simple simple formula, RE by H whole square, gravitational acceleration due to up to height H. Got it? And variation of depth, I have already explained you G1 minus D by RE with the help of question. Let's solve this problem with a particular question. A body is projected vertically upward from the surface of the earth with velocity equal to the half of the escape velocity. The maximum height reached by the body in Earth's race is that. So, to solving this problem, you have to understand about the, you can say, escape velocity. How can you find escape velocity for this situation? Escape velocity is the such type of velocity on which whenever you are projecting a particular particle outward the, you can say, gravitational field, so that velocity will be required so that it can easily move the gravitational field of the earth. Let's say if a particle moves to the out of the gravitational field from the earth, that means I can say that particle reach to the infinite position. So at infinite position, gravitational potential energy will become zero, but at a surface, gravitational potential energy due to small m mass and earth will be G capital and small m upon radius of the earth. That to change in kinetic energy. So at V, so at infinity value at initial point, that is the escape velocity which is required. That half m v square velocity. So escape velocity you will be get V equals to 2 capital G capital N by R E upon square root value. Now according to this question, if a body is projected vertically upward with the surface of the earth with the velocity equal to the half of the velocity. Extra velocity is written like this, half of extra velocity divided by 2. So you can be right potential energy at the surface G capital M small m upon RE, and potential energy at a particular height can be written as G capital M small m upon R plus H. That will be equal to change in kinetic energy. So change in kinetic energy initially is 0. At final, it becomes like this velocity. So initially it is 0. At final, we don't know. So we can find the maximum height at maximum height, particles velocity will become 0. So final kinetic energy will be 0. Initial kinetic energy will be half m v projection square. Got it? So let's solve. So final minus initial potential energy, you can be right G capital M small m upon R plus H minus G capital M small m upon radius of the earth. That will be minus times of half m v projectile velocity. So minus will be cancelled out, and that value will becomes you can say you can assume G capital M small m common, and R plus H and R will be LCM. R plus H cancelled and R will be multiplied, and minus R plus R minus H. So that will becomes minus G capital M small m H upon R plus H. That will become half m v projection velocity. Minus to minus will be cancelled out. M to m will be cancelled out, and v projection velocity will be VE by 2. So you will write, I can have separate slide value so that I can solve this numerical. So G capital M multiplied by H upon R plus H will equals to half M will be cancelled, and this velocity will becomes VE square by 4. That means 2 times of G capital M divided by radius divided by 4. So this answer you will get 2, so 2 will be cancelled out, GM will be cancelled out, and R will be multiplied. R will be cancelled or not? Not, R will not be cancelled. So 4 times of R will be multiplied. 4 times of RH will equals to R plus H, and H you will be get RH minus H will equal to R. H you will be get R upon 4R minus 1 is the height. And let's consider r is the radius of the earth, which is very negligible. This term will be negligible. 1 minus, that means 400 kilometer minus 1. That is the very less negligible value that you can be considered as a radius of the earth also. So r upon 4r minus r, that is also considered by 4r. So overall answer you will get r upon 4. That is your final height. Got it? And option D is your correct answer. So that is your numerical, which I have already solved. I think time already over. So I think we should complete this chapter in the next class also. So half of the chapter will be remaining, and it could be take mostly half and 1 hour also in the next class. So we will cover in the next class also. So if you have any doubt regarding to this, any numerical, any question, he and she can ask me. After that, we can end this today lecture. Anyone who have any doubt can ask me any question. Okay, if nobody has any doubt, we can stop this lecture from the right now, and in the next lecture we can continue. So today we have ended this lecture for 5 p.m. So in the next lecture we will cover also gravitation and rotational, and after that we can continue with our next class 12 physics. Okay.
A force that acts due to a body's mass is called gravity. So
This call is now being recorded.
so for
This call is now taking notes.
yeah, so for this very reason, you would have often observed that when a ball falls, when you any object actually, any object when you throw it up, it always tends to come downwards. This is due to the force of gravity of the earth. So Galileo found out that all bodies fall with the same acceleration independent of the mass, and Newton actually just he basically unified all of these laws under one law. So it is so this same force called gravity makes the apple fall, and it also holds the moon in its orbit. So all you have to keep in mind is basically the force produced by a body due to its mass is the gravitation force. And also it is the weakest of the fundamental forces. Now what were the four fundamental forces? Electrostatic forces, gravitation forces, strong nuclear forces, and weak nuclear forces. So among all these forces, the weakest was force of gravity. So basically, this gravitation, the concept of gravity didn't wasn't introduced at once. It was obviously transferred from centuries to centuries. So each century, a new concept was introduced, and that is how we have our fundamental laws today. So, a very important thing this is Kepler's first law. So, what does Kepler's first law states? It basically says that every planet moves in an elliptical orbit. An elliptical means basically an oval-shaped orbit, as you can see in the diagram. So, an oval-shaped orbit is an elliptical orbit. According to Kepler, the sun lies at one of the two foci of the ellipse. So, foci basically means focus. So, the ellipse or the oval shaped thing, this is from maths. So, an ellipse has two focus. Okay. So, the sun, Kepler stated that the sun lies at one of the focus of the ellipse. So, the sun is at the focus of the ellipse, and the planets revolve around in the elliptical orbit. Now, what is perihelion and aphelion? So, perihelion is the closest point to the sun, and aphelion is the farthest point from the sun. Semi-major axis is the average distance from the sun, and eccentricity measures how elongated the ellipse is. Elongated means how long, how long it is. So, that is the eccentricity E. So basically, the first law states that, summing it up, it states that every planet moves in elliptical orbit, and the sun is at the focus of this ellipse. This is what the first law states. You have to remember the first 2 points. And then the second law states it is the law of areas. So let's say we have sun and we have a planet at the orbit. So the line joining a planet to the sun sweeps out equal areas in equal intervals of time. So, so let's say my planet, let's take the orange triangle. So from if a planet moves from this vertex to this vertex, and if it moves from this vertex to the green triangle, so what Kepler stated that the area of the orange triangle and of the green triangle is the same. Basically, in equal time interval, in the if planet A moves in time t and B also moves in time t, so this planet sweeps out equal areas, like in the same timing the planet will sweep out equal areas, whether it is doesn't matter the distance basically. So what does this stated that planets move faster at perihelion and slower at aphelion. So perihelion is the closest point and aphelion is the farthest point. So at perihelion, that is the orange triangle, it moves faster, and at the green triangle it moves the slowest. Then next it states that the force is central, so torque about the sun is 0. So basically second law states that the basically a planet at certain distance from the sun sweeps out equal areas in equal intervals of time. So this is second law, and the first law states that all the planets move in elliptical orbit and the sun lies at the foci of the ellipse. Then what we have then the third law states that it is basically a mathematical thing, that the square of the time period of revolution is proportional to the cube of the semi-major axis, which is a. So basically t square is proportional to a cube. That's all. That's what the third law states. And these two are related with some constant, which is 4 pi square by gm. So this is just a formula. There is no explanation to it. You just have to remember this. And these are some tables, planet with their semi-major axes and time periods of revolution, and then the values for that constant. As you can see, we get the same value for t square by a cube. So for this very reason, we have that we derive this law. Okay, so let's do this question. A planet moves in an elliptical orbit with the sun at one focus. At which point is its angular momentum maximum? So this is asking about the angular momentum. Now angular momentum is it will be what for this elliptical orbit? It will be mvr sine theta. So from here, from Kepler's second law, which is dA by dt, we get L by 2m is equal to constant. Basically, the angular momentum, since the force is central and there is no net torque acting on this, there is no torque acting about the sun. So due to this, the angular momentum is constant at every point. And therefore, for this, the answer is that angular momentum will be same at all the points. So let's come to universal law of gravitation. This states that every particle attracts every other particle in the universe. So basically, since gravitational force is due to the mass, so obviously any body that possesses mass will obviously attract the other body. So it basically states force is directly proportional to the product of their masses, inversely proportional to the square of distance. And this, you have to remember this thing, that the force acts along the line joining the two particles. Basically, the gravitation force is a central force. It always acts at the line joining the center of the particles. So this, you just have to remember the formula, which is F is equal to G into m1 m2 by r square. So since this force is vector, force is always a vector quantity. That's why it has a direction. So gravitation force is an attractive force. It is never repulsive. So it will obviously attract the other body. Okay, now let's do a numerical. Two bodies of masses M and 4m are separated by distance r. Where should a third mass be placed so that the net gravitational force on it is zero? So in order to solve this, I will have to show you a screen. So what does the question say? It says that we have a mass m and we also have a mass 4m, which is separated by a distance r. So since gravitational force always acts, okay, let me draw a diagram also. This is m and this is, so since gravitational force always acts along the line joining the center of the masses. So that means the point where the net gravitational force should be zero will definitely lie between the masses. So we know one thing for sure, that it will lie between the masses only. So it will lie somewhere here only. So let's assume this distance or this point to be at a distance x from the mass m. So this is at a distance x from mass m, this point. I will take this point as p. So since the distance of both of these from each other is r, and the distance of p from m is x, so the remaining distance will be what? R minus x. So for the net gravitational force to be zero, this basically means that the force from m cancels out the force from 4m, right? So this would mean that we just have to use the gravitational formula, which was gm by x square should equal to g4m by the distance of this point, r minus x square. Simple. So what we did here, we know that there is a point P where the net force should be zero. So I simply equated the force, because in order to cancel both of them out, we will need them to be equal, right? Since they have to be equal to cancel each other out. So we will just cancel G and M, two masses. Okay, so you are correct, but the question here says that we have a mass here at this point P. Okay, so this point P, the force due to these masses on this should be zero. So what I did is, let's assume this mass to be some capital M. Okay, so the gravitational force between M and capital M will be this, and the gravitational force between 4m and capital M will be this. So ultimately it will cancel out. So that is why we will eventually get g into m by x square, which is 4. So that is why we will get the simplified version as that. G will cancel out, m will cancel out, capital M, which is the mass of the object placed in the center, that will also cancel out. So what we will have is 1 by x square is equal to 4 by r minus x square. So now just simply equate those. We will get r minus x is equal to 2x. And then r will be equal to 3x. So I will get x as r by 3. So my answer is that at a distance of r by 3, I need to place this mass m. So the net gravitational force will be 0 there. Does anybody needs explanation from this problem again? I can explain this again also. Should I repeat this question? Okay. So this question basically stated that you have one mass and you have another mass, which is separated by some distance. You have to place a third mass at some distance to cancel the net gravitational force. So you'd have to find the distance at which that third mass needs to be placed. So that's how you calculate it. the answer. So it should be r by 3 from m, from the mass m, because x was from m. So let's continue. Now in gravitation also you have the superposition principle. If you have studied electrostatics, basically the sum of the forces, sum of the gravitational forces due to many particles, you will obtain it due to the vector sum of the individual forces. So basically, if you have m1, m2, and m3 masses, and you have to find the net gravitational force on the mass m, so you will basically have to please explain the last question. Okay. So this superposition principle, you just have to vectorly add all the forces and you will get the answer. Now, vector addition is kind of complicated, so you will have to do it part by part. But you just have to know that you have to vectorly add it, because force is a vector quantity. So obviously, the addition needs to be vector. Okay, I will repeat the last question. Okay, let's come here. So in the question, you have two bodies of mass m and 4m. Just ignore the typing mistake. They have it has been written so many times. So basically you have a mass m and you have a mass 4m, okay, and they are separated by a distance r. Now the question asks you to place a third mass so that the net gravitational force on it is 0. So let's go back to the question. So basically, let's say I have a mass m, I have a mass 4m. I have to place a mass. I will call it capital M. Actually, you don't need the mass of the third mass, but I will just call it capital M. I have to place a mass capital M somewhere such that the net gravitational force on it due to M and 4M cancels out. Okay. So for this, I am assuming that I am placing this mass at a distance x from M. So automatically the distance from 4m will become r minus x, since both are separated by a distance r. Okay, so I found out the distance from both the masses of m. Then I simply applied the gravitational formula, which is force of gravitational formula is what? m1 m2 by r square, right? So force between m and capital M will be what? G into small m into capital M by x square, since the distance between them is x. And this will be equal to this force, since both of them are cancelling each other out. So they have to be equal to cancel each other out. So that is why I am equating it with the forces between capital M and 4m. So G into 4m into capital M by r minus x square, which is the distance of this from capital M square. Then I can simply cancel capital G, I can cancel small m also, and I can cancel capital M also. So at last I got 4 by x square into r minus x the whole square. Now you just have to simplify it. Okay, so 1 by x square is equal to 4 by r minus x the whole square. So rearrange it. R minus x the whole square will be equal to 4x square. Now if I put the square root here, it will become r minus x is equal to, it will become 2x. So I got this equation there. Then you will get r is equal to 3x, and then you will get x is equal to r by 3. So basically I have to place the mass capital M at a distance of r by 3 from the small mass. You can do it any way you want. Like you can also place it at a distance of 4m from here, and you can solve it. It is up to you to take the distance from whichever mass you want. So is this question understood? So superposition principle is basically, it states that the net force on one particle will be the vector sum through all the gravitational forces from each particle. We will also solve a question on this one. Okay, so 3 equal masses are placed at the vertices of an equilateral triangle. The net gravitational force on a mass placed at the centroid will be what? So let's take this question. Okay, so we have 3 equal masses placed at the vertices of an equilateral triangle. So this is an equilateral triangle. I have three masses, equal masses. So let's say all of them have a mass m placed at the vertices of this equilateral triangle. The net gravitational force on a mass placed at the centroid will be what? So centroid, what exactly is a centroid? So if I draw a median from each of the vertices, so let's say I draw a median, I will name the triangle ABC. Let's say I draw a median from C to AB, then a median from B to AC, then a median from A to CB. So the point of intersection of these medians is what you call a centroid. Okay, now what the question says is, I am placing a mass here, any random mass. I will take the mass as capital M at the centroid. So what will be the net gravitational force here then? So in this also you just basically you have to directly substitute the formula, but you have to do vector addition here as due to the superposition principle. It's stated that the vector sum of the forces you have to obtain. So let's solve this. Um, although there is a bit complex maths for the distance from the centroid, but since it is an equilateral triangle, you can remember one thing, that the distance from C to the center, B to the center, and A to the central will be equal. Okay, since this is an equilateral triangle, so let me take the centroid as O. So this is O. So what I mean to say is CO will be equal to AO and it will be equal to BO. Okay, since due to symmetry and since all the sides are equal, so you will have the distance of these from here to here to here will be equal. So yeah, so basically you have the distance from the mass to the central mass, which are, you can take these as R. So just substitute. Okay, so basically what did you get from this? That all the forces due to A, B, and C are equal. At least the magnitude is equal. Okay, so we found the magnitude for each force. Now let's look at the direction. Since they have to be added vectorly, so that is why I also need the direction of each force. So in this case, what you will have to do is you will have to take the resultant. Okay, so force due to A, B, C, force due to C will be this. Force due to B will be act along this direction, and force due to A will act along this direction. Now, for vector addition, what you can do is you can first take the resultant of FB and FC. Okay. So when you take the resultant of FB and FC, Okay, this is the formula for the vector resultant. So here ax square you can take fc square plus fb square plus 2fc fb cos theta. So since all these forces are equal as we gathered from here, so basically let's take all these forces to simply be F since they all are equal. So I can simply substitute it like this, plus 2F square cos theta. Now what is theta? Theta is the angle between the two forces, that is this angle. Now, since this is an equilateral triangle and all these partitions are equal, so basically I have to divide each force by 3 because one circle is 360 degree. So one portion of the 3 will be 120 degree. So basically this will be, theta will be 120 degree between each force. So I will simply get 2f square plus 2f square cos 120 is minus half. Okay, so into minus half, so this 2 will cancel out and I will get 2f square plus, sorry, not plus, minus, since there is a minus sign, and at last I will get the answer to be f. So what did you understand from this? That means if I add fc and fb, the resultant that I'm getting is again f only. So since I already resolved fb and fc, now what is left? Now the only force left is fa and f, which is the resultant of fc and fb. Now in order to take their resultant, I don't even have to calculate anything, but I simply have to take the values. So since fa was also equal to f and below also there is an f, since these forces are acting in equal and opposite directions, my resultant will be 0. So my answer for this question should be 0. Okay, I understand this was a sort of confusing question. So if anybody has any doubt in this question, I can explain it again in a more simpler manner. There was less gravitation. There was gravitation in this, but it was more about vectors. So if you are clear with vectors, this question will be very easy to solve. Okay, basically, we calculated the magnitude of force, then we performed vector addition, and then we found out and through the magnitudes, I just cancelled out all the forces. So if you don't have any doubt, let's move forward. Now we have the gravitation constant. It is basically a constant. That means the value for this is universally accepted everywhere. This has the same value throughout the universe. It doesn't even matter the medium. It has the constant value, which is 6.67 into 10 raised to minus 11. So you just have to remember this value. So for this question, if G is equal to 1 in a system of units, the dimension of mass is. So in this, you have to apply this gravitation formula. From Coulomb's law, we know that F is equal to m1 m2 by r square. So just rearrange it in terms of G. So what we will get then, G is equal to fr square by m square. In case the mass, let's take this mass to be equal, since there is no mention of different masses. So we will have the mass as equal, and then G will become fr square by m square. Okay, from this. So just apply the dimension equation then. For force, the dimensional equation is mlt minus 2 For distance, obviously, it will be L square, and for mass, it is m square. Then just simplify this. You will get m minus 1. Then this will become L cube and then t raised to minus 2. So in the question, it says that we are making G1. So basically, if the left-hand side will become 1, let's rearrange this in terms of mass. So if mass is minus 1 here, when it goes this side, it will simply become m. Then we will have the dimension of mass as L cube into t raised to minus 2. So this was simple. Basically, you had to use the Coulomb's gravitational formula, and you just had to rearrange it in terms of the mass. Then next we have acceleration due to gravity. This is basically the acceleration experienced by a free falling body near Earth's surface. Free fall means that the force on the body is only due to the force of gravity and no other acceleration is acting on it. So G is basically given by G into capital G, that is the gravitational constant, into ME by RE square. Okay, now RE and ME are the mass of the Earth and the radius of the Earth respectively. So from this, we can derive the gravitational acceleration due to Earth. Let's take another question. A body is taken from Earth's surface to a depth equal to half of Earth's radius. What will happen to its acceleration due to gravity? So, so for this, we will need these formulas. So, if variation of g with height, so let's first learn about the variation of g with height so we can solve the above question. So at height h above Earth's surface, distance from the center is re plus h. So since the radius of the Earth is re, obviously at a height h above the surface, it will be re plus h. So g decreases as we move away from Earth's surface. So for a height h above the Earth's surface, the formula for g is capital G into me by re plus h square. This we basically substituted the re in this equation. So this was with height, and for depth it is similar thing, but we just make it to 1 minus d by re. So now we can solve the question. So a body is taken from Earth's surface to a depth equal to half of Earth's radius. So what will happen to its acceleration due to gravity? So basically the depth is r by 2, radius half of the Earth's radius. So in this formula, if I simply substitute r by 2, you just have to substitute r by 2 and you will get d is equal to r by 2 and you will simply have your answer. So the answer should be equal to 1 by 2 since this r by 2 will r and r will cancel, so this will become 1 minus 1 by 2 and 1 minus half is again half, so then the g will become g by 2. So this was basic direct formula substitution. So let's come to escape velocity then. Let's come to gravitational potential energy. Energy stored in a system of masses due to their gravitational interaction. So basically, the work done by a gravitational force on one mass is stored at its gravitational potential energy. For near Earth, it is given by UMGH, and for in general, it is given by minus of G into ME M by R. Then we have a thing called gravitational potential. It is basically the work done in moving the mass from infinity to a certain point against the gravitational force. So this potential is given by potential energy by M, or in general it is given by minus G into M by R. You can correlate this with electrostatics also. In electrostatics, V is given by K Q by R. In this, replace the Q with M and G with K. So you will have this. A particle is taken from the surface of the Earth to a height equal to Earth's radius. The change in gravitational potential energy is. So you just have to simply substitute in this formula in the general form. So in this R, you have to substitute the R by 2, which is the half of radius of the Earth. Sorry, not half. It is in this. It is equal to Earth's radius. So you simply have to substitute RE instead of R, and then you just have to subtract it. So you will have your answer then. This was also direct formula substitution. Now let's come to escape speed or escape velocity. So the minimum speed with which a body must be projected to escape Earth's gravity. Basically, what the amount of speed that is required by a body to completely escape the Earth, to such that it escapes its gravitational force. So this V escape velocity is given by 2 capital G into ME by RE, or if we simplify this, we can 2 GME, we can get it as 2 into G small g RE. So you just have to remember the formula in this case also, and also you have to remember that for just Earth, the escape velocity is 11.2. So this is quantity, you just have to remember the 11.2. Then come to Earth satellites. So the Earth has a natural satellite, which is the moon, and we also have launched various artificial satellites, which are like for us various purposes: communication, GPS, weather, and so on. The gravitational force provides the necessary centripetal force. So obviously, for a satellite to orbit the Earth, what we will need? It will definitely need a centripetal acceleration or the centripetal force directed towards the center in order to form a circle. So obviously, this centripetal force is given by the gravitational force of the Earth. So this time period is basically the time taken for the body to complete one revolution. This time period is given by 2 pi into root of RE plus H cube by GME. And the V here is the orbital velocity. The orbital velocity is given by this formula. So with respect to orbital velocity and satellite motion, higher orbit defines a lower speed and longer period, and lower orbit means that the speed will be more and the period will be shorter. This you can derive from the formula also. And from this, you can also derive the Kepler's third law, which states T square is proportional to R cube. So for a geostationary satellite, T is 24 hours. That means it takes 24 hours to complete one revolution around the Earth. And for this very reason, it appears to be stationary, though it is not stationary. Since Earth also has a time period of 24 hours, that means it takes 24 hours to complete one rotation. A geostationary satellite takes 24 hours to complete one revolution. So due to this reason, it appears to be stationary even when it is not. So this question also, the time period of a satellite orbiting just above Earth's surface is T. So you have been given the T, and if the satellite is taken at a height equal to Earth's radius, the new time period will be what? So again, in this you just have to substitute height. In height, we will have to substitute radius of the Earth, which will be 2re cube, 2re the whole cube. That will give you 8 re cube by g into me. So that way you can calculate it. Energy, the orbiting satellite also possesses some energy. So in this case, we know the potential energy. This was from the previous formula only, and for the kinetic energy, it is given by capital G into me m by 2r. So basically, the total mechanical energy will be given by adding both of these, which will be minus G me m by 2r. So let's quickly wind up and then solve the questions. So these are some basic concepts that you should just know. So what is weightlessness? The satellite and astronaut both in free fall. So what happens when a astronaut is in? So when an astronaut is in a satellite, the astronaut experienced something known as weightlessness. Now, when does this weightlessness happen? When both the satellite and the astronaut are in free fall. Now, what does free fall mean? It basically means when the only force acting on the satellite and the man is the force of gravity, and no, they don't have any other external acceleration. They only have the acceleration due to gravity. So in this condition, they experience something known as free fall. But you might say that since they are in free fall, why are they not falling on the earth? But that happens because even though they are experiencing free fall, there is a horizontal velocity component which keeps the satellite moving in a circular orbit. Then we have the shell theorem. It means that a uniform spherical shell attracts an external mass as if all its mass were at the center. This you can correlate this with the electrostatic potential formula also. Like for a uniform spherical shell, the charge, if there is a charge on its surface, it attracts the charge as if all the charge was concentrated at the center. So you can correlate this with that. And the second shell theorem states that the gravitational field inside a uniform spherical shell is zero. Inertial was and the inertial mass and the gravitational mass are experimentally equal. G is universal and constant, and small g varies with place. So don't get confused between capital G and small g. Capital G is constant, G varies, small g. Gravitation is always attractive. There is no repulsive gravitation force. It is always attractive. And the moon has no atmosphere because its escape speed is much lower than the Earth's. So these are just some points that it's good to remember. Now let's come to the questions. So a satellite is moving in a circular orbit of radius r around Earth. Its orbital speed is v. If satellite is moved to another orbit of radius 4r, then the new orbital speed will be. This is also pretty simple like the previous questions. You have been given an orbital speed v, small v. And if the satellite is moved to another orbit of radius 4r, so let's go back to the formula for orbital speed. So the orbital speed or the orbital velocity is given by this formula. They are basically changing the radius. So when you are changing the radius, what will change with the velocity that you have to calculate? So basically r is becoming 4r, then the new orbital speed will be so in this also you have to substitute in the formula and compare with the original formula. Then a satellite of mass m is revolving around Earth in a circular orbit. If its orbital radius is double, then the ratio of its initial kinetic energy to final kinetic energy. Again, in this also you have to use the kinetic energy formula. Here. So here the radius is 2r, you have to double it. So what will be the impact on k? You will have to find a ratio. Initial to final, it will be 1 is to 2 is to 1, since they are inversely proportional. Okay, so in this, from this chapter, you will mainly get comparison questions, and you have to just remember the formula for each thing. So here is the formula summary. For gravitation, vector form, acceleration, g at a height and g at a depth. Then you also have universal gravity, same thing, and g at a height and g at a depth. For kinetic energy, potential energy, basically all the formulas you just have to remember, and you will get a lot of comparison questions like what if I double the radius, what if I triple the radius, like the ones that we similarly solved. So you main focus should be on the formulas. So is this chapter clear to everyone?